Hi everyone, I welcome you all to the live session on Python full course by Intellipaat. This session is conducted by multiple experts who will be teaching you all about Python from basic to advanced level. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Python. Then after that, we will see how to install Python on Windows. Then later on, we will be teaching you all the basics of Python like variables, tokens, operators and lot more. Post that, we will learn a bit more advanced topic like NumPy, classes and objects, Lambda functions and etc. Then later on, we will see exception handling in Python. Then after that, we will be seeing how to use PyCharm. Post that, we will be learning about Python text mining. Then after that, we will learn about sentimental analysis in Python. Then later on, we'll be doing very interesting hands-on demo and projects like Pygame and credit card fraud detection. Then lastly, we'll be covering Python interview questions and answers. So, this session is going to be very interesting. Stay tuned and watch the video till the end. Now, let's begin the session.
What is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C# or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century. And basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this, and Python is open source, if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver-client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, The first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. We've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. There are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much probably equivalents to putting out an output which gives out hello world. You can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, basically Apple's operating system, and you can use any of your favorite operating systems. In fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the #1 language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. And of course, coming to artificial intelligence. Well, ladies and gentlemen, I know you guys might be waiting for this at this point of time. Hey, what about data science? What about artificial intelligence? And much more? Well, here it is. You must learn Python today because Python is one of the most preferred language in today's world to help achieve artificial intelligence. So where is artificial intelligence implemented? Well, look around you, look at your smartphone, everything from Siri, Alexa, all the way to Google Maps, Amazon. I can go on naming thousands of applications of artificial intelligence which has been so subtly integrated into your life. You have to even understand and contemplate to see if something's AI or not anymore. That's how well it's all been implemented. So on that note, there is a 44% enhancement when you put artificial intelligence and help with the current products which are already existing. And AI will of course optimize all of the internal operations in an organization by up to 42%. AI will help make better decisions, and of course AI will help pretty much optimize all of the external operations which take place. And this is a very important point because you can see a 31% increase there. And of course workers will be free enough to make sure that they spend their time, their efficiency, and much more to actually be creative instead of doing some redundant tasks. Well, now where does Python come in? Well, you need to understand that Python gives you a very efficient way to work with data. And when you're working with artificial intelligence, it is of course in no doubt that you'll be working with a lot of data. To ensure that you can handle all of this data with ease, Python has got us covered. And then let's talk about the library ecosystem of Python. Python has an extensively huge library system, and pretty much we're going to discuss about the libraries as well. But then at this point of time, you need to understand that all these libraries which are pretty much given to the developers, the frameworks or whatever it is, all of this is helping us get closer to making artificial intelligence more intelligent, if you know what I mean. And of course, it gives us beautiful visualization tools, and compared to any other program programming language. There are languages like R as well, of course, which are on the boom right now. Python is again another standard when it comes to using visualization tools. And again, this, in my opinion, forms a very important reason for you guys to jump on this, because as a learner, as a developer, as a person solving a problem in your company, you will require an efficient way to process the data. You will require a large ecosystem. You will require very good visualization tools. And at the end of it, there is something even more important, is community support. Since Python is an open source language, it is the number one programming language. Again, thousands of people pretty much start out with Python and learn Python on a daily basis, help each other solve the problems as well. In fact, we have the Intellipaat community where we actually cover Python as well. We cover all of the IT related concepts in depth in the community section, where we have people from across the world coming in to help each other's problems out. So make sure you check out Intellipaat's community after the session, ladies and gentlemen. And coming to the next point, Python has another strong footing in today's world. As you can see from the title, it is web development. Python provides us with so many nice frameworks to work with. Everything from Django, we have Flasks, we have Pylons, and we have Web2Py. Basically, all of these are tools to ensure that Python as a programming language can help in web development. The introduction I gave you to Python said Python is used for web development and app development. Well, you can see all of the beautiful libraries that Python provides us for web development on your screen right now. Django is amazing to work with. Flask, again, if learned, you can create very beautiful applications using that. Pylons, of course, and at the end of the day, even Web2Py as well. Well, at this point of time, my goal is not to overwhelm you guys telling you all about what Python is and what Python is offering us. Well, I'm trying to tell you the potential of Python, ladies and gentlemen, and I know that it is amazing as well. Coming to big data, of course, the entire world is a big data problem. Look around you. There is terabytes worth of data being generated every single second. We upload a picture to Facebook, we upload a picture to Instagram, we might sing and put something out on SoundCloud or whatever it is. You're putting in a lot of data out there on the internet, and it's just not you, it's the entire world population, a majority of the population who make use of all of these apps. So when you're looking at that, pretty much there is a lot of data being generated. And how does Python help? Well, as I mentioned, Python is amazingly easy to work with. It is all because of the libraries and all the support it gets. See, for example, from Apache Foundation, we have Apache Spark, and we have tools such as Dask and PyDo, which basically help in giving Python the access to basically go on to make use of parallel computing. With parallel computing, you can solve big data problems by breaking down a problem into simple sub pieces, assign it across multiple computers, and have these multiple machines, multiple nodes as we call it, solve the problem for you, and do it in such a way that there is no strain on one single machine doing it, of course. And that's not the only reason. If you're dividing the load among hundreds of computers across a server, 1,000 computers for example, you have that much of power, 1,000 times of power, 100 times of power, whatever it is, to give it to you in the most simple terms, ladies and gentlemen. So handling big data with Python is a breeze, and companies are looking out for all of these, and they want you as a big data expert there. So if you want to become a big data expert, you need to understand all of these concepts, and to understand all of these concepts, you need to first set across a programming language through which you're going to work, and use all of these frameworks that come with it and go on to make use of it, right? So basically that is exactly what I'm trying to tell you guys here. When you hone in on a particular language such as Python, you have all of these beautiful frameworks to work with at the same time. Then coming to data science, of course, I've put in a fire emoji out there to tell you that data science has been on fire all of 21st century. Data science is pretty much booming right now. And in fact, guys, if you do not know, data science is being actively used right now to fight the outbreak of the coronavirus, which is spread across the world. And we have an entirely in-depth session covering basically on how machine learning and other technologies can actually be used to help fight the coronavirus, or COVID-19 as it's called as well. So make sure you check it out after this session. And of course, coming to why you should learn Python in terms of the data science aspect, well, again, it provides amazing libraries to work with here as well. For numerical computation, we have these two beautiful libraries. It's Pandas and NumPy. Both help in amazing numerical computation. And when you're working with a lot of numbers, when you're working with data frames, data sets, whatever it is, these will ensure that the same level of readability is met, and that of course you can efficiently handle all the data with ease. And then coming to data visualization, ladies and gentlemen, we have Seaborn and Matplotlib. These two are very famous tools which are basically used to perform data visualization when we're talking about data science, when you're talking about Python, and when we're talking about solving most of the data cases of today as well. Well, as I mentioned it before, let me strengthen it again. Python is the number one programming language out there as of now for data science, and if you are capable of handling numerical computation, and if you can understand and produce very good data visualization methodologies, of course you are preferred by all of the top hiring companies out there. And this brings us to all the skills that is actually needed when you're working with Python, when you have to begin working with Python, or even general aspects of a programming language such as Python. So the first skill that you will require is object relational mapping, or ORM as it's called in short. Basically, ORM is used to create virtual databases where there is a data which cannot be converted into another type, or if you want to perform some analysis on a data which is present amongst huge amounts of data, well, ORM is the tool to go to. When you're working with Python, there is SQL Alchemy and there is Django ORM, which will basically help you achieve this goal. And it's as simple as that. Coming to skill number two. Skill number two is basically all the front-end technologies that you might be working on in case if you're looking at the web development aspect of Python. It is a must-have that you understand certain tools like HTML5. It can be, pretty much JavaScript. It can be CSS3, cascading style sheets, of course. And there are many other things which you might have and need in your arsenal to go on to become a very good web developer if you're working with Python as well. But then do understand that it is not always the tools which come into the picture. You, at the end of the day, if you're working with front-end technologies by making use of Python at the same time, you will be creating a very good user experience the person who's going to be watching your website. And at the end of the day, to keep it very structured, you will have a program manager who will overlook all of these, and it is going to be a very structured process of how you'll be going through the same as well. And of course, you will have a scrum master at the end of the day to bring all of these together to ensure that when you're working with a website or a web application, that everything goes smoothly and as the way that it's initially planned as well. So if you're working with front-end technologies and you want to go on to become a web developer using Python, make sure to keep all of this in mind. And of course, coming to the third skill, it's basically all the Python libraries that you have to know which exist. Everything from requests, beautiful soup, we have Pygame, we have Scrappy. So basically from web scraping all the way till building your own games using Python, Python has it all. But the most important aspect of Python, as we've been talking for a while now, is Python for the use in machine learning, Python for the use in data science, and Python to achieve artificial intelligence at the end of the day. So there are some amazing libraries and frameworks here. There's TensorFlow, Keras, there's Spark, again NumPy, PyTorch, MXNet, Panda, Scikit-learn, and many other Python libraries which will basically help you to pick up one which you like and what you would work with, and at the end of the day, what problem are you trying to solve. So Python will give you a choice of 250 plus libraries where you can pick up one, become a master in it, and pretty much go on to have a successful career as a Python developer at the end of the day. Because there are experts who are wanted for Keras, there are experts who are wanted for TensorFlow, there are experts who are wanted for as Django developers, Pygame for game developers, and there is much more. So you need to understand that all of this are trending. All these are among the top libraries for any programming language in the world right now, and that is how much Python's libraries have all blown up. So make sure you jump on this and make the best use out of it. The skill number 4 that you need to understand is basically version control systems. So basically Git is among the world's most famous version control system out there, and pretty much this will help you not just as a Python developer but as a programmer in general, because when you're working with Git, there is a lot of structured process which basically happens. It ensures that there is no confusion when multiple people are working on the file, and for example, a file which is already committed and deployed. So basically when a file has been deployed and committed in a separate branch, well, let's say call it the development branch, or call it the branch where the data is actually the data which is all live on the website or whatever it is, well, this data you're not messing up for testing purposes, or you're not working on it actively, which might actually cause real-time changes to your website. So making use of Git will not only help you with Python, it will help you with all the other programming languages, by helping you stage your content, by helping you track your commits, and to ensure that if there is modifications needed and modifications done, who has done the modifications to what branch at what point of time, and you can even leave comments to the modifications done as well. So this will keep the entire concept of programming and bring it into a world of structure and give it some foundation foundation where there is no confusions, there is no anomalies, and basically no mix up when there is more than one developer working on something at the same time. So this brings us to skill number 5. Skill number 5 is very important. It's artificial intelligence and machine learning. Why do we keep mentioning so much? Again, as I mentioned, it is the preferred language for AI and ML. It gives you multiple libraries out there. Everything from working with neural networks, working with machine learning, working with deep learning, and as I've mentioned, all the things that follow in these concepts as well. For example, in neural networks, you have convolutional neural networks, you have recurrent neural networks, you have concepts such as autoencoders, you can perform time series analysis. So all these fancy terms and concepts, they might sound fancy and they might sound convoluted at this point of time, but they are the foundation of what makes Python a beautiful language to work with. And basically, they're so easy to learn. All you need is a structured process. All you need is the right hands-on, the right instructors, and pretty much the right content to help you master a language such as Python. And of course, this brings us to the 6th skill, which is communication. This is the most important skill if you're looking to build a very serious career in Python. Well, why do I say that? Because, ladies and gentlemen, let us be very honest here. If you're working for an organization as a Python developer, there are chances that you will be working in a team and you will not be doing everything solo. If that is the case, you need to work amongst your team. You need to work among multiple other teams. See, for example, if you're a web developer or a data scientist for that matter, you'll be working with the data ingestion team in the morning. You can be performing analysis, writing neural network models in the afternoon, and at the end of the day, you might be creating very good visualization by using multiple tools out there, Matplotlib or whatever it is, and you can be presenting all this information to a non-technical audience. You as a programmer will understand all of these concepts because probably you've been working on it, you're trained on it, you're certified on it, and whatnot. When you're explaining all of this to a person who might not know it, there lies a small challenge. So communication plays a very important key, not just when you're becoming a developer in Python, but then when you're becoming a developer in general, ladies and gentlemen. So on that note, what are some of the key takeaways that you can pretty much notice at this point of time? The first thing that I can tell you is if you are willing to take up Python seriously, or if you want to understand why you should pick up Python, first check if you have the problem solving skills, if you have an interest towards solving problems, because Python at the end of the day can of course be used for recreational programming. It can be used even for competitive programming as well, and most of the time it is basically used when the problem statement comes up and how you can use a programming language to solve that problem. So make sure you ask yourself if you have the intent, if you have the interest to solve problems. And then programming, of course, since Python is a programming language, one of the top in the world, you need to make sure that your game is up when you're working with programming, and when you're working with a language such as Python, this is very important, ladies and gentlemen. The next point is communication. As I mentioned, communication is very important. It is key. And when you have to check out how much there is to learn, pretty much I hope you guys were not overwhelmed with all that was shown on your screen, because again, 250 plus libraries, as I mentioned, is a lot. And you might be wondering, do I need to learn all the libraries? Well, no, you just need to start by being eager, by being curious, by checking out what Python offers. What do you like with respect to the language? What do you like to do? And how can Python help you get to your goal? It is as simple as this. Ask yourself these 4 questions, and pretty much this will help you to the maximum. So on that note, let us quickly check out a demo. I'll be showing you how elegant it is to work with Python by picking up a problem and solving it using machine learning as well. So guys, the point of this demo is to ensure that you guys get to understand how easy it is to work with Python. Of course, we can work on a very complex data set, we can work on a very complex demo basically, and the point is to not overwhelm you. The point here is to ensure that you get a clear understanding with respect to Python, with respect to its usage, and all of us basically like less code to achieve maximum efficiency and to solve the problem, right? So nobody wants to write 10,000 lines of code if it can be done in say 2,000 lines of code, and that exactly is your takeaway after going through the demo session, ladies and gentlemen. So basically, we're going to try to predict to see if a person has diabetes or not, or check the onset of diabetes basically by making use of machine learning with Python. Even before we begin, as I mentioned, Python and machine learning has been amazing. You have multiple libraries here. You have one amazing library to work with machine learning, and that's scikit-learn. Scikit-learn is pretty much used 99% of the time when you're working with machine learning, or you have a requirement where there's a problem and you have to solve it. So let's go on to understand and check how we can basically make use of machine learning to solve the problem for us. So basically, let us go on to check what is the accuracy of detecting the presence of diabetes. Diabetes is again a rising concern in my opinion. be it a country like India, be it a country like USA, or let's say anywhere across the world, diabetes is a very deadly disease, right? Pretty much it is the condition where your body cannot maintain the blood sugar, and this will cause a lot of havoc if you're not diagnosed and if you're not prepared for it, or if you've been ignoring it for a while. So at the end of the day, it is basically your job to ensure to see how you can bring the world of computing and medicine together. See, medicine is a field where it's thriving on its own, and pretty much, it can do really, really well with or without the help of computing. Let's be honest. That is how it was for the last 100 years or so. The field of medicine has been grown exponentially. Coming to today's world, medicine alongside data science, medicine alongside the power of computing, it has stepped up the game of medicines to another level. And I'm sure over 70% of the doctors are going to agree to this, because again, to give you another case, in 2019, pretty much data science helped the doctors figure out the onset of early breast cancer in all the patients, and it sort of gave away a probability of 55 or 56% of detection. Ladies and gentlemen, we're talking about cancer where 1 or 2% can be can add a lot of things to your life, and it can take away your life as well. When you're thinking of numbers at that scale, you need to understand a 55% of probability to a patient saying that, hey, you have malignant cells in your system which might hurt you, or you have benign cells, they are not cancerous, they'll not hurt you, and all of this, giving this hope to a patient and then proving it with respect to validation. That, in my opinion, is very, very important usage of computers with the field of medicine, ladies and gentlemen. So without further ado, let's quickly jump in to understand how we can go on to predict diabetes with the help of machine learning. And the step one of any programming language, the step one of any problem statement is to understand the problem statement. And as the problem statement that I have mentioned, we need to go on to see how we can make the computer understand that, right? That's the point. Well, let's begin. Well, step one is to basically, import all of the libraries that you'll actually be using. So it is a common programming practice to all the beginners who might be watching this session that you import all the packages that you think you will require at the starting part of it, so you don't have to keep doing it at every point of time. So the step one is pretty much very important, where we're importing all the packages such as pandas and numpy for data handling and numerical computation. As I mentioned at the start of the session, we'll be using Seaborn and Matplotlib as well to show you some very good visualizations. Scikit-learn, which is a very important part of machine learning, as it poses to be one of the top libraries, as I mentioned. And of course, there is one single line, since we're using Google Colab out here. Google Colab is basically a Python Jupyter notebook, you basically hosted on the cloud. So we have another thing, we're importing basically files which will help us upload files and help Google Colab talk to our dataset as well. So after importing all of the Python libraries, we need to go on to actually load the dataset. So loading the dataset is basically the operation of inputting our files which we'll be using. In our case, we're going to be using a diabetes prediction dataset. So let me quickly go on to import it. So basically using files.upload, it'll give us a very, very easy way to go on to upload these files. And as you can see, the file has been uploaded, and our dataset is there. So your question will be, what does the dataset look like? Well, can you talk to us a little bit about the dataset? Well, of course, ladies and gentlemen, you have multiple aspects of this dataset. And as I mentioned at the start of this project, basically this dataset is a very simple dataset. It does not require a lot of cleaning. Data cleaning forms a very important aspect of working with machine learning, working with Python, and this dataset is pretty much a simple one. So quickly going through all of the features that we have the pregnancies column, which basically describes if a person has had a pregnancy and if the person has been pregnant before, and the number basically indicates how many times the person actually became pregnant. And glucose will basically give you the glucose level on what was tested at that point of time. Blood pressure, again, as we call it as BP, is basically the diastolic blood pressure which was measured at that point of time. And again, we have the skin thickness, which is very important to understand the levels of fat. Again, the levels of insulin is basically generated by the human body, and it helps regulate sugar levels, and it can be picked up from a serum test as well. Coming to BMI is basically body mass index, and an average of 25 BMI is considered to be a healthy person. Anything less than that, you might be undernourished, and anything above that, you might be considered obese as well. And then we have the diabetes pedigree function, which will basically tell you if there was an onset of diabetes in your family, because diabetes is something which is hereditary, as you might have read on the internet by now. So this basically will give us an understanding to see if it ran in your history, to see if it ran in the family history before. And then coming to age of course gives the age of the person, and the outcome. The outcome is to basically check if the person is basically predicted to either have diabetes or not. 1 indicates the person is predicted to have diabetes, and 0 is the outcome where we detect that the person has not had diabetes in their life. before. And then of course, coming to description of the data set, let us actually go on to use some concepts of descriptive statistics here. So descriptive statistics is very simple. We're going to be analyzing data using statistics, everything from the count of occurrence of that, what is the mean of all the values in the columns, what is the standard deviation, what is the minimum value of occurrence, what is the maximum value of occurrence, and of course you can go on to check the 25%, 50%, and the 75%. It's called as the IQR, interquartile ranges of all the data as well. See, some data might not make sense. Let me point out something really quick. Insulin will never be zero in the body. BMI can never be zero in the body, and you can see that there are minimum values here. And as I mentioned, you can go on to perform complex analysis to remove all of these values to pretty much ensure that they won't hurt your data later. Well, why do I say this? Because data cleaning is probably the most vital step for a data scientist out there, and data cleaning is very, very important when it comes to basically telling your model to give out accurate results, and basically it'll help your model learn better as well.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And this, of course, brings us to step number 3. Step number 3 is where you'll be splitting your dataset into two. We call it the testing dataset and we call it the training dataset. Why do we do this? Well, we need to train the model based on some data and later verify it to see if it has learned something or how accurate that it has learned, right? So basically here, we make sure that, we split the data into a training data set. We basically split the data into a testing data set, and we can go on to perform analysis further. And the most important thing is that you need to go on to distribute it, and not just basically pick up the data. Hey, first 10 columns and the first 10 rows of these columns, let's split it into the training. Remaining, let's go to the testing data set. Well, no, we can actually go on to randomize all of this and distribute it with respect to the testing data set and the training data set. Well, this is basically done to ensure we can add some sort of randomness to our testing and our training data sets at the end of the day. And ladies and gentlemen, welcome to step number 4. Step number 4 is where all the magic is happening. Here is where machine learning is coming into the picture. So basically we're using something called as GSCV for performing evaluation to see if a model can learn something and understand something. What is GSCV, you might be asking? GSCV is basically one of the amazing techniques. It's called as grid search cross validation, and this technique is used to understand what parameter can be used best, and how you can go on to evaluate what parameter will give you the best results at the end of the day. So you might be wondering, can I use just body mass index to check if a person is diabetic? Can I just check out using blood pressure to see if this person has diabetes or not? Well, with respect to grid search cross validation, your data, since it's being split into the test case and the training case, you can basically go on to tell your model to effectively use this validation case, which is basically the test case, against your training case to make sure that your model has learned well. You can go on to use multiple other things as well. There's something called as k-fold validation as well. With respect to k-fold, your testing data set is broken down into small chunks, and basically it is n folds times which is run across the training data set. What I mean by that, k is the number of times you want to run your testing data sets across the training data set. Well, again, not getting into all the details to basically overwhelm you again. To keep it simple, here we'll be using cross validation, and by making use of the gradient boosting classifier, we can ensure to find and evaluate what are the best parameters and how we can go on to use them to accurately detect the onset of diabetes. So let me quickly run this, and ladies and gentlemen, as you might know, this is the process where the machine is actually learning, and it's performing analysis by going through all of the data. And this is very important to know that this might take a small amount of time. I am thinking in my case this might take about 2 or 3 minutes, so we'll be back as soon as we get the results. So as you can see, that took about 3 to 5 minutes, I would say, and pretty much you can see by making use of grid search, we can get to a number where we can understand the accuracy of learning. But then we can go on to improve all of these. There are concepts such as hyperparameter tuning and everything, which I will not explain in detail. Again, we have in-depth videos just to understand hyperparameter tuning. We have in-depth blogs as well. So pretty much, you can go on to learn. And if most of you are beginners, or if you're looking as enthusiasts or learners of an intermediate level, you might not go on to understand it completely as well. So at the end of the day, we have a prediction here, and the first step you need to do when you have a prediction is basically store the prediction. We can put it in a variable and store it, and after pretty much storing the prediction, what you have to do is you need to see it. Just seeing it as numbers will not make sense, so let's go on to use graphs, and let's pretty much plot the frequencies against the predicted probabilities. And pretty much, as you can see on the screen, the predicted probabilities versus the direct frequency of occurrence, and pretty much can help you with the presence of diabetes or not easily as well. And hey guys, there's a quick fact, pretty much that says that the human brain can comprehend images 3000 times faster than numbers. And pretty much I do believe in that concept as well, because when I see graphs, basically I understand it better. And coming to step number six is basically now using different variety of classifiers to understand, what gives you the best result, what gives you the most accurate results as well. So by making use of gradient boosting classifier, we've got an 85.2% accuracy. What about the concepts such as a random forest classifier? Again, these are different methodologies which again come from scikit-learn, and pretty much which will help you understand it. Well, as you can see on your screen, with respect to random forest classification, we have a 78% of accuracy in detection. What about XGBoost? With respect to XGBoost, whoa, we have almost 80%, 79.6% of accuracy in detection. This might put up a thought in your mind saying, hey, why are we looking at multiple classifiers? Why can't we use the best one to be done with it? Well, ladies and gentlemen, with respect to machine learning, that is not the case. One classifier might not be the best for all the use cases out there. So what we try to do is we put in the other classifiers out there. We make use of 5 or 6, in fact more than that, 7 or 8, to basically understand what will give out the best results and what will basically help the machine understand the concept better and give out more accurate results. Because at the end of the day, we're looking out for the most accurate results we can get our hands on, and that is one of the reasons why we go on to use multiple classifiers as well. So you might be wondering, what can we do any further with this project? Can it be built better? Well, of course, you can perform a lot of data cleaning for that matter, and pretty much you can go on to use many other classifiers as well. You can use k-nearest neighbors algorithm, which is basically KNN. You can use concepts of perceptron. You can make use of the concepts of decision trees and many other methodologies to check their performances, see what gives you the better performance. And in my opinion, gradient boosting, random forest, and XGBoost pretty much gave us high numbers of accuracy for this particular case, and I thought it was fitting enough to show you guys this. Well, as you can see, it is pretty much very easy to go on to work with machine learning with respect to Python.
Now let's take a look at the features that will be available in 2021 in Python. Python is very frequently updated, so new features are going to be available with every new version, and old features are going to be deprecated in every new version. So we recommend you take a look at the new feature list in Python whenever new version releases. So Python will have several features added to it in 2021. So one of those features is bit count, then there's strict zipping, and then there's the read-only proxy of dictionaries. In case this seems a little overwhelming, don't worry about it. Stick with us till the end, and we'll guide you through some of the resources through which you can learn these things. In case you wish to be notified about more content like this, click on the subscribe button and click on the like button so that you get notified of new videos that we create on these topics. In case you have suggestions for us to cover any other topic, put them into the question box or put them into the comment section down below, and we'll help you out with that as well. So now let's discuss these features one by one. Firstly, it's bit count. So as we know that computers don't really understand the source code that we write. To it, it's just a large blob of text. It's the job of the interpreter or the compiler to convert the code that we write into machine code. Machine instructions are at their very basic level written in binary. Binary is a number system which works with either 0 or 1, and it has a binary digit system. Binary digits in short are called bit. So if you ever hear 1 bit or 2 bit information, you mean there are 2 binary digits that represent the information. Both of them could either be 0 or 1. Now the bit count function is there so that you can count the number of ones in a binary format of a number or a string or whatever. So once that code is getting compiled and the value that you have is compiled, what will be the number of bits or ones in the entire string? Don't worry if you don't understand it. We'll take a look at that in the hands-on section as well so that you can get a better understanding. Then comes strict zipping. In case you have not heard of zipping before, you might not have used Python that much because zipping is by far one of the most common things that has happened. So zipping basically allows you to create a tuple out of two lists. If you have two lists with different values and you want to create tuples of the same indexes, you use the zip function. Strict zipping basically means that if the lists that you are providing to zip are of different lengths, you will get an error. Before this, what you would have to do is you would have to check them manually and say, okay, this is not working. You have given us different length of lists to zip, and we can't process this list. And then you move ahead. But this was a check that you have to do on your own, and sometimes you'd forget. So in Python, they have added this new feature in which when you create a dictionary, when you create a zipped version of two lists, you will have to provide lists of same length. If not, then you will run into an error. And we'll take a look at that as well. Finally, there are the read-only proxies of dictionaries. So in dictionaries, many times we want to create a read-only version of the dictionary. Now there are ways you can do that, but it's difficult to create a read-only version of a dictionary right at the beginning. So in order to use it correctly, we will have to use the newer versions of Python because they come with a feature set that allows us to do that. And we'll take a look at that as well. So let's get started right from the beginning and let's have a hands-on in which we understand all of this. So let's get started. Now for the hands-on, you would have to install Python. So let me just show you. You have to go to this programming python.org website. Here you can download the newest version of Python, and if you want to follow along, you can do that here. The code you write here is going to be interpreted in Python 3.9, and we want to use the latest pre-release version. So go to the download section, click on the operating system that you want to use it for. I will be using Windows. If you're on Mac, you can use it here. If you have some other platform like Linux, you can click here. So I go to Windows, it opens it up, and it shows us look into this section which is on the right hand side. It's called the pre-release section. The stable releases are the versions that have been checked and all the bugs have been removed that were reported while the software was being developed. On the other hand, in the pre-release section, we might have some bugs, but you can try out the new features as well. So you can go here in Python 3.10.0. Before that, you would get Python 3.8.7 release candidate 1. But we want this to be the one. It was released on 7th of December 2020, so not too long ago, and you can download the installer here. If you want the help file, it's available. If you want the embeddable package, it's available as well. Choose the architecture correctly, install it, and you will be good to go. I have it installed and running, so I'll just show you what it allows us to do, right? So the first thing that we have to take a look at is something that we refer to as a bit count. So let me just show you. So I will create a number and I will save it inside X. Let's call it 108. Take a look at 108 and we have the value embedded in a variable X. Now, if I want to take a look at its binary representation, I have to use the function bin. This has been available for a long time. This is not Python's current version. As you can see, we have 1, 2, 3, 4 bits. So if I want to check how many ones are there, all I have to do is type bit count, press enter, and I get 4. If you are using some other version, as you can see, this is Python 3.10.0 A3. A3 is the third alpha version. If you're using older versions of Python such as 3.9, you might run into an error saying numbers don't have a property or a method named x.bit count. So in that case, you would have to upgrade. So this is how it happens. Now, if I were to change x to be equal to -108. Now, if I were to go back, take a look at the binary representation. It's the same thing, but I have a negative symbol added at the beginning to show me that it's a negative number. If I take a look at the bit count again, I get 4. So the number of binary numbers that are 1 here is the same. There's 3 zeros and there's 4 ones. So that's one way you can do it. So how does it work? Well, in a very basic sense, the way it works is what you do is you calculate the binary number, it returns a string, and here what you can do is you can just count the occurrence of 1. This should return the same thing, which is 4. So in case you're using older versions of Python, you can just create a function on your own, call it bit count, so just call it def bit count, get a number, and here all you have to do is return the binary representation of x and then count 1 in it, right? So if I go bit count 108, you get the same thing. So if you're using older versions of Python and you want to use this feature, this is available for you to use it this way. All right, now let's take a look at zipping. Again, for those of you who are unaware of how zips work, let me just show you. I'll just scroll down a bit. Create a zipped version. I need to create two lists. I'll call them A. A is going to contain, I'm going to call it small a. Now I'm going to create few things here. I'll call them names. So John, Jane, Jenny, and Johnny. So we have a list. I'll create another list. This will be called three things. We'll call it the number of the percentage that they acquired. So let's say 88, 44, and 98. So I will only keep three here as of now. Let me just add one on another to show you how this works. And 77. So I have two lists, A and B. I want to create a tuple of these two values, these two values, these two values, and these two values. The code I would have to write for this is going to be a little cumbersome, but since Python provides me with the zipping feature, all I have to do is pass in A and B, and it returns a zip object. If I want to create a list of the tuples, I can do so as well. It's going to be list. There you are. John has 88 percentages, Jane has 44%, Jenny has 98%, and Johnny has 77. As you can see, the corresponding values are being used. But suppose instead of B being this, I change the size. Now it's the length of A is 4, length of B 3, and length of B is equals to length of A. We are going to get false. But if I try to create a new list of zip and A, then I get only three values. So that's the thing that you have to understand when you're trying to use zipping. One of the values get removed from this. So this is how it works. But if I want to be a little strict here, I can pass in a parameter in the zipping function, and I'll call strict is equals to true. Now I have passed in. So argument 2 is shorter than argument 1. So I have both the features. Earlier this feature was not available, and passing strict is equals to 2 was going to raise an error that it doesn't understand what strict means. But now since I have two lists that are of different lengths, if I want to opt in for stricter versions of zipping, then I can do so. The reason why this was added, strict true, was because to make it backwards compatible, so that other code that used the older syntax in which different lengths would be accommodated for, in cases like this, they would not want to break the older code but just want to add a new feature, and that's the way they chose to go with it. In case we were doing this, then we would have to just create another function, call it strict underscore zip, passing A and B, def stri strict zip A and B, and then I have to just check if length of A is not equal to length of B, then I have to raise an error or something like that. So I could do it like this, or I can, here I have to use the word except and throw a new exception. Now that's possible, but I won't be doing that. So that's how you can do the new zipping feature. Finally, the third thing that we have to do is take a look at the dictionary. So let me just show you how that works. First things first, I have to create a dictionary. Now again, the same way I did earlier, I had two lists. I'll create a dictionary out of those. So if I pass in dict with A and B, I think yeah, so because they are of different lengths, it's not going to work. So let me just take a look at that. I'll just create a dictionary easily. Jane had 88%, John had 44%, Jenny had 87%, and Johnny had 98%. So let me just store it inside this is a dictionary that I have, but right now I can change the values if I want to, whether knowingly or unknowingly. So for instance, Instead of John having 44, I can just make it up to be 77, and it works the same. Now the dictionary has been updated, and it could be a problem if you are someone who doesn't want to change that. So that's the way you can do that. But if you want to extract these things, let's take a look at that first. So first of all, let's take a look at how you can extract the keys. So d dot keys, and this is how you get. For values, you just have to type in d dot values, and you get the values. So these are two different types, dict keys and dict values. So after getting these things, if I want to create a read-only proxy of the original dictionary, all I can do is just create a new dictionary. I'll call it d dot mappings, and it's getting me an error because I have to do it on values. So let me just do it here. values, and then do it. Oh, and it's mapping, not mappings. Sorry about that. If I press enter, this is a mapping proxy. So if I want, I can just take a look at how much did Jane get. It's 88. How much did John get? It's 77. If I want to delete, I can't do it because mapping proxy does not support item deletion. So I can't delete the items out of it. So that's the way this works. Again, these are not fit for being used in production. So we recommend that you don't use them in production. Just use them where you can. Just try them out and see if this works.
What chatbots actually are. So as the name suggests, chat and bot has something to do with a robot imitating a person, while chatting to another person. So when we have to break it down into a little bit of simple terminology, basically it's a software which is based on artificial intelligence, and this software will try to imitate humans. It'll try to basically, perform the same actions as us human beings without the person, having a very good idea if they're talking to a human being or an AI. If your chatbot is very good, if the chatbot which is being implemented is amazing, well, the human can be fooled enough to not know if they're talking to a robot or if they're not talking to a human as well. And most of the time, you wouldn't even require that kind of a complexity, because let's say when you're in the Amazon case as well, where is my order, or why is my payment declined, or whatever it is, you will have a very simple question to which there will exist a straightforward answer, right? So it'll not like Amazon's chatbot will start telling you stories about why your payment failed or why your order didn't come or whatever. So when it comes to that, if it is very subtly implemented, if it is very complex in the back end, you will not find a difference between it being a robot or it being a human being as well. Way back in the 70s and the 60s, there was a test which was very famously implemented across the world. It's called as the Turing test. If you guys didn't know on that, make sure you read up on the Turing test. It was amazing on how artificial intelligence is such an old concept, but it's being used a lot in the 21st century. So whenever you think about artificial intelligence, ladies and gentlemen, the first couple of things that should come into your mind is, for example, Siri of Apple, Alexa of Amazon, or the Google Assistant. These chatbots again have been in our lives most of the time, right? For all the Apple users, you guys have Siri. For Amazon, we have Alexa, and for the Android phone mobile users, we have the Google Assistant. So you might have been using these on a daily basis, because one for sure, I use Siri a lot and I use Google Assistant a lot as well. And I do know people who use Alexa for their home automations and much more. So when it comes to stuff like this, from the simple Amazon chatbot all the way till a complex powered bot such as Siri, Alexa, or Google Assistant have been helping us daily. So in fact, you can ask the Google Assistant or Siri to play any song for you. And in fact, let's say you're sitting at a restaurant or something, you listen to a beautiful song that's being played, and you just want to find out what song it is. Instead of going through all the pain of installing a software which will listen to the song and tell you what song it is, or you asking the restaurant manager what song it is, just pop out your phone, say, hey Siri, what song is playing in the background. Siri, or in fact even Google Assistant, will actually analyze the song, it'll listen to it, and it'll tell you, hey, this is the song that's being played. How simple is that? For example, you want to set a calendar invite for the next month, or let's say you have a meeting which you want a reminder for, you want to set an alarm. So all these manual tasks which you could do basically with one voice command, you can get all of it done very simply. And I think that's the essence of chatbots, ladies and gentlemen. So again, coming to emphasize on why we require chatbots, well, when you look at it, the first thing, it's cost and time effective for the companies, because developing a chatbot does not take a lot of money, and it makes sure that it can be done in a quick and a rapid way. As you'll see in the demo which I'll be showing at the end of the session, it will basically validate this point on how time effective it can be when we are working with chatbots, because it's pretty simple, it's pretty straightforward, and at the end of the day, even when you're working on an enterprise level, basically you're working at a level where you have a huge organization which requires a chatbot, it will not really cost much to build it as well. And of course, adding on to the last point itself, coming to the second point, it's cheap development cost. When you're working with chatbots, you need to understand that there are only certain things at this point of time that we can do with chatbots. Of course, with every passing day when we're talking about technology, there are again thousands and thousands of things which keep coming into the market. But with chatbots, you can have it respond, you can have it imitate a human to the best of its ability, right? And with the current power of AI, I think the entire world is pretty much just trying to make sure that their chatbots are as human as possible. So with cheap development costs, there are again a lot of companies which are jumping on the need of chatbots as well. So how would it help the companies, you might be asking? And the best thing is human resource. See, if you have a person who is responding to live chat, which is basically a mundane task, right? They keep doing it again and again and again. So this person as a human resource can probably put into a more effective role. This person can be put into a more productive role rather than answering the queries of customers, which can easily be done with the help of chatbots, right? So it's saving time, it's saving money, and pretty much it's increasing the productivity of the company as well. This is the primary reasons why thousands of companies across the world today have implemented chatbots. And the next point again adds on to the previous point as well. So since your company is being more productive now with the help of chatbots, again you can pretty much give that wow factor to your customers. And if it's not the wow factor, which is basically what you're looking for, you can help your business brand itself through all the social medias out there by showing the world, what, I've implemented artificial intelligence here. And you would invite the world, you would invite the developers, customers, or whoever it is to check it out and see if they like them, to see what's going on. And this again directly translates to you talking to your customers in a more customized way, and this will probably help your business in the short term as well as the long term as well, right? So it makes sense. So what do you think? I mean, there are millions of other chatbot cases that we can think of as well. For example, there are doctor apps and health apps which will basically diagnose any condition that you might have. So you can pretty much type in the symptoms and say this is what I'm facing, and it will probably give you a very vague outcome of saying, hey, you might have this kind of a condition. Of course, you should consult an actual doctor and not rely on these chatbots at this point of time, but then we're getting there. Who knows, probably 10 years from now, the world of medicine can be revolutionized by keeping chatbots very accurate with respect to the field of medicine as well. And that's the thing about artificial intelligence, right? So when you think about it, the possibilities are actually endless, and we've started seeing those endless probabilities in the last 10 or 15 years or so. Coming to the next point, which is chatbot evolution. So this is one important concept, because when we talk about traditional chatbots, so all these traditional chatbots that we have seen all these days basically are system driven. So by system driven, what it basically means is that they have access to a small amount of data, and they have responses which basically they know what to reply for when you ask. For example, if you have to take the Amazon case again and simplify it to a level where there is a possibility is that the customer might ask two questions. The first question is, where is my order? And the second question might be saying, why is my payment failed? So when you have to break it down into simple terms, and the bot recognizes what question you might throw at it, giving the answer to it becomes very simple. So that is system driven. And automation scripts, as I just mentioned, if there are a certain number of questions which the business things that you can ask, they can program the answers automatically for this as well. And this relates to a minimum amount of functionality, because the chatbot cannot really think and grow and understand from what the customer asks. So it already knows the question, it basically maps that to an answer, and it just gives an answer. So it's basically a give and take policy where the bot might not be learning anything. And then coming to the current bots of today's world, these implement task level automation. So basically with task level automation, they know what they're seeing, and they can understand the context between the tasks and all of the system requirements that exist. So basically, if you're asking a question, the simple question again saying where my order is or why my payment has failed, it'll already have a system context there in place, saying, you know what, this is the question, this is the answer, give the customer the answer. With task level context, it will know what task has to be done to arrive at that answer. So it's not like take a question, find the answer, give you the answer. So it's take a question, analyze, and then give you the answer. So with current bots, that analyze part that exists right now. So the communication level is intermediate. So probably 7 out of 10 times or 6 out of 10 times, you will not figure out that you're talking to a chatbot. So that's how interesting and intimidating it's become right now, that it's getting good. We're getting there. And customer help. Well, current bots basically have been put into a use of, for example, project support, customer service, front desk management, and much more. So if we have to talk about the future bots will have multiple levels of communication which are cross-linked with each other. What this means is that at the end of the day, when you are talking to a bot, you can ask the bot to get some task done for you. You can ask it queries and get questions. It can perform analysis for you and much more. And all of this coincides to one thing called a service level automation, basically, which will ensure that all the tasks which are to be done manually, all of these can be automated easily as well.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it understands system level context as the traditional bots. It understands task level context as the current bots we have in place. And the best part is it'll get people context as well. So it'll understand who you are, and it can start generating and recognizing patterns in between people, what people are requesting for, why they're requesting for, who requested it. So out of billions of people across the globe, if you keep asking and training your future bots on a certain number of questions, or you keep asking it something, it'll recognize that the question is coming from this particular person. So that's how powerful it can actually get. And of course, in the future as well, there are multiple concepts such as bot OS and master bots. So bot OS is basically an operating system which is completely revolutionized and revolving around the usage of bots for your use as well. And master bots are basically bots which can control a certain number of chatbots under them and control some amount of context, some amount of functionality which are given to them to handle, basically. So they are the bots which will handle other bots, something like these. So something like this. So again, when we have to get a quick vivid comparison, I thought it was very vital for you guys to understand this about the traditional, current, and the future bots as well. Going to the answer of how does a chatbot actually work? Well, there are two types of chatbots when you have to think about it. One is something called as rule-based bots, and the other one is called as self-based bots. And the other one is basically self-based bots. So when you talk about rule-based bots, as the name suggests, there are some rules on which these bots will basically work on. You ask a simple question such as where is my order? Your bot will recognize the word where is and probably order. And this is a rule which is programmed in the backend which says when you find all these keywords, just give them an answer saying, hey, your order is here. Your order is on the way. Your order is delayed, whatever. So you cannot ask any complex queries to a rule-based bot because it will not have rules in the backend which will basically help it understand. So think about rules if they are like a book, all right. So it will basically look into this book for an answer. If it can find it, it will tell you, or else it cannot. So it's as simple as this. And most of the time, the training of these bots are really simple, and it is not complex. And what this coincides to, it basically means that you can ask simple queries, get simple answers. If you ask complex queries, it might fail. And now coming to self-learning bots. Self-learning bots will make use of concepts such as machine learning. It will make use of concepts such as deep learning to basically understand what you're trying to tell the bot. It's not like there's a book, it will blindly refer the book and give you an answer. So it'll try to understand why you're asking this, what you're asking, and how best it can think it can give you the answer. So this line that I just said, this is very important for self-learning bots because this is exactly what makes it highly efficient, and it is basically a trick to learn and to basically fool you into thinking that it's a human being, and that of course is very good for us. That is what we're looking for here as well. But then training a self-learning bot will take a lot of effort, because it is a very complex process to think about working with a lot of data. It will be terabytes worth of data for a very simple response generation as well. So training it with a lot of data, helping it analyze, and helping the bot give us an answer based on an analysis rather than a textbook definition is something which is very complex as well. So these two are the basic types of bots which we work with in today's world. But then when we have to talk about self-learning bots a bit, because again, when you're talking about artificial intelligence, when you're talking about machine learning, there are again two more types of self-learning bots. So they're called as generative bots and retrieval based bots. So let me talk about generative bots for a second here, and it's going to give you an answer. So basically you might be wondering, okay, so if I ask it any complex query, will I get an answer because it's using artificial intelligence? Well, the answer is no, because even though it can do word to word analysis, there are certain limitations here which will not allow it to give you an answer every single time. So in that particular case, generative bots actually have the upper hand when you think about retrieval based bots, because retrieval based bots are, again, they have predefined responses. So there are so you ask a question, it will go somewhere, pick up your answer and give it to you. So it's content based. No, so it's context based. With context based, it knows what you're asking, but it does not know. So it does not know how it can improvise its answer to basically give you the best answer out there. It knows that it can give you an answer, but it doesn't know how it can give you the best answer. For that, you need generative bots. Your generative bots will analyze the accuracy, it will analyze the likeness of its answer, and then it will give it out to you. So with self-learning bots, these are the basic examples. I'll quickly repeat it. So with generative bots, it knows and analyzes your answers before giving it out. With retrieval based bots, there are certain predefined responses where it just picks it up and it learns a little bit on that and then gives it to you. With generative bots, there's a comprehensive analysis which goes on with every single word that you put in, and then it learns. With retrieval based bots, it will look and hunt for a context, and once it finds that context, it will go back to the responses which are stored again, and then map those contexts based on responses and give you those answers as well. So on that note, next we'll have to check out something called as the chatbot chart. So basically, when you're working with a chatbot, right? So there's a good chance if you're either talking to the chatbot via messenger, you're communicating via website, or you're probably using a mobile to talk to Siri, Alexa, or all of the chatbots that we discussed. So as a human, you will be giving it certain inputs, and the chatbot will give you an output. So whatever inputs you give, right, so it will go into something called as a chatbot server. So the chatbot server will have three important things if you're talking about self-learning bots. So it will have certain knowledge, and this is like the book that it will go on to hunt. And it will have rules. Rules is basically like an index to the book saying this is where you need to look for the answers in the book. And then of course it will have machine learning, it will have artificial intelligence saying, hey, learn to understand these rules and learn to understand where you can apply these rules to find the context in the knowledge. So it's something like that. And to do all of this, it needs a lot of data, right? So there are numerous data sources across the world. It can be something as simple as learning from Twitter, all the way to learning from certain studies which is like probably 35,000 pages long or whatever. So everything from simple to complex data sources. It might be on the cloud, it might be social media, or wherever it is. Your chatbot server will pick up all of these data sources. It will try to understand what knowledge can it learn based on machine learning and what rules it has to apply, so that it can arrive at this stage where it knows stuff. And then it's not important that it has to know stuff. What's important is that it has to find a way to convey all of this it knows in a human way, imitating a human, right? So that is again an important thing. So basically this is like a one picture, one stop solution to understand the basics of how a chatbot would work. On that note, we can So on that note, we can actually go on to building our own chatbot. To do that, there are certain things we need to walk through as well. And the first thing is prerequisites when you're working with Python. There are two amazing libraries, and two among, let's say, thousands of beautiful libraries of Python, because I'm a huge fan of Python for the reason that it has amazing libraries. So there are two main things which we will be using to build a chatbot, and it's pretty common and obvious as well. So we have scikit-learn, which is basically used as the machine learning library for Python, and there is NLTK. So NLTK is again another amazing library, as we'll be walking through step by step to understand what makes NLTK what it is. So it's an amazing natural language toolkit. That is what NLTK stands for, and it's widely used in today's world to ensure that they can make a very good chatbot as well. So to give you a quick revision of what NLTK is actually used for, so this natural language processing, this natural language toolkit is actually used to process certain human language data. Well, mostly it's English, because again, English is a widely used language. So it is basically used to understand how this chatbot can be built by making it understand the words. See, for example, you will know what an apple is, you will know what a ball is, you will know what a cat is. This is because from your childhood till today, you've been taught A for apple, B for ball, C for cat, or whatever it is. So you have been programmed over the years where you know what all of these are. But then as soon as your computer sees a cat, there's a good chance that unless it has any training, it is just a text which says cat. It will not understand that it's seeing a cat, or that the context is a cat. So to teach it that context, saying whenever I type a cat, you think of cats. So that aspect is basically where NLTK comes into play. And to do all of this, there are many concepts. There's classification, there's tokenization, there's stemming, there's lemmatization, there's parsing, and all of this. But to get to all of that, of course, we'll be checking out all of these. The first thing you need to do is you need to install NLTK. And to install NLTK with Python, there is a very simple command with pip, the package manager. It's pip install NLTK. And once you clear this step, you have NLTK installed and you can work with it. So coming to the terms that we have put down there, classification. So classification, when you're working with data, basically is where you help the chatbot understand what type of data it can see. For example, there are certain words which are used very commonly. They're called as stop words. So for example, the, is, that, was, all of these are stop words which will arrive, and you will be using it multiple times in a given sentence, right? So I might have used the word like 100 times or more than that in this live session as well. So you need to understand to classify what words are very commonly used, what words are not very commonly used, and more. And then tokenization. So tokenization is this process where each of your words are actually broken down into events and so tokenization is this process where each of your words are broken down into single entities, and these entities are called as tokens. Tokens are basically the input to the chatbot that you give, saying, hey, you know what, this is a word, understand what this means. And then coming to stemming and parsing, we're going to check this out in a bit of detail in a second now. So to make your bot understand text, the problem here is that your machine, when you're using machine learning, when you're using artificial intelligence, deep learning, whatever it is, it will require some numerical features to work with. It will require numbers, it will require vectors, it will require matrices to work with. It does not require strings, and with the help of strings it cannot learn. So how do we solve this problem? Well, let me tell you with pre-processing how basically the text pre-processing works. There are two things. One is case conversions and the other thing is tokenization. So again, before we delve into tokenization and case conversion, let me repeat why we are doing this. So when you're using machine learning, when you're using artificial intelligence, your bots or whatever you're building, it will require to understand zeros and ones. It will require numbers to understand, and it cannot work with text. So we need to find ways to convert our text into these numerical numerical features, right? And hence we're doing the text pre-processing. Okay, so coming back to the methods, so there is case conversions and tokenization. With case conversion, for example, lower cases might mean different and upper cases might mean different. Let me tell you. So when you're starting out a sentence, you always start with an uppercase, but in the middle of the sentence you will not be using any uppercases unless it's like a proper noun and certain reserved keywords, right? So your computer needs to understand this, and basically to do all of these we will be converting everything into one case, usually when you're working with building a chatbot, because when you're thinking about keeping the same case and helping your machine teach, it becomes a very complex process. So to keep it very simple, we'll have the cases converted. So everything in a sentence, it'll either be lowercase or everything in a sentence will be uppercase. So that's why we need case conversions. And when we talk about tokenization, as I just said, you'll be breaking down your sentences, your words into a list. So that's basically sentence tokenizers and word tokenizers. With sentence tokenizers, each of your sentences will be broken down into singular entities. With respect to word tokenizers, each of your words are broken down into structured entities called as tokens, and these form as the input. So when we have to talk about how it works in NLTK, we have something called as the NLTK tokenizer. And since we're working with the English language out here, so there is a pre-trained tokenizer which will already understand what you're typing in, and it's basically the pre-trained punct tokenizer which is present as a part of the NLTK library. Alright, so one important thing you need to understand is that your text might contain a lot of things which is not required. For example, there are a lot of numbers or letters which you might not make sense of, or your computer might not sense of. So basically we need to remove all of these words, and this process is called as removal of noise, because this is noise through which it will not help us in any way building our chatbot. And then stop words, as I just mentioned, right? So is, was, and the, all of these are very common stop words which need to be removed to ensure that your chatbot is not confused when it's working with words. So stop words have been removed, or they are pretty much categorized differently. And then stemming and lemmatization is where things starts getting really nice, because when you're thinking about stemming, so stemming is basically a word which is derived from its stem. So let me give you an example of a stem word. A stem word may be learn, Learn, learn. So when you're talking about stemming these words, think about the concepts such as learnt, learning, learned, learn. So these four words, right, which basically has something in common, which is Learn. You can have Learnt, Learned, Learning, learning. So learn is common in all of these words. So learn becomes a stem word through which you can give context to all of these other words, right? So that is stemming. Now talking about lemmatization is a little bit different from stemming, and here is why. Here we talk about context rather than the words itself. See, for example, if I tell you good, better, and best, it gives you a positive connotation, and it gives you a general meaning of something is good, right? So good also means it's good, better means it's good, best means it's good. So you need to make your computer understand that good, better, best all have a positive connotation, and it means something is good in general. So lemmatization, all of these lemma concepts that we talk about, is basically this, giving your context some meaning. So I hope I was clear with stemming and lemming. Stemming is where we use these stem words and basically derive something out of each word's process, processing, processed, all of that. With lemmatization, it's basically context based learning, good, better, best, where you're giving meaning to the words you're checking about. And then talking about the input to a chatbot, it's of course when it has to learn, it needs input, right? So basically as I just mentioned, since it cannot understand strings directly, all of these strings are converted into numerics. So basically we are doing this by converting text into numerics based on the requirement. If they're required, they're considered. If they're not required, they're not considered. And you might be wondering why a concept like this is called as the bag of words. Why can't you just call it input? So it's called bag of words because here we're trying to consider the words which have come in. So we do not care about the order of words which come in. So if there is a sentence which says I like Intellipaat, with the bag of words, think of it like you're dumping the words in the bag where you do not care about the order. For example, I like Intellipaat can become Intellipaat like I like Intellipaat I or whatever order it is. So your sentence might not make sense grammatically, but all the words are there in a jumbled order. So it's like taking these words and putting them in a bag and jumbling them up, or even just putting it inside without any order. That is why it's called as the bag of words. And now coming into how it is basically processed. Let us take a raw input, and this raw input is something like a sentence which says, I do not like chocolates. Of course, there's not a lot of us who do not like chocolates, right? So ladies and gentlemen, again, let's keep this session interactive. So head to the comment section and put in your comments so we can understand and help each other out better here. So again, coming back to this, with respect to raw input, it's let's have a sentence which says I do not like chocolates, and you want your computer to basically understand I like chocolates part of it. So I do not, that do not part, we do not want it. Are you getting it? So your input is I do not like chocolates. You want your machine to pick up I like chocolates, and this is how it does. So I is required, so it becomes 1. Do not is not required, so do becomes 0, not becomes 0, like is required, like is 1, chocolates is 1. So whatever words you want to be picked, those words are 1, and whatever words you do not want it to be picked, those become zeros, right? So this is how, in a very very simple way, it's called as vectorization. And of course each of these entities will be separated by a comma, but then just to keep it more readable for you guys, I'm just showing you a general way on how an input can be vectorized and what is the result that we can obtain by converting this grammatically correct or incorrect sentence, for that matter as well, into a mathematical vector. All right, so I hope this is clear.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
And with that, we need to check out something called as the TF-IDF formula. So guys, again, if you know what TF-IDF is, head to the comment section and let us know. So what is a TF-IDF? Well, it's actually an acronym for term frequency and inverse document frequency. Well, fret not if you don't know what this means, as I'll be explaining all of this. So with respect to bag of words that we just discussed, right? So when you have an input which is a bag of words, it'll have a lot of words. So basically I told you we are ditching the order and we're just considering a lot of words, right? So that is the advantage and the disadvantage. The advantage is that there is a lot of words. The disadvantage is that your bot will not have a lot of information there. So there is a difference between having a lot of words and helping your bot understand all of these words, right? So this is where bag of words has a little bit of a downside which can be fixed, and it's fixed by giving it context and making it understand about these words. And to do that, we have something called as term frequency and inverse document frequency. So let's talk about term frequency before. First, basically, term frequency, when we're working about it, you need to understand that we need to find out how many times the term is occurring. So this might be because of classification. We need to understand stop words. We need to find out how many times one word is occurring. So if you have a sentence which has the word apple like 100 times, let's say it's a 10,000 word essay and you've used the word apple 100 times, you know it because probably you have used it. Now to make your computer understand that there is apple there 100 times, we need to find out how many times it has occurred divided by how many total terms there are in the document, right? So this will give you a term frequency saying, for example, if we do 100 by 1000, so there is a chance that 0.1% of every single time your word apple is occurring. So if you have like 1,000 words which says apple 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 1,000 times, and then if you want to search the term frequency of apple, what do you think it is? So it's going to be 1,000 itself, right? Because there is nothing else in that. So I'll give you an example again in the next slide. You will get a lot of clarity on this as well. For now, you need to just know that the formula of term frequency, where we are trying to find out how many times a term occurs, is basically the number of times it appears in a document divided by the total terms in that document as well. Now if we talk about IDF is basically inverse document frequency. So inverse document frequency is the number of times that your word has not occurred. What is the rarity of words that has basically occurred in your document as well? So for that we'll be using a logarithmic formula. It's basically 1 plus log of x by y, where x is the number of documents that you have where you're checking this, and y is the number of documents where this term occurs. So when you do a logarithmic inversion of this number of documents by the number of occurrence of the term, you will get the rarity of how many times the term has not occurred there. So let's walk through this with an example. On the left, I have kept the formula so that you can refer to it while we calculate on the right. So let's say right now we have an essay, or we have a document which we also call as a corpus. So corpus is basically the input document. So let's say we have a document which is 500 words, and in this 500 words the word call appears 10 times. Alright, so this is a generic document, there is 500 words and the word call appears 10 times here. So what does the term frequency of this mean? So term frequency again is the number of times a term appears, which is 10, divided by the total words, which is 500. So 10 by 500 will give a term frequency of 0.02. So for every word that you have written in this document, there is a 0.02 times chance that you've used the word call. This is term frequency visualized. And then if you have to talk about IDF, consider this. Let's say there are 10 lakh documents out there, and the word call now appears in just 60,000 of these 10 lakh documents, right? So 10 lakh documents, the word call appears in only 60,000 documents of these 10 lakh documents. Now to find out the inverse document frequency, basically as I just mentioned, we're going to take the 10 lakh, which is the number of documents, total documents, and divide it with the documents where we have the term which we require. So IDF in this case becomes 10 lakh divided by 60,000, which gives us a value of 1.22. And now if you have to give context to your machine, if you have to tell your machine, hey, this is the word, this is the context, this is how many times it occurs, there's something called as TF-IDF weight, and this weight is basically the product of term frequency and the inverse document frequency here. So as soon as we multiply all of that, we'll get a number which is 0.0244, and this number will basically give context to your machine, saying this is the weight of this particular term in these documents and in each of these particular documents as well. So your word in every document, in total number of documents added together, clubbed, and after you find the term frequency and the inverse document frequency, you will arrive at the weight of it. So on that note, we've seen all of these theoretically, and we need to now check it practically. So let me quickly jump to the practical aspect of how we can go on to check it. So here I am making use of Google Colab. Google Colab is basically a Python Jupyter notebook which is hosted on their Google Cloud platform. So this is where we will check out a very simple demo use case of how we'll go on to work with chatbots by using Python. Here again, as we have walked through in the theory, we'll be making use of NLTK. NLTK is the Natural Language Toolkit, which is a beautiful library to work with when you're thinking about Python. And of course, as always, whenever you're working with Python, it is a common practice that you import all the libraries that you require at the start of it. So in this particular case, we are importing NLTK and NumPy because you have to work with numerical computations. We're importing random because we'll be randomizing a couple of aspects here, and we're importing string. So string is basically a library which will help with string processing techniques in Python as well. So if you are on a native Python environment which is different from Google Colab, you might have to install all of these before using it. To do it, instead of import, just type pip install, pip space install space NLTK, pip space install space NumPy as well. So with Google Colab, all of this comes pre-installed, and that's the reason all we have to do is we have to just import them and it starts working. So after importing all of the libraries, the first step is to make sure that there is some data through which we can teach the chatbot, right? So this is where we'll have a file. This file or this document is called as a corpus, and with this document, this is where all the data resides in which your chatbot can understand. All right. So to do that, first we'll be using the file function. We'll be using an open function where the file we have, we'll call it as chatbot.text. Of course, you can call this anything else you want. You'll be opening it in the read mode because you're reading it, and if there are any errors, we're going to ignore those errors for now. So after reading these document, we'll be converting it to lowercase because, as I told you, case conversion is very vital for data pre-processing, and we will download the punked part of the tool case because we're working with English language, and this is already a pre-trained library that is present, right? So this is a one-time download that you'll have to do. And of course, we have something called as WordNet. So WordNet is basically a database which consists of relationships in between each of these words, all right? So with WordNet, you will have an access to like 200 languages. With respect to Punkt, it will give you the pre-trained library for English as well. And in fact, the WordNet is pretty, it's a pretty old library of data. It is present with us from the 1980s as well. So that's a fun fact for you guys. And now we spoke about tokenization as well, right? So we need to tokenize this to be each inputs of words and be inputs of sentences. So basically we are using nltk.sent_token to basically convert the sentences from the raw data, and word_tokenize to basically convert words. So here sent_tokenize is the sentence tokenizer, word_tokenize is basically the word tokenizer. All right. So again, as you can see, if you just put your mouse on that, you will basically find out what it is. So you can actually go on to the definition of it and find out about it a little bit as well. So now to do this, we need an input. So we haven't yet talked about what input we are doing, right? So in fact, let's go to Wikipedia page and give chatbot. So there is a Wikipedia page called Chatbot, and this is like a basic input to our model to train. So what we'll actually do is we'll take everything here, just hit Control A, in fact copy all of this and basically put it to a file, create a file called as chatbot.text and just put all of this there. So you will have something like this, and this is like a text file through which your chatbot can learn something. All right, it's simple as this. After that, save it, call it whatever you want, but then you have to remember the name because you have to input this, right? So now coming back to the input, as soon as I hit play, now it's going to say an error because it does not know where my chatbot.text is. It's on my desktop and we're running it on the Google Cloud. So let me quickly upload the file here, chatbot.text, and as soon as this is uploaded, I can run it again, and now it sees my chatbot.text file. It will convert everything to lowercase, it will download everything that's required, it will convert it into sentence tokens, it will convert everything into word tokens. So we did all of this by making use of 5-6 lines of code, and it's this simple, guys.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now, coming to the next aspect of the same step 2, basically here is where we'll be printing an example to see our sentence token and word tokens to see if it has worked, right? So now, as you can see, I just hit print and we're trying to just print a sentence token here, and we're trying to print a word token here as well. So whatever sentence here, you can give any sentence for checking here, and then you can just paste to see if this this sentence, which is the raw input, if it is converted into a token or not. So as soon as I hit play here again, it is obviously converted into sentence tokens and word tokens as well. So coming to the next step is basically pre-processing and handling your data. So as I said, WordNet is basically like a dictionary out there with more than 200 languages, and where it understands your words. Now we discussed about lematizer. With respect to lematizer, we give this word certain context, right? So that's basically what we're doing out here. With lemmatization, we are giving it context. You can think of the example which I just mentioned, good, better, and best there as well, right? So basically step 2 is all about that. And then coming to step number three is basically where you will be programming a greet response. See, for example, with any chatbot, right? Be it Alexa, be it Siri, be it Google Assistant, whatever it is. As soon as you say hi or hey, it'll not tell you something which is very vague. It'll greet you back. It'll be very nice to you, and it'll say, hey there, what's up, or how's it going, whatever it is. It's like a human conversation. So when you say hi to someone, they'll not just nod their head. 90% of the time they'll say hi back to you, right? So to give it that human touch, step 3 is all about giving greeting inputs and responses. So if you give it a response saying hello, hi, greetings, sup, what's up, hey, or whatever it is, it will give you a response back with hi, hey. It'll nod its head, it'll give you hi there, hello, it'll say I am glad you're talking to me, and all of that. So you can change these inputs and these responses to whatever you want. So basically this is not very complex. If it sees any of these, it'll give you a random input of this. This is where we require the random function that we inputted, right? So you might be wondering, where it's not like you give hello and it tells you hi every single time. You can say hello 10 times and it'll give you 10 different outputs from this response here. So as soon as we run this, we are taking the inputs and we're generating random greeting responses and printing to the screen. Now coming to step number 4 is where we start giving out responses. So to give out certain responses, so you need to understand that we'll be using the TF-IDF concepts. So I hope you guys remember the term frequency concept, the inverse document frequency there. Now we have to import all of these, right? So basically these are all part of scikit-learn. It's part of the concept called as the feature extraction, which is based on textual inputs. So we're going to import that, and you might be seeing the second thing which is being imported here as well. So the second thing which is imported is something called as cosine similarity. So cosine similarity is a part where you will be checking out and teaching your chatbot about how to find certain behavior inputs and how to find and understand what your difference is and the similarity is in between what the user types and in between what document is present. Do you understand that? So in our case, the document is the Wikipedia article that we took up, and the user input might be something where it has to learn and map this user input to the document. So that is where cosine similarity is used as well. Of course, we can discuss the TF-IDF concept or cosine similarity in a lot of depth, but then I do not want to overwhelm you guys with loads of information here. All right, so we're trying to keep it simple, and as you can see, it's just a couple of lines, and we have almost built our chatbot. So after generating these responses, we need to write a function for concepts such as where we are thinking of stop words, we are pretty much removing all these stop words, understanding it, and we haven't talked about what happens if your chatbot doesn't understand you, right? So if it sees stop words, it knows what to do. If it sees a greeting message, it knows it has to greet you back. But then if you type random stuff there, it has to give you a response, right? So it cannot stay idle. So basically we are trying to print a message here saying, hey, I'm sorry, I do not understand whatever you have typed. So with respect to this function, it's pretty straightforward, it's pretty easy. If it doesn't understand something, it'll tell you it doesn't understand you. And step 5, yes, step 5, or probably we can call this step 6 as well. So this is the last step where you will be programming the start point and the end point. So starting when you run the chatbot, instead of greeting it, it'll probably say, hey, my name is this, I can help you with this, and I want to quit. No, and if you want to quit, just type something, type bye bye or whatever. So in fact, there's actually a tiny mistake here which I will clear, which is a spelling mistake, which is can. I mean, come on, everyone does spelling mistakes. All right, now so basically what I'm trying to tell you guys here is that as soon as your chatbot starts working, it'll print out this message. It'll say, chatbot, hi, my name is samplebot, I can help you with chatbots if you need. This will be anything else, because we randomly picked a Wikipedia article for chatbot. You can pick up anything. It doesn't have to be a Wikipedia page. You can make it learn on a blog of your choice and then give you responses to the questions you ask. And then if you want to come out of the loop, this is basically working on a while loop where it's constantly waiting for your input. If you want to quit, you can just type bye, and if it sees a bye in the input section, it'll say thank you or thanks, and it'll basically quit. So as soon as we go ahead and run this, it says chatbot, my name is samplebot, how can I help you? If you want to quit, type by anytime. So let's say hi to our chatbot. It'll say hey. Again, as I mentioned, it is a random response that it is giving to us based on the greeting pool, right? So I can say hi again, and it will say something else apart from hey. So it says hi there. Another time, let me say like hey or something, it'll say something else. So as you can see, it's not giving you the sample a response that it is supposed to give. So it is generating random responses and it's giving it to you out there. Now let's just say we want to quit. All you have to type is bye, and as soon as it says bye, it's like, okay, thank you for talking, bye bye. And it's pretty simple like this, right? So even this we achieved with 5 or 6 simple steps in Python, which is really amazing. And in fact, let's run again. So in the chatbot article, there's this person called as Alan Turing, who is considered to be the father of intelligent machines. So let's ask the chatbot, who is Alan Turing? Let's see if it can find that out. Of course, the responses will be pretty vague. It will not be very accurate. It says there is a stop word which came here as well. Of course, apart from that, it gave you the answer. It says Alan Turing was a British scientist and he was a pioneer in computer science. See, I asked it a question saying, who is Alan Turing? It figured out that I'm asking a who question. It found out everything about Alan Turing and it gave me a sentence output there saying Alan Turing was a British scientist and a pioneer in computer science as well. So basically, this you might be expecting like a 2-liner, 3-liner output, but our chatbot, this simple chatbot, is intelligent enough to find this for you, and it's amazing. So basically, we didn't write hundreds of lines of code here. We probably wrote like 100 lines in total, or less than that, in fact, to build our own chatbot to do this, right? So it's as important as this, and it's as fun as this. So we can check out a case where it doesn't understand. So if I go on to type some random stuff, it'll say, so, see, I'm sorry, I did not understand you. So this pretty much covers all of the cases. We checked out greeting, we've generated response where it does not understand you, and it pretty much analyzes your document and gives you a valid response of whatever is in the document as well. So you can type something else as well which is not in the document, and it will say I do not know, because it has not gone through these words in the document there as well, right? So again, pretty simple, and I hope this demo was pretty much understandable to all of you guys. So there are many other complex demos which I can use and show with respect to NLP, probably by making use of very, very complex data, and by creating like a very nice use case, by making use of a very nice user interface, by using TK inter and whatnot. But then again, to keep it simple, so this was what I had in mind. On that note, let us come to the question. So you pretty much decided Python is your career goal. So on that note, pretty much you've come to the point where you need to become a Python developer, and you need to understand what is the demand. It's all about demand and supply in any business, and it is the same with respect to Python developers as well. Well, here I want you guys to be overwhelmed, because look at the people hiring on your screen right now. I've filled the screen through and through with all the people who are hiring for Python developers, data scientists, web development using Python, whatever it is. These guys want people who know Python. Everyone from the major social media sites, Instagram, Facebook, Evernote, Android, LinkedIn, people. And of course, we have the giants like Unisys and analytics companies like Mu Sigma, and we have IBM, we have Fractal Analytics, we have Ernst & Young, we have Edgewov. Edgewov is basically an Infosys company. We have Ola, which is again the competitor of Uber in India, and we have Oracle, we have Siemens, and many, many others who need Python developers for all of their problems. And of course, there is more. Fortune 500 companies, there's Skype, there's BBC, there's Adobe, Best Buy, Walmart Labs, Apple, Google, you name it. As I've mentioned, everyone, I would like to say 90% of the companies in today's world will require a programming developer at one point or the other. And in those 90%, well, let's say 60% of them need Python developers compulsorily. Well, that is an incredible number. That is thousands of openings pretty much every single day as well. And on that note, you might be curious of saying, hey, what do Python developers earn if there is this huge of a demand? Well, let me tell you the average salary of a Python developer. It's somewhere around 123,000 American dollars. Of course, in the USA, it's about 15 lakhs per annum in India, and it's around 71,000 pounds in the United Kingdom as well. So, ladies and gentlemen, this job not only gives you the bragging right of being a programmer in the top programming language of the world, and but it is very lucrative at the same time. You can look at the numbers on your screen. These numbers are very much achievable. You just have to prove to the people that you're going to be hired with that you're capable of doing it. You have the right training, you have the right hands-on experience, and at the end of the day, that should be more than enough to guarantee you an employment with one of these top companies that I just showed you.
First, let's take a look at an overview of the career options. So since Python is quite a versatile language, you can have a few career options in Python. So if you know Python, then there are many fields that you can go into. Some of these are the ones that we're discussing here. It's not that these are the only fields that you can go into. There are many, many other fields as well, but these are the fields that are the most prominent ones. First is the automation engineer field. Second is web development. Third is ethical hacking. Fourth is game development. And then there's data scientist. Data scientist, machine learning engineer, they're both closely related. So we've clubbed them all into one single field. All right, let's take a look at automation testing. So we'll first have an introduction. So what is automation testing engineer? So automation testing is done when a person writes Python scripts that can be used to check whether or not computer software is behaving the way it's expected to. For instance, if you have a computer software and you wish to check whether or not it's working correctly, or whether or not things that have been used to make to build it are using correctly, the components are working correctly, such as the database interaction, the network layer interaction, so on and so forth, you can write Python scripts that can automate this process. Although there are people out there who do it manually, automation is really taken off, and nowadays people prefer having an automated test orientation. Now let's take a look at some of the tools. These are just some of the things that you might need to know in order to become an automation tester. The first thing is Selenium. Although automation testing requires a lot of tools and there are a lot of tools out there, Selenium is by far one of the most popular ones. It's an automation testing tool that allows you to automate a browser, most notably Chrome, and using that you can just instruct it to find elements, click elements, fill in some text fields, so on and so forth. And the browser will follow all the instructions that you have written and will follow an entire use case scenario. In case something fails, it will notify you immediately. So instead of you having to do it all manually, the browser will take a look at all of that and then will notify you whether or not server is not working or it's getting an incorrect response. This is all done through the user experience flow. So this browser will act as a user. It will be automated by Python scripts. So how a user will interact with the product is how the product is going to be automated using Python, and then the browser will make the interactions happen. And if something goes wrong, then we will be notified. But what about from the development perspective? This is where testing comes into play. So you can take a look at PyTest. PyTest is one of the most popular frameworks for testing in Python. It allows you to write tests. It allows you to create mocks. It allows you to create stubs. It allows you to basically take a look at the code and then test the code itself instead of taking a look at the output or the end product and then using the Python code to automate that end product's interaction. So here you'll take a look at the code. This is more like white box testing. So here you'll take a look at the code, you'll write test for the code to check whether or not it's working correctly or not. And then later on, those tests could be part of the test suite, which then will help us understand how you can go about doing it. Then there's PyUnit. It's another testing tool, but it's focused mainly on testing the code and testing individual components or individual units of code. Other parts of the code could be isolated, so your application doesn't need to know much about it, and you just need to know PyUnit or the unit testing tools that you have available. PyUnit is quite popular in both the development and testing communities. So Selenium, PyTest, and PyUnit are three of the things that you might need to know in order to become an automation tester. Now we'll take a look at web developer and we'll understand what is involved in creating web applications. Now, in case you are wondering how you can get the skills that I'm describing, how you can learn to use these tools in order to further your career in Python, do stick with us to the end and we'll guide you through some of the resources that you can use in order to get better at these tools and easily pick up these skills so that you can get it done. Right? All right. So a web developer that uses Python can build the backend of a web application. Python is used to build the backend. Now the backend can either serve the entire web application. So it could be all the markup is templatized and then you can get data from the database and then hydrate the markup and then send it to the user. So this is how PHP would work. So you can use that way, or you can create a web API. Basically what web APIs allow you to do is allow you to systematically and programmatically expose some data that you have in your database. So in case you wish to expose all the lists of users available in your database, just their username and the date of birth, you can do that. And then the front end of the application will take a look at the data that is sent back and then build the entire web page on the client side. So either way is useful, and Python supports both the ways. So it's quite versatile, as we have already discussed, and you can do it that way.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Now let's take a look at some of the tools that you might need in order to become a web developer, the kinds of technologies that you need to know. So web development involves the use of many tools and technologies. Some of these are, the first one is Django. Django is by far the most popular one. It's currently in its third version. It's really a really good framework, very easy to get started with. It's got batteries included, so anything that you might need to do in order to create a web application, such as database interaction, authentication, authorization, serialization, deserialization, response parsing. There are so many things that are needed, and Django makes it all easy for you. It allows you to break up your apps into break up your entire web application or the backend of your web application into smaller applications, which can then be used to create separate functionalities or separate features. So in order to create an authentication system, you can create separate applications for authentication, and that way you can just plug and play your applications, which is quite easy to use. Then there's Flask. In order to get a higher level of access and control on the code that you write, you can use Flask. Flask is a micro framework. It only takes care of a few subsets of the thing, and the rest of the things are left on you for you to figure out. Flask works well with other tools as well. In case you wish to introduce your own database access technologies, such as an object or object relational mapper, or you just want to do it the traditional way by getting the data from the database and converting each row into a domain object, you can do that with Flask as well. And then comes Web2Py. Web2Py isn't that popular, but it's quite useful in some scenarios, especially if you have a really small application or you want to build applications for quick prototyping purposes. Web2Py is a very easy to learn tool. Web2Py is also quite good for you to use on your personal projects and so on, and they can help you out with a lot of things as well. So Django, Flask, and Web2Py are three of the most popular tools that are written in Python and are used in web development. Let's take a look at ethical hacking. So what is ethical hacking? An ethical hacker tries to break into a system in order to find out security loopholes that need to be fixed. It is to be understood that ethical hackers are employed by the company in whose system the hacker tries to break into. So you get onboarded into a company on a contract basis. They ask you to have 3 months full access to the systems that they want to check whether or not are hackable or not. You can then take a look at their networking schemes. You can take a look as pretending as a malicious user. You then need to figure out ways that through which you can break into their system. If you find a way, it's your duty to report back to the people who have employed you, and those people can then fix those things, and you could even help them out into fixing these problems. So that would be really useful, and that's why ethical hacking is all about. That's what ethical hacking is all about. Let's take a look at some of the tools. Now, the tools for ethical hacking are not just based in Python, but Python is quite popular in this field because it's very easy to learn, and ethical hacking is mostly about networking. But if you know programming, then that could be really, really helpful. The first one is Scapy. Now, Scapy is a tool that allows people to sniff network packages. So packages that are coming in or out of a router or coming in and out of a network, Scapy can be used to take a look at those packages. And if it's interacting with an unsafe network, such as you are on a you are in a cafe, and a person is logged onto the same router in the cafe as you, and they are interacting with a non-HTTPS website, which means it's not secure, and anything that is being sent over the network could be easily intercepted and then taken into account. So a person who can take a look at the username and password that you're sending over the network would easily hack into your system. So that's what SCAPI does. Then there's flow grep. What flow grep does is that it takes a look at the request and response coming in and out of a network, and it matches the response body with a particular pattern that you're sending it. So if you want to get all the requests that have username or password in the request body, then you can take a look at that. Or if you want all the network requests that are going to a specific domain, then you can take a look at that as well. Flow grep allows you to narrow down the request that you're taking a look at. Then there's subroot. It allows you to take a look at all the subdomains available for a particular domain. So if you are working on an example.com and you want to take a look at all the domains that you can explore, instead of finding out yourself, you can use subroot, and it'll tell you whether or not mail.example.com or sample.example.com or database.example.com, lms.example.com are these domain names available for a normal user, and if they are, then how can we use them? That's where ethical hacking tools come into play. These are some of the subset of the tools. The tools are really large in number, and there are a lot of tools available. And again, we'll take a look at different methodologies, and we'll help you navigate these tools in order to understand how you can learn them. So stick with us till the end. But till then, let's just take a look at what else we have. Game development using Python. So game development is quite a vast field. Many people get into programming to learning how to build games of their own. Now, game developer uses Python to build games which can be played on a variety of platforms such as computers, mobile, and so on and so forth. There are many ways that you can build games on using Python, and we'll take a look at some of them now. So let's take a look at the tools. The first one is Pygame. Pygame is one of the most easy to use, uh, Python gaming frameworks. It allows you to build games using some of the most common technologies that you come to use, such as sprite sheets and collision detection, and it does all of these things for you. Many of the gaming engines that we will discuss will take care of the physics for you. So in case you throw something in the air in a 3D game, how does it then get back onto the surface that we have created, and what the interaction will be like? All of that is taken care of many of the game engines. Pygame does have extensions that allow you to do that, so you can take a look at those as well. And it makes it really easy for us to understand how to use these gaming tools. And these gaming tools are quite easy to use by themselves as well. Then comes PyOpenGL. So OpenGL is a graphics library that has been created and is being used by a lot of people to create a lot of different things. The PyOpenGL is the Python extension, and it allows you to write Python code in order to create OpenGL scene graphs, objects, and monitor their interaction with each other. OpenGL allows us to efficiently render complicated objects on the scene graph or on the screen that we have available. And in those screens, many games use OpenGL extensively. So in order to create stellar visuals and great graphics, you need to understand how to use OpenGL. And for Python users, you can use PyOpenGL for that. PyOpenGL also allows you to write your own OpenGL scene graphs and interpret some of the OpenGL objects that have been created by other people. So it's quite easy for us to use as well. So do understand how to use that and try and use that as well. Then comes Kiwi. So in case Pygame didn't work out for you, you found it to be too complicated or confusing, then Kiwi is an alternative to that. Kiwi also does many of the same things that Pygame does, but it's very easy to understand. It's very easy to use. It also allows you to create applications or create games that can be used in either of the mobile applications or the desktop applications or many other places. So you can take a look at Kiwi as well if Pygame seems to be a little too daunting for you. But I would recommend that you check out all of these tools, get a feel for which one serves your needs the best, and then use that. And now let's take a look at data scientists. So a data scientist takes a lot of data and gets useful insights out of the data, or what they do is they take the data and train a model which can make predictions by learning from the data. So data science has elements of machine learning as well. Data science is part of machine learning and a part of broader range of artificial intelligence, which takes a look at the data and figures out what we can extract out of it in order to get better predictions. Take a look at some of the tools that are available for us as data scientists. So we have data scientists. As data scientists, we have many tools available. These are a few subsets of them. The first one is pandas. Pandas is a tool that if you have worked with data science for any number of time, it's a tool that allows you to take a look at structured data. So if you have data saved in a CSV file, in an Excel file, in an Excel worksheet, if you have data stored in a database file, you can get it into your Python program using Python or using pandas, and then you can visualize the data. You can perform data wrangling tasks. You can group the data, sort the data, drop some of the columns, get some of the data, clean the data. There's a lot you can do with this. Especially the cleaning part and the cleaning the data, dropping columns, all of this is done ridiculously fast in pandas. It is very performance optimized, so it's very useful in that regard as well. Then comes NumPy. NumPy is by far one of the most popular languages out there. So NumPy is one of the most popular libraries out there. NumPy is used for numerical manipulation. So if you are someone who's getting into the crux of data science and you're trying to come up with algorithms and you're creating a lot of simple equations, but you want them to run as fast as possible, in Python using NumPy is quite a good thing. Because in Python, the normal data types that we use store a lot of unnecessary information that are not that useful for generic computation. NumPy strips them out and allows you to perform these computations quite easily. It has a lot of convenience functions as well that allows you to just lean over the initial complexities and then figure out how to apply these functions on the data that you have. It has it has functions to calculate the sine and cosine values and do matrix multiplications, transformations, Fourier transforms, so on and so forth. So any data complicated task, a numerically complicated task, NumPy can perform really easily. Then there's scikit-learn. Scikit-learn is by far one of the most easy to learn libraries. And what it does is that it takes care of the initial hurdles of learning how to create a machine learning model or a data science model by learning the algorithms. So instead of having you implement all the algorithms, scikit-learn takes care of that. It contains a lot of generic algorithms that have been developed by people who are working as data scientists for a long time. So what they do is that they take the data, they convert it, and then they send it back to the users. So in case you wish to become a data scientist and you want to take a look at scikit-learn, you can take a look at that as well. In scikit-learn, you take a lot of packages that scikit-learn provide, and in those there are packages for accuracy testing, training testing, and splitting the data, cleaning the data, or if you want to build a model, you can just import a generic class that can take in the data, take in the data, train the model, and then allows you to make the predictions. And those could be saved to be used or exposed later on as well. So these are the three libraries that are incredibly useful in data science with Python. There are others available as well, but these are the ones that are the most useful ones.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. Now, I've broken it down to a couple of steps and let's go with it together, right? So step 1 is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows. So we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with this screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Just before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now, and this will ask me for my admin password because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. And I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install, and step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the setup, guys. So guys, now the setup is successful. So let me quickly open up command prompt to verify that it has been installed correctly, guys. So if I go ahead and type in Python there, then pretty much Python console is ready for us. So let's type in a sample code, hello world. And as soon as I go ahead and run this, we have the output, guys. So pretty much, well, as of this moment, Python 3.8.0 is the official stable release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do a equal to 1, b equal to 2, c equal to 3, and so much more, right? So let us create a new variable d and then probably add a and b to it. So let me just quickly do this. We can print d. Well, d is 3. Let's multiply, let's create another variable, call it e, multiply d and c. Let us print e. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3, and so much more. To just get out of the console, you will have to type quit followed by parentheses, and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotlib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video. But note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code, and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console. But here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter, and if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using, because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that, okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it b plus c. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen, and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took b and added the next string to it. I could even make it a little bigger. B. Let me just do it this way. BSBA and CSS, and as you can see that it added it to the it added those two strings together. Now if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. if I have a string called ABCD, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age n equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B and C to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B and C, if I were to use B, C and A, then B will be assigned 10, C will be assigned 15 and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter. and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand, so let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and 1. So when you hear something like integers can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have, this will be 0 since all the 4 numbers are 0. Now what we're doing is, I want to check, if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is, if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If, let's say, this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is, we take a look at it and we go 2 raised to the power of 4, and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3, and the number at the third digit position is 1. Then 2 raised to the power of 2, and the number should be 0, and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3, this should be 2, should be 1, this should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1, so we multiply it here by 1. Then at the first position is 0, second position is 1, and the third position is 0. So what ends up happening is, we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0, plus 2 to the power of 2, which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1, which is 2 multiplied by 0, and we go 2 to the power of 0, which is 1 multiplied by 1. and this ends up giving us 0 plus 4 plus 0 plus 1, and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1 we have come to 4, right? So that's how this works. So this is what the operator, left shift operator, does. It takes the binary format and shifts it by 2. Now on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed, and add two zeros at the begin, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4 and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discussed are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code. And we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others, and these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type RET is equals to 7, this works just fine. But if I were to type return RETURN, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. but functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every characters in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, it's 72. So if I were to print var with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 var equals to 7. We'll get a syntax error. But if I were to do it v1ar, this is just fine, it will work. v1ar and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path. Press enter and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. and for that you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing, like the null pointer and all, but you don't need to worry about that. You just need to understand why there's two quotes and why there's one quote, and that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type three single quotations, press enter. I get back the prompt with three arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers, so we can store that in integer as well. Let's say that I want to store -77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a new version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type Perl, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now, and when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers and tuples will have some value assigned to them, and then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable we have lists, dictionaries, sets, and in lists we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this, and if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters, because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now, another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the fifth character, or the sixth character in this, which is on the fifth index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the fifth character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the last, removing the last one character. If I were to remove the last two characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f with g. I press enter, it returns another string to me, which is a, b, c, d, e, g, g, h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me. Monday, Tuesday, Wednesday, Thursday, Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to add something to the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned somewhere, some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousand. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary to for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a, and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple. So to see if it's a tuple or not, and it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add two curly braces. Inside it, add the key, which would be the person's name. Let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter, and now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good, but one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. I press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary of something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple, and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? Set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2. with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in S, and it will show you 2. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this, and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do 1 in S as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in S I can type 1 in L, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window, and here type in VS Code, press enter, and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open VS Code for you. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py and right and click on edit. It will open it in Notepad and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder, so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. So you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well, so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We are typing Python and the name of the file. So you can do it either way that you want. Now that that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I print it. It's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num 0.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
and then I keep going on, like print num1, num2, num3, so print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understand what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parentheses, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they are immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter, and pop is also not available. But you can print them, you can loop over them, just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this dictionary, dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys, these are the values. So Jane earns 15, John earns 20. So we type it, we print in the keys. Now if we don't want to print the keys, let's say we want to print the values. I do that, now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now, another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for X in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10, because the end is exclusive. So always remember that. And now if I do L dot append X, and finally we can print X, not XL. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code, because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add X to the list. Now Python is waiting for me to define what X is. So I'll go for X in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier, and this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and this is where you will get run into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if, say, the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand, if the condition is true, then statements 1 is going to execute, and if condition is false, we'll execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true. Then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Where on this again is correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else, again write some code, x is greater than 15, and finally else, x is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We take a look at, we assign a value of 17 to x, we check this condition, we check if x is less than 20. It is less than 20, we go down, we print x is less than 20. We go down, we check x is, if it's less than 15. It's also true, so we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read if you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on. So don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flowchart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, Then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does. And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So in space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and there's a space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list, and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list, and you don't want to print the name of people whose salary is less than, let's say, 40k. So what you can do, if person, let's say that for each x 0 index is x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. It'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9. Go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. Another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index started with 0 and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1. I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code, and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you are working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform. And if that's the case, then you don't return anything, you just omit the return statement completely. To give an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's Lambda functions. Now this is a concept that gets overlooked quite often, but Lambda functions are very powerful. So Lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a Lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how Lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But if since you can see it's a very simple simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36. Now, another thing that Lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. Alright, so if I were to call this function download file, and let's say that the URL is ftp : www.abc.org. Now if I were to run this, let me just run this here, it's going to perform these tasks. But the major advantage of using a function is now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL df ijk, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines, so this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see. And it's downloaded it, but as you can see that this step is now added to all three of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in two data and I perform some task. Now I want to return x multiplied by y. Let me call it, again this is a very trivial example, multiply, right? And if I want to multiply two numbers, multiply, you multiply x and y. Now x and y are going to be numbers, so let's say 15, 10, comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it to multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print, let's say that I want to, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply and we want to execute. If I run this again, it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. Taking a look at what are data structures. So a data structure is a particular way of organizing and storing data in a system's memory so that it can be used efficiently for some purpose. A good example of this would be and arranging data is a very important aspect of any programming language. Some kind of arrangement of data might be better suited for one purpose than other purposes. To give you a more concrete example, if I were to give you a few numbers, let's say from 1 to 10, let's say I were to give you 10 numbers of any, I were to give you 10 numbers and those 10 numbers were given on a card. All of those cards were placed face down in front of you and you had the option of arranging them in any way possible by looking at their value. Then I would ask you to check for a particular number to be existing in one of the cards. So if I were to say, okay, check whether 10 exists in one of those cards, what you could do is, if you had arranged them all in a linear fashion in a random order, you can just take a look at each card and see whether or not it contains the number 10. So that's easier for you to do for 10 numbers, but let's say that the scale increases and now you need to do that for 100 numbers, for 1000 numbers, for million numbers, and for even billion numbers. That is going to be really time consuming. On the other hand, if you had stored it in a different way, let's say that you had stored it in a way in which when you get the data, what you do is you first take one card, see if it is what the number of the card is, place it someplace, then take the other card and see whether or not it's smaller or larger than the card you had previously taken. If it's smaller, you put it on its left hand side a little below, and if the card is larger, then you put it on the right hand side, and you keep doing it again and again and again. This forms kind of a tree like structure in which a card is at the top, all the numbers smaller than the card is on the left hand side, all the numbers larger than the number on the top is on this right hand side, and this rule is followed for all the cards. So if you have many cards, this will be followed for all of them. Then I can come along and say, for the 10 million numbers that I have given you, tell me if the number 15 is in those. What you can do is take a look at the card right at the top. If the card at the top is larger than 15, which means 15 is smaller than the card at the top, you look at the left portion of the structure that we have created. On the other hand, if it's larger, then you look at the right portion, and you keep repeating the step. Each step is going to cut down half of the tree for you, so you don't have to worry about that. So this is what's called a tree data structure in essence, and this is specifically called a binary search tree. And the technique we're using inside it is called a binary search algorithm. Basically, if you have data that is sorted in a particular order, you have the ability to look at the data that's right in the middle of the deck, figure out what the number is. If the number you are looking for is smaller than the number, then you have to discard everything that comes after that card, the middle card that you have chosen. If it's larger than the number, then discard this and everything that comes before it. And you keep doing it again and again and again, and you will eventually get to the card that you choose in a very few number of steps. In fact, the number of steps is different from linear to logarithmic scale. So it's quite different. So this is one of the ways that storing data in a particular way can help you. Similarly, you can, if you wish to grade a few papers, you can store them in a stack that's easier for you to deal with. And if you're trying to manage a few people getting through and doing things in an orderly fashion, you can store them in a queue. Similar concepts are carried over to data structures as well. Right, let's take a look at what is a linked list. So a linked list is a linear data structure. Now, a linear data structure basically means that data inside this data structure is stored in a linear fashion. Linearity basically means that there is an order one data point comes after the next data point, and that comes after the next data point. So this is how linear data structures work. The most common and famous example of a linear data structure is an array or a list in Python. If you have used other languages such as Java and C++, then you are using arrays, and those are linear data structures as well. So each element or node in a linked list, and a node is a term that we use to define a particular data point in our data structure, which is linked list. So node contains two things, or two pieces of information: the value that we want it to hold and a reference or a pointer to the next element. Now that pointer could point to the next element if there is one. If there is no next element, it points to none in Python. None basically refers to an absence of value. So this piece of information comes in handy, which we will take a look at when we're implementing the linked list. So as you can see that a linked list, we use node. Now node is one way to refer to what we are describing. You can use other terminologies such as elements or any other thing. But node is what the community has settled down on. That's the keyword here. And it uses reference or pointer for the next element. Now the reason why we're using the word reference and pointer is because depending on the language, you call them different things. In Java and in Python, you use reference, which basically means you ask for the address of an object in memory, and it will be given to you by the runtime environment. On the other hand, in languages where you get to manipulate the raw internal memory of a system, such as C++ and other languages, you can use pointers. Pointers also allow you to do arithmetic on the addresses, where you can add a few things and get the next address. But that's not possible in references. In any case, you can implement these data structures in any language that you desire. Whether it's Python, whether it's Java, whether it's C++, whether it's any other language, you can use them in all of those. Right? So let's take a look at the benefits of using linked list. So using a linked list has several benefits. The first one is that it is dynamically sized. A dynamically sized linked list basically means that it is a list in which you can add as much data as you can, or as many nodes as you want to, as long as there is space in memory for you. Now you might be wondering that that's also the case with arrays or lists in Python, and we'll get to that in a moment. But since lists are also dynamically sized, there is one tiny bit of problem with lists that we'll discuss later on. But the important aspect is that they are dynamically sized. Now, similar concept to list in Java and C++ and other statically typed languages is arrays. Arrays are not dynamically sized. They cannot be sized dynamically. They only have one type, and you cannot add more data to it after a certain point. You have to define the capacity of an array when you're declaring it and when you're instantiating it. In C++ and Java, if you have created an array that can hold 10 memory items, you can't add 11th one. That would be considered an illegal operation, and that would cause your program to crash. Just know what the error is and how you can use linked list to solve those errors. Arrays are not bad. They are used for specific purposes, and if you want to only store 10 memories, then using a linked list is just an overkill. So understand the problem and then use it. In any case, linked list can be dynamically sized. It allows for faster insertion operations. So let's compare it to other data structures such as arrays, as that's the only one we know right now. In an array, let's say we have 1,000,000 elements, and I want to add something right at the beginning of the array. Even though it might be dynamically sized, what I would have to do is assign firstly grow the size of the array. So from 1 million, it should now be able to store 101,000,001 element. Then I have to shift all the elements one place back. So the element that was at the uh, uh, that was at the millionth place now needs to go to the million and first place, and that way we need to shift all the elements available.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And then all I have to do is rewrite the element that is the zeroth index at the beginning. Similarly, if I had to do the same thing for any other place in my array, such as the 10th index, 15th index, 17th index, I would have to do the same kind of process. Just I would have to stop at the 10th index and not go till the end. Now that's useful, but as you can see, it's quite inefficient. I just want to add one element at the beginning. That's not what I want to do. So in linked list, you can do it quite easily. Since in linked list, all you have to do is just create a pointer, point its next pointer or reference, store the next reference to the beginning of the list, and point the pointer that's pointing at the beginning of the list to the current pointer. It might look sound very typical, but don't worry, we'll take a look at that in the demo. So you don't have to worry about that. But that's the way it works. So this is why insertions are much faster in linked lists. This is why linked lists are preferred in situations where we have data that is being dynamically added. So we need to figure out where we want to add it and how we can do that. Next, let's take a look at faster deletion. So again, it's the same problem. If I wish to delete 10 elements from my array at random points and I want to shrink the array, now I have to firstly remove one element, shrink the array from the back, then do the same thing again and again and again. That is also quite inefficient. In linked list, all I have to do is just make sure that there are no dangling pointers. That means that if I'm removing an array or I'm removing a node, I just want to make sure that the node that is occurring previous to the current node and the node that's occurring next to the next node are connected to each other. That's the only thing that I need to take care of. Other than that, we just have to remove the data. The rest all will be managed by either the garbage collector, or it's something that I would have to take care of on my own. Now, again, depending on how you are implementing these structures, you can implement them in several different ways, but it generally leads to a faster deletion time. Then comes memory utilization. Now, many data structures need contiguous blocks of memory. In linked list, you don't need continuous blocks of memory. So, for instance, if I want to store 10 million data points or 10 million nodes of linked list, I just need to find 10 million small patches of memory where I can store my linked list item, and the rest I can just point to the memory address of the next element in each of the node, and it will work just fine. On the other hand, the memory utilization is not going to be great in arrays, because in arrays we have a lot of we need to have contiguous blocks of memory. This is how arrays are implemented underneath the hood. This is also why we need to define a fixed size right at the beginning, because it's more efficient that way. So when we have an array and we want 10 million data points, what we need to do is we need to firstly find out a block of memory in which I can store 10 million data points, and assign that block of memory, that block of contiguous memory, to my program, so that it can add 10 million arrays, 10 million indexes inside my arrays, inside my memory. Now, that's easier for us to do, but it causes a lot of overhead on our memory's part, because let's say that there are few patches of memory that can store 2 million, 4 million, and 4 million again. Now, for our memory to be able to be used by arrays, our computer or our operating system would have to defragment the memory. which basically means just rearrange the memory in such a way that all the empty space is patched at the bottom so we can easily use this again. That takes a lot of time and could hang our computer and could lead to degradation in our computer's performance and speed. So let's take a look at how we can fix something like this. So we use linked list for that. But before that, let's take a look at lists versus linked lists. So what is the difference between a list and a linked list? A list is a Python programming construct. So when we're talking about list, we're talking about the native Python implementation of a list. And a linked list is going to be something that we will be implementing in a few moments time. So in Python, we already have a built-in data structure named list, but it is a little different than linked list. So although it might seem that the internal implementation of Python's list might be the same as linked list, mainly because we are using dynamically sized linear data structures, there's some key differences. A list is stored as a contiguous block of memory, while a linked list is stored as a bunch of nodes scattered around memory connected to each other. So if you want to store some small pieces of data, then you can use lists. But if you are going to store a large bunch of data and you need to be able to dynamically size it and want to add and remove data continuously from it, then you can use, instead of using list, you can use linked list. Linked list is much more efficient for that purpose. You can use lists for that as well, but the memory consumption is going to be high and it's going to lead a degradation of performance. So it's up to you which one you use. You just need to understand how to use or in which situation to use which one. Both these are tools. Understanding which tool to use when is going to be really going to be the key to building good software. So now let's take a look at the types of linked list. So there are many types of linked list. Since linked list is a very versatile language, we are going to mention only three of the most used types of linked list, but you can use other kinds of linked list as well. The first one is singly linked list. In a singly linked list, we only share a single reference to the next one. So basically what it means is that we have a data point that contains, or a node that contains some data and reference to the next element. If I go to the next element, I can't go back to the previous element. There is no dual connection. It's just a single line of traversal. So this is what a singly linked list is. Then comes doubly linked list. In a doubly linked list, we have both pointer to go from current to the next node and from the current to the previous node. So that way we can traverse both front and back in our data structure. So these are two different kinds of data structures. And then there's circular linked list, in which the last element of my node is going to point to the first element, so that we have a circular linked list. Instead of storing it in a linear fashion in which we have the beginning and the end, we have, instead of having a beginning and the end, we have a circular structure. Now all of these can be used for their own purposes. In singly linked list, we use data structures to implement single data points. These are called nodes. The main important aspect that is different from singly and doubly is the memory usage. The memory usage of doubly linked list is going to be significantly more because it's storing three pieces of information, not two. Whereas in singly linked list, you're only going to be storing the data and the reference to the next element or next node. So that's the thing. Now, another thing is that they are used in different things. So singly linked list can be used in the back and forth feature. It can be used to develop stacks, which can be used to develop the forward and backward features in web browser. So when you visit a browser, then you go forward, then you go backward, then you go to another address, then you go backward, and then you go forward. All of this is implemented by singly linked list, and it's quite easy to do it with doubly linked list. In singly linked list, it's a little difficult, but it could be done if you do it using stacks. On the other hand, in doubly linked list, you can perform many different kinds of things as well. And a circular linked list can be used for developing caches, something that is called LRU, or least recently used cache. And that's one of the most important implementations of circular linked list. So you can use it that way. And you can implement circular linked list using singly and doubly linked list, which basically means using a single link or double links. Double links means something that points to both the current next node and the previous node as well. So you can use it that way as well. Now let's take a look at a demo of implementing linked list in Python. So as promised, I have a Jupyter notebook, and here I'm going to implement the linked list. So you don't have to worry about how I'm going to do it. Just follow along with the code. If you have Jupyter notebook with you, you can do it quite easily. So Jupyter Notebook is not really necessary in this case. You can also write the code inside a simple Python file and then run it. I'm using Jupyter Notebook because it's easier for me to show how things are being implemented. Since we need a node, the first thing I'm going to do is implement a node. So just create a class, call it node. That node class needs to have a constructor. In Python, a constructor is called an initializing method. Call it self. In the self method, inside the self, after the self keyword, I need some data and the next pointer, next, should be pointing to null. As you can see in Jupyter Notebook, this is highlighted as green because next is a keyword in Python. In case you don't wish to use the next keyword, you can use something else, some other keyword that makes sense. I'm going to use it here. It doesn't really make much difference here, but you can use it for something else as well. And by default, it's none. So if there is no other point that is given to us, it's going to be next. So now all I have to do is just give it some data. And also I can use the data to be none as well. So it just doesn't contain any data. And now self dot data is equals to data, and self dot next is equals to next, and that is done. So that's our node class. This is what is going to contain a single data point. If I run this, I don't see any error. If I were to create a new data, let's call it n1, and I don't do anything, press n1 dot data, run it, doesn't print anything. If I press n1 dot next, doesn't print anything. On the other hand, if I were to pass in 1 and if I were to print n1 dot data, it contains 1. And if I were to pass in as the next element a new node with the value of 2, this is 1, n1 dot next would give me the address, and I want the data here, and that's no. And I can do the same thing again and again. So here after this I can do it node 3. This is what it looks like, and I can go to the next element and it's this. So it's quite easy to use it that way, but we want to do it in a little more efficient manner. So all I can do is I can implement it using a linked list. Now inside the linked list, I don't need to inherit it from any other class. Here I am initializing it, and all I need is self. So self, and you can call it anything. Many people call it start. I call it head. So head is going to be the element that is pointing at the beginning of our list. If head is null, which means there is no beginning, that means our list is empty. And if your head is not none, that means that there is some element at the beginning. How many elements are there? That can only be determined by going through the entire list. But we know that there is something at the beginning. That's all we want to know. So with that, we have created the initializer or the constructor function. Now comes the meat of our application. Here we have to implement the insert function or the insert method since it's inside a class. First parameter is self, second parameter is data. Now comes the interesting aspect. So what we do is we create the new node here. So it contains the data and the next pointer is going to be pointing to nothing. Now it is up to you how you want to implement it. What many people do is that they create two separate functions, insert front and insert back. Now this depends on how you want to implement it. I want to keep this simple, so I'm just going to call it insert. Insert front and insert back basically mean I want to insert some data at the beginning of my list, and insert back would mean insert some data at the end of my list. Depending on how you wish to implement it, both are valid reasons. Just understand why you want to implement it at the front or at the back. Now, all I want to check is if, not if self.head is not none. Now I could simply just do this, if self.head. That would lead to the same thing, but I want to be more explicit here. So basically means if there is some value in the head is pointing to, that means our list is initialized and there are some elements already there, and I want to put it at the end. All I have to do is I have to current is equals to self dot head while current dot next is not none. So all I'm checking is, so I'm going to go to the next element till I don't reach the end. So right at the beginning of the end, which I'll show you, current is equals to current dot next. So what I'm doing is, let's say that I have a list in which I have one that point to 2, that point to 3. Let me just make it a little easier to read. Now what happens is I take a look at the head. Head is going to be pointing to 1. From here I take a look at the head and I understand that there are elements here. So I assign this to current, which is here, and then I keep checking does it have any next element. It does, so I go to the next point, which is here, current is equal to current dot next. Then I check if there's some element after it. There is, so I go there. Then I check if there's some element after it. There is not, so current is currently pointing to the end of the list, right? So after reaching there, all I want to do is current dot next is equals to new node. So let's say the new node is 4. Now current dot next is going to be equal to 4. In actuality, it's going to be pointing to none here. So I'm checking if the next element is not none, then move ahead. It is none, so I'm going to go to 4, and its next element is none. And now we're done. So this is how this is working. We have inserted an element when there is no element present inside our, when there is some element present inside our list. But what if there is no element? Well, then we can just basically do it this way. Self dot head is equals to new node, and we're done. I'll have to add an else clause here, and we're done. So we have created the insert function. Now insertion is fine, but what if you want to print the list? That is where we come here. So def print list, and I don't need any argument other than self current is equals to self dot head, and while current is not none. All I have to do is print current dot data. Okay, so this is done. Now all I have to do here is create a linked list, which I can call it anything. I'll call it list, or for simplicity's sake, I'll just call it L. Linked list. I have created an object of linked list, which means this code ran completely, this portion of it. Now I have to insert some data here. So L dot insert 1, that works. 2, that works. 3, that works as well. So as you can see, I didn't have to define a particular size. The size is being automatically generated for me. It's automatically being increased in its size. Now, if I print the list, as you can see that it is going on uninterrupted, right? That's a problem. So let me just call cell dot, and this is a problem that we're going to see in a moment. Restart and clear output is going to be the one. This is also one of the reasons why I chose Jupyter Notebook. And now let's take a look at why this failed. And the reason is quite simple, because we have not moved ahead in our list. What happened is, after we print the data, we want current is equals to current dot next. This is a mistake that many of us make many times. What's happening is printing the current data, and we're going to the next value, and we're checking, okay, now am I pointing to nothing? If not, then that means there is some data left to be displayed. So I'll just rerun it again from the start. Linked list, insert, and print. And as you can see, it's being printed correctly. Now, if I want to print it entirely on one line, I can just, and now it's done. So this is what it looks like. As you can see, it's not really difficult to implement. It's basically 15 lines of code, creating, insertion, and printing. You can also delete the nodes. There's many different articles and different ways of doing it. And now I'd like to show you how you can implement a doubly linked list. So we'll implement it from scratch again so that it gets settled in your memory. To implement it in a doubly linked list, you have to implement it the same way you implemented singly linked list. Firstly, you have to create a node that's going to be a little different from the singly linked list node, and I'll show you why. Hopefully you remember why, but let me just show you anyway. So we need self, then we need data, which could be none. Then we need the next pointer, which is by default none. And then finally, we need a previous pointer, which is going to be equal to none as well. And this is the crucial bit of difference. We didn't have this earlier. So now all I have to do is just self dot data is equals to data, and do the same thing here. Self dot next, and self dot previous is equals to previous. Run this. This is working. Now let's just check if it's working correctly before moving ahead. Node data is 1. Okay, so I print n dot data. This is what it prints. Now I want something to be before and after this, right? Let me just do it this way. Node 1, node 2 is going to be this. Or we can do it this way. We can create 3 nodes. 2 and 3. N1, N2, and N3. So N1 dot next is going to be N2. So right now what we have done is this. We have created 3 nodes, N1, which is 1, which is pointing to 1. n2 which is pointing to 2, and n3 which is pointing to 3. Now what we want to do is, yeah, we want to convert it to this n3 plus n2 should also be pointing backwards, and n3 should also be pointing backwards. This is the whole reason why we do doubly linked list. So n1 should have a reference to the n2, n2 dot previous should have a reference to n1. So this could be done. Then n2 next should be n3, and n3 dot previous is equals to n2. If I do this now, if I were to print n1 dot data, prints 1. If I were to print n1 dot next dot data, I have an invalid syntax error here, n3. Now if I were to do it, if I want to go a step back, I can just do previous, it should print 2. And again, I try to go previous, it should print 1. That's how that looks like. Now if I were to do this, here's if I want to implement a doubly linked list, all I have to do is type class doubly linked list, def init, we pass in self, and that's about it what we need to pass in. The implementation is going to be quite similar. It's just going to be one piece of difference which I will highlight. By default it's not pointing to anything, so it is working. Def insert. To insert something, what we need is the reference to self and some data. So all we have to do, if self.head is not none, which means that there is some value in self.head, then all we have to do is, firstly we have to create a new node as we had done earlier with the data. And now if there are some values, first we have to get to the end of the data. So current is equals to self.head, while current dot next is not none, current is equals to current dot next, and we keep doing that. Once we reach till the end, we make current dot next to be equal to new node, and now comes the new bit. New node dot previous is equals to current. So what happens is, let me just visualize it for you. As we had done earlier, let me just use this. So we have the first node, which is head. It is pointing to 1, let's say, which is pointing to 2, which is also pointing backwards, right? And now we are here.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The next of 2 is pointing to none thus far. We create a new element, which is 3. So we go here, we remove it with 3, and we create the previous pointer to be pointing to 2. This is what we're doing, right? So it's easy to understand, and this is, we can do it very easily. But if there is no element, then basically all we have to do is self.head equals to new node. Quite simply the same code that we had earlier. And similarly, all we have to do is call the print list function, pass in self, while, and also we can current is equals to self.head, and just check if current is not null. We print current.data and we go to current's next point. Run this. We have run into an error, which is if self.head is not null. We are running into an error in line number 7. So it's here. Let's see what is the issue. Is not null, not in not null. That is the issue. So now we have come up with the issue. Now let's create a new node. Let's call it L again, and I'll call it W linked list. Don't need to pass anything. L dot insert 1. Now we want to insert 2. Now we want to insert 3. And now all I have to do is go through the entire thing as we had done earlier. So L dot head dot data, L dot head dot next dot data, L dot head dot next dot previous. So we go one step forward and then one step backwards. Should print 1, which it does. Next dot data 3, previous dot data, and should 2. So as you can see, we have a way to move forward as well as backwards here as well. So that's what W linked list is. You can do other things as well. Deleting items here is going to be a little tricky. So just make sure that you have access to the previous and the next nodes. And that way you can take the previous node's next pointer pointed to the current element's next node. And the next element's previous node should be pointed to current element's previous node. And then you can just remove the data that you have. It's very easy to do, quite easy to do in many ways. So we're done here.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what are these operators? Well, these are some specific characters which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes 2 operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator.
2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So, for example, I'm defining a variable var equal 10. So this equal to is nothing but an assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20. Since the value of var is already 10, so 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, B equal 20. A is greater than B. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay. Let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equals 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright. So let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated.
So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1, and again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. So that's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Alright. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2, since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right. 00 and remove 10 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0010. Now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010 and you are adding 2 bits in the end, since you are shifting 2 bits to the left. So you are getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 triple 0 and one more 0. Alright. Since I'm moving 3 zeros. Alright, since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you are getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array which you had already studied in C, C++ or Java. It's almost same as that. Alright? And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So this was all about the Python token. So moving on ahead, we'll learn about data type in Python. Well, Python has majorly two data types, immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright. Immutable data type consists of numbers, strings and tuples. On the other hand, mutable data type, they consist of lists, dictionaries and sets. Alright. So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has 4 different types of numeric literals: integer, long integer, floating number and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function or complex function. Alright. You have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now what if I want to check the data type of these variables? So how can I do that? So for that we have type function. So print the type of variable A. Alright? Or print the type of variable name. Or print the type of variable salary. Fine. Execute it. Sorry, there's a typo. It's type. Alright. So you can see that variable A is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright. Let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright. Let's perform some operations on string and understand them in detail. Suppose I have first string as hello world and my second string is Intellipaat. Alright. Now what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1 and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello starting from 0 and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 plus 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5 and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str.replace. What I want to replace? First mention that I want to replace me. With what I want to replace? It's m. Fine. Execute it. So you got the output as attachment. attachmnt. Fine. me is replaced with m. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach.replace. So what you need to replace from here is ment. You don't want ment from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the basis of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these three different words are separated by comma. So what I want to do, I want to split the entire string on the basis of comma. So I'll write split str dot split on the basis of comma and execute it. So as you can see, I got the output as three different words: word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals Intellipaat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me, it will be 1. I'll tell you why. See, the output is 1 because, well, remember I told you Python is case sensitive. So both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot u dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me Intellipaat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? Since in capital Intellipaat you have 2 i's. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, at the rate, hash, 123, capital A, small b, small a, c, capital C. Alright. So this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5. Execute it. I must to mention this. Put it under the quotes. Execute it. So the character with maximum ASCII value is small c. Alright. Or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine. So let's move ahead. So well, next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright. So this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal within the parentheses. I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically, concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. What is the invalid syntax up here? Something is invalid, yeah. Let's define it again. Okay, this semicolon is missing up here. Fine. Execute it. So yeah. So this concatenated me and gave me the result as A, B, C, D, E and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3 and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple, I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3 and 4. Fine. So I'll get the output as B, C, D and E. Let's check it. So I got the output as B, C, D and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learned in tuple. It is used to add two or more lists together. Let's define another list as mylist2. Mylist2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with mylist2? So what I'll do, mylist plus equal mylist2. Let's see what is the result. Let's print the value of mylist. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because yeah, I executed it twice. It's my fault. So what you can do, you can just mylist dot remove. Hold on. I don't want to execute this entire list or statement, so I'll define it under different block. So my list dot remove Python okay, I have misspelled Python as okay. Remove this, again remove this, and remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of times. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1 3.14 and Python, and we want a sublist from 1 to 4th index number. like 1, 2, 3. 0, 1, 2, 3 plus 1. Fourth won't be included. So we'll get the output as 1, 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right. It's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different strings. Alright. For example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want? For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position and you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you're grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, one apple, two ball, all are taken as a pair element. Fine. Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, mydict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces. And you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. My set S2 consists of 1, B and C. So if I am performing a union on it, so it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1 2C, 1 BC. So we have 1 and C common in both the sets. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set and it will return the only value which is a unique in first set. For example, we have 1 2C in set 1 and 1 BC in set 2. So if you subtract it, so you have 1 in both the set, so it will emit it. 2 and B, so nothing can be done about it. C and C, again it will emit it. Now since only 2 is left in set 1, so you get the output as 2. Alright? Fine.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So this was all about the data type in Python. So now that your base is clear, let's have a quiz. So what would be the output of the following code? Test1 equal Python programming and print test1 from 2 to 6. In order to know the correct result, do post your answer in the comment section below. Alright, so let's move ahead. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break, and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Let's see the flow of execution. You start it, you check the condition. If the condition is true, then execute block 1. If the condition is false, then go to the else part and execute block 2. Fine. Yeah, this block 1, it comes under if part. Alright. Let's move next. Let's move ahead. Next is nested if else. Let's see the syntax. If condition 1 is true, then execute statement 1. Else, if condition 2 is true, then execute statement 2. If none of them is true, then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition, that is else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, then finally the else block would be executed. That is execute block 3. And yeah, remember one thing, there is no condition associated with the else block. Else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterating variable in sequence, colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement. Again increment the value of count by 1. That is count become 2. And again check if 2 is less than 3. And so on, continue this till 10 is less than 10. And when this thing arrives that 10 is less than 10, your condition become false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright. We have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x. X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for x in fruits. Now x of 1 is banana. Then print x. X is what? Banana. So it would print as banana. Again, it will go back. X and fruit of 2 is what? Cherry. Print x. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code, like a equal 1. In variable part, I got a equal 1, while a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is a is even. A in this case was 2. So 2 is even. Fine. So this is our output. Next, again it will go and increment the value of a by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
For example, a equal 10. While a is greater than 0, check for if a is not equal to 5. If a is not equal to 5, then print A. Else break it. Fine. Let's execute it. Sorry. Just bench A minus. So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition. Alright, let me just show you. Let's just replace this break with continue and let's see what is the result. So yeah, see, got the output as 9, 8, 7, 6, 4, 3, 2, 1, but you didn't got 5 up here, right? Why? So as I told you, this 5 was skipped. Fine. So this was all about the flow control. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instructions that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by user is a user-defined function, right? Syntax. It starts with the keyword def, after that an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b and return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that I'll write a function name as add. Inside that I'll pass two arguments, a and b, semicolon, and this function should return me the sum of a and b. Alright, fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function which returns the absolute value of a number. We have all function which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def, that is keyword. So we are defining the function as print the value of b is b. And again inside the function we are updating the value of b to be 100 and print the new value of b is b. And then what we are doing, change it and we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you how to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30. And the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2. Inside this d is what? Print the value of d is d. Alright. Next we'll define some numeric literals like d of 0 is equal to 99. D of 1 equals 98. And then print the new value of d is again d. Fine. This is my function. Now if I call my function using pass by reference, so my function 2 and I pass the value c into it. So let's see what we get the output. So we got the output as the value of d is 10, 20, 30 and the new value of d is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright, in pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Now let's discuss about the lambda function in Python. So what is this lambda function? Well, a lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10 and then print x inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright, if you change 5 to 10, the output would be 20. Alright, let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes two arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 comma 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass two arguments up here, x and y, colon. Now return me the product of x and y. That's it, it's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass two values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n. So you are defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook. Define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it. So my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the Lambda function. Fine. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon, and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python. So coming to our last topic of file handling in Python. Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it will return you an error. Next is the append. And the mode is A. Alright. What it will do, it will open a file for appending. And in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine, I'll tell you about the difference of appending and writing later in this section. Alright. Next and the final one is create, that is X. It creates the specified file and it returns an error if the file with the same name exists. It creates the specified file and it returns an error if you already have a file with same name. Fine. Let me just show you. Like f equal open path of the file. I'll open it in my D drive. D slash name of the file test file dot txt and comma, what should be my mode? It is a reading mode. R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here and it will create your file. Let's go to our D directory and let me just show you the file. D. So you can see the test file up here, right? So this is how you can open a file in Python. Or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. Test file. Hello everyone. Welcome to Intellipaat. Good luck. Let's save it. Save it as test file.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode r. R is what? Reading mode. And then print f dot read. Fine. Let me just open that file for you. F equal open. The path of the file, it was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f dot read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to Intellipaat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine which would be used to return one line or the first line. Again copy it. Paste it up here. Read line. Just hit enter. Sorry, you got an error. Okay, I read line. Okay, sorry, L is small. Read line. So you got the output as hello everyone. This is my first line. Next, what if I need to read first 2 line of my document? So what will I do in that case? So in that case, what you can do, you can use read line twice. And it will print first 2 line of your text like this. Again do it once more, f dot read line, hit enter. Again the same error. Okay, so what you got? So you got the first 2 line from your text. Alright, now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to Intellipaat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f dot write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, just check the existing file. Open it in a readline mode. R for x and f, print x, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use w instead of a? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen myfile.txt_x, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do, you have to first close the open file. So f.close, inside this, mention the name of the file, or the path of the file, d:/test file1.txt. First close it. Sorry. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Test file1.txt. That's it. Got the error? The system cannot find the specified file. So I guess the file is, no, it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Okay, let's get started with NumPy. So I believe you guys already know like what Python is capable of, how powerful it is. So we can use Python for all sort of things, right? From desktop development, web development till data science, we can do anything and everything with Python in the programming world. And next thing is Python builds upon its functional modules. Okay, so it has all core constructs of programming. Like there are 3 types of programming that we have: structural, object oriented, and functional. So it is capable of doing everything. Okay, next is when we work with anything in Python, we have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to, play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python. So that will be coming along with Pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, Then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program. And then we will have a alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am writing it again and again, pip install numpy, so it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it, we write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be how where it is where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing yes. So we are changing data type from mutable to non-mutable. It's the other one, right? Right. Next is nd array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in the real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to, it all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property, it has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? Sorry, so you need to do this, so you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming, okay, I am working on 2D arrays, sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names, A and B, right? 2D arrays I will be showing you, not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print whole. If we do this, that also will mean the same, and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay. Now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay. This part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay. Now next is, if you go into check the individual, yes, right, so it will be begin colon n minus 1. That is how. So right hand side will always be excluded like that. Okay. Next is NumPy array initialization, right? So how do we initialize NumPy arrays? As we have already seen, right? How do we do that? But still, this is how you do it. Okay. So initialize means what we want to do is, we don't want to place any list in there. Okay. But what we want to do, we want to have some by default values. Okay. Default arrays we want to take it up. Okay. So let's see how we do it. Okay. First one is, we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay. So a lot of time we will be using this zero based or one based indexes. Okay. So for creating a zero based arrays, right, what we need to, come on, what we need to do, we need to have some sort of like some shape of zero arrays. Okay. So that's how you do it. Okay. That's how you do it in NumPy. So what you do, you write np dot zeros, then you specify the dimension of the array. Okay. 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np dot zeros, then row comma column. Okay. That's how a tuple you need to pass it to. Okay. That's this kind of tuple you need to pass it to the Python arrays. Okay. So that's how it works in Python, I mean in NumPy. So that's how you print zero arrays in NumPy. Okay. Next is, if you want something with the interval, right? So how you do, you write like this, np dot array, within bracket we pass, so it will print you another new array. So what we are doing, we are sorry, in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's arrange, so it's a range actually. Okay. So what we are doing, we are passing 3 variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having 5, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have 3 numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay. Till 20 we will print it out. Okay. So that's how this kind of arrays are getting printed out in NumPy. So using this a range, you can have other type of arrays also. Data visualization, why it is needed, what what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture what is data visualization. So data visualization is basically presenting a data, presenting numeric or any kind of data with using I mean using charts and graphs and or any other pictorial formats, right? So by that, what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay. Also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like, see, this is the data that we drill down, and this is what we have found out, so this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field, this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time what you will do is you will grab a already defined and already optimized library that is available in net. Those are all the time will be open sourced. So those open source libraries you can grab and you can use those to use those as it fits your purpose. Okay, so that's what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are going to give a summation like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them like, okay, this is what is the thing. Okay, and we can ask data from clients also. So that's how we can do. Okay, so in those cases, data visualization comes really handy. Okay, and data visualization is presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have, 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some, till 18 you will have some xyz kind of data. But that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, right? Like girls are more initiative in this. Or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this. And next is, I mean, data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just, I mean, just plot this data, if you just show them with the picture, like compare the upper table and the below pictures, the later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always always be using this technique to get some insight from the data, like that. Okay. Okay, so now the things that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right? Like some average, standard deviation and all this kind of average basic stats, then you will see that those have almost the similar kind of values, right? Some is always like 99. Some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you will, where you will see how different the data sets are. How different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right, this will look something like this, that is in my screen. So let me just grab my piece of code for this Anaconda portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried. That is, I mean, already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation. It's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only 1 or 2 points are here and there. Those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data, it is stacked. All the points are stacked in here, because if you check this, all the x values for the last one is set as 8 except one. For one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one, for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this Anascom portrait is a unique data set. Okay, this Anascom just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this Anascom portrait was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with four data set, obviously with four x and y data sets. So for four of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay. So for in here, those four of them are all the four of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay, so that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import Matplotlib into our Python code. So Matplotlib, why Matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this Matplotlib code, right? So that's where what we are doing is, in this Matplotlib code, what we are doing, we are just this is a Matplotlib library, and this is a object oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this xy points, and you can try plotting these points in the plot, like we showed in the last class, right? How to plot a line chart. So you can try it that way also. If you are not having the data set also, so then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this Anascom quadrate picture won't be given, I think so, because I don't have it. If they have updated, then fine, you can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take two arrays x, y, x1, y1, x2, y2, x3, y3, four arrays you can take of x and y, then merge those, like for xy plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see, the equation will fit this one to some extent. So yeah, that will be better. So if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here, we have used plt.plot x and y1. If you even if you for now, if you do even if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now, keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things. No need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done xy1, xy2, xy3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why that? Because if you see, the x part for all these three data sets are same, right? So only one array would do, and for y we have four different arrays, and we have plotted those. Okay, we have plotted those using this plt.plot line. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one, it will take the horizontal axis, second one it will take the vertical axis, so it will have x and y too. Okay, other things we are that will be we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have Matplotlib, ggplot, Seaborn, Plotly, and GeoPlotlib. So all these plots comes handy in data visualization, but the Matplotlib, it has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like, as you saw, right, we have a setup function, we have a access function, text function. All those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is Matplotlib is there. Next is Seaborn. Seaborn is again built on top of Matplotlib, and that's also a very good plotting library. So, but and generally we use Matplotlib the most. Then comes the Seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multi-dimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that like the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multi-dimensional graphs. So 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is this is a next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, I mean sorry, object name dot function name, that's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on NumPy, so NumPy is also possible. I have shown you examples, but this Matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like how what all types of graphs we have in Matplotlib and how that can be used, and what are the usage of those graphs and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used the alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is.
What are exceptions? So let us understand that. Firstly, let us look at the definition of exceptions with regards to programming. In programming, an exception is defined as an event which stops or interrupts the intended flow of a program's execution. So, as a programmer, when you write code, you have an intended flow of how your code blocks will execute, in what particular order, and what exactly you need to execute. So, anything that comes in between, anything that occurs out of the blue, any exception, so to speak, any error that happens that is unaccounted for will totally interrupt your flow, and that is called an exception. And we need to deal with that in programming sense, because otherwise we can break our applications, right? So let's look at this from a technical perspective. There are two types of programming languages that exist. So the first is compiler based languages, and the second is interpreter based languages, right? So in compiler based languages, what happens is all of the code is firstly compiled and converted into bytecode so that the machine can execute it all at once. So in this particular case, before the execution of the code is converted into low level language, right? The entirety of the code. So in this particular case, what will happen is you'll basically have your code structure where the code starts. There will be a code module one, a code block one that will execute, which doesn't have any errors or exceptions. So it will execute successfully. And then if you encounter a code block or a part of the code where there is an exception, a code block, so it will simply throw a compiler error that there is an exception over there, or there's a code error over there. Simply go and fix that. But it will not interrupt the code module 3, at least in the compiler sense of way. The module 3 will compile successfully, and you can even run the code and it has a chance of running successfully. So this is called compiler based languages. These are like, for example, we can take C, C++, Java. These are compiler based languages. All of the code is first compiled and then it is executed. So, on contrary to that, we have interpreter-based languages. Now, in interpreter-based languages, the entirety of the code is not compiled; it is just executed line by line, right? So, Python is one of those languages. Obviously, Python is an interpreter-based language. So the workflow of interpreter-based languages goes something like this. So the code starts line by line, right? The first code module is executed because it does not have any exceptions. It is correct, so it is executed. So the next code module where there is an exception, when that is encountered, right? What that will do in interpreter-based languages is that it will stop the execution altogether. So the next code module will not execute either, right? So what happens essentially in this particular case is that even if the code module 3 does not have any exceptions, it is completely logically correct, right? It will still not execute. So in interpreter based languages, not handling exceptions could lead to the entire application breaking, right? So we want to execute things that are correct, right? Even if code module 2 is wrong, we want to resolve that particular issue and we want to move on to code module 3. So unless we handle these exceptions, that is not going to be possible, right? So exception handling is meant to deal with exactly this. So let us look at the workflow of this particular case if we handle the exceptions. So how to handle exceptions in interpreter-based languages? It is sort of the same for compiler-based languages as well, except we all know the logic of whether all the code modules will compile or not in compiler-based languages. In interpreter-based languages, we do not need to concern ourselves with that. Uh, what exactly happens over here is that the code module 1 will execute successfully as it should. When the exception is encountered in code module 3, we can see a little bit of change in the flowchart, except for the arrow, instead of the arrow pointing downwards from code module 3, right over here, as we can see, the arrow goes to the right, and it basically goes into the condition which says that if there is an exception, execute this part of the code on the right hand side, and then continue as usual to code module 3. So even if there is an error in code module 2, we have created a fail safe for that essentially in this if exception clause. So whenever there is an error which is encountered, we go to the if exception clause, and then the if exception clause continues on to code module 3, and we are able to execute the entirety of the program as much as possible without actually having to stop the execution at all, right? So this is how exception handling happens in a diagrammatic view. So now that we understand the workflow of exception handling in Python, we can look at some examples of exceptions that can actually occur in Python in day-to-day programming. So we'll look at some simple ones so you understand the concept. The first one we're going to look at is called the zero division error. Now, the error name is pretty straightforward. It happens when you try to divide a value by zero, or you basically try to get the remainder of that particular value by zero. So, the modulo operator or the division operator. So, essentially, if you understand this arithmetically, when you try to actually do this in theory, what happens is you get infinity when you divide a number by zero, right? In computational terms, you cannot actually compute infinity. So to deal with that particular issue, what programming languages do is that they throw an exception when you try to run this particular operation, right? So you can design cases to deal with this particular exception if it happens. Other than that, this is what the error is called. It's called the zero division error. Then we have the name error. Now, in name error, what happens is when there is a variable name that you're using, which has not been defined previously, right? And you're directly using it, it'll throw a name error. For instance, if you try to write a statement which is a equals to b plus 3, and you haven't defined the value of b, right? Then it'll throw a name error because this b variable has not been defined. Then next up, you have type error. Now, the type error refers to data type mismatch, essentially. So what happens in this is when you try to basically perform an operation where there is a data type mismatch. For instance, in this particular example, we can see that a equals to hello, which is a string value, plus 4, which is an integer value. We are trying to add an integer to a string without any implicit or explicit conversion, right? We're not trying to convert this particular integer to a string value and then trying to add it. We're trying to add it as a numeric value itself. Now, in programming logic, that cannot happen. We need to convert this 4 into a string if we want to add it to our hello value, right? So in this particular case, it'll throw a type error because there is a data type mismatch between string and an integer. So, if programming languages have defined a variety of exceptions, there must be a way to deal with these exceptions as well. So, what happens essentially is that every programming language has its own way of dealing with these exceptions, right? In Python, there are ways as well. So, let us understand what is exception handling first. Exception handling theoretically is defined as the process of adding fail-safe measures into the code to keep the program running in case of an exception, right? So it's essentially used from the application point of view to stop the application from breaking when an error is encountered, right? So let us understand the various methodologies that Python implements to deal with these particular exceptions. So firstly, we use the try block, right? So the try clause is used to define the block of code that you intend to successfully execute if no exceptions occur, right? So instead of writing code straightforward, like writing print text without the try block, what you'll do is you'll simply write the try and then you'll indent a print statement after the try, right? So this print statement is now under the try clause. So if an exception happens, you can now handle this particular exception. Instead of the program simply giving you an error and stopping, you can now find a way to deal with this particular exception. You can try this code. If this does not work out, you can deal with the exception that happens. So next up, we have the except block, right? So the except clause is used to define the block of code that you would want to execute if and when an exception is encountered in the try block, right? So say in this particular case, suppose the print statement fails. So when it fails, the control goes to the except block and it will print exception, right? So you can deal with this various ways. You can add various categories of exception in front of the except clause to deal with that particular exception only, which we will see in the example that we are going to execute. But this is how you would deal with a particular exception. When you try a part of code and it does not execute successfully, you can straightforward go to the except block and execute that statement, which is present in the except block. Then you have the else block. Now this is an optional block of code that you can use. It is used to define the block of code that you would want to execute optionally if no errors occur in the try block. So say if the print statement executes successfully, the except statement will obviously not execute because you haven't encountered an exception. But the else statement will execute because the try statement did not have any exceptions, essentially. So it will basically print the value of X and then it will print no errors. Then finally, we have the finally block, right? So this particular block of code is also optional in exception handling. You can use this particular block of code when you want to execute a particular set of instructions, regardless of whether an exception is encountered or not. So the finally block of code will execute whether an exception has been found in the try block or whether the try block has successfully executed. It will still execute. So in this particular case, whether the exception prints or the value of X prints, the will always execute will always print. So this is essentially how you handle exceptions in Python. So now that we understand how these four particular clauses work, we can now move on to the demonstration part of this particular tutorial. So let us see how exception handling works in an hands-on experiment. So let us now see some of these exceptions in action. So firstly, let us try to execute the name error. So if we try to do this, A equals to B plus 1, right? And we execute that. So it simply gives us a name error, right? So the way we can deal with this is by simply going over here and adding a try clause, right? So when we add a try clause, we can put a tab statement over here and add in except statement and print the message that we want to print in case this particular exception occurs, right? So exception has occurred. We do that and we click on play. So we can see that instead of this particular statement executing and giving us a name error, we can see the message an exception has occurred, right? So next up, what we can try is something different. We can write over here except name error, right? So this is the category of exception that we want to deal with specifically instead of dealing with all of the exceptions. That is what happened, right? So if we play this as well, we can see the statement exception has occurred, right? So let us try something else with this. We can also add a finally clause over here or an else clause. Let us first try an else clause, right? So when we add an else clause, we can type print no exception has occurred, right? When we do that and we click on play, it still gives us the message exception has occurred because the exception is actually occurring, right? But instead of that, if we simply change the B to 1, right? Now the statement should successfully execute because there is no exception over here now. We click on that and it'll simply print no exception has occurred. And if we type something like print A over here and click on play again, so it'll first print the value of A in the try block, right? And then it'll go to else and say no exception has occurred. So next up, we can try something else. Let us try the zero division error. So in this particular case, what we will do is a equals to 100 modulo 0. Let's try that. And print a, right? Now we can type except name error. So we know that this is not the name error, this is the zero division error, right? But we'll still write that and we'll see which exception is actually caught, right? So print name error has occurred except zero division error will print zero div has occurred. Then we play that and we can see that instead of this particular exception printing, the zero division exception has printed, right? So since we did not catch any name errors, the zero division error was caught when this particular statement tried to execute, right? So instead of that, if we simply go over here and change this to 1, right, it'll simply print the actual output. So when we divide 100 by 1, the remainder is 0, right? We can add something else over here, which is called the finally block, and print hello, right? So in this particular case, what will happen is we play this and we get the 0 from the try block and the finally from the hello block. But that is not all. Say if we change this back to 0, right? Now this means that we get the zero division error once again, right? So now what will happen is we'll get this statement, which is zero div has occurred, in which in this particular case the error was caught, the zero division error, and then the finally block was executed regardless of whether the try block executed successfully or an exception block executed, right? So that is how the finally block works. And finally, to look at the last error, which is the try, which is the type error, we'll simply type try b equals to hello plus 17, which is an integer value, right? We do that. We type print over here, type b, we go to except, and we type in the type error, which is the error that we are probably going to catch over here. Print type error, we do that, and then we can try to add an else statement over here. Print uh, the print statement over here will say something like no exception has occurred. And finally, we get the finally block, which says I am going to print regardless, right? So when we try to execute that, we can see the exact workflow of how this is working out. So the tried statements tries to execute. We get this p equals to hello plus 17. This does not execute because there's a type mismatch, the data type mismatch, string and integer. We go to the type error, right? Now, since an error was actually encountered, an exception was actually encountered, the else statement will not execute as well. So this statement will not execute because error was encountered, right? And then the finally block that we have over here will execute regardless because it executes regardless anyway. So if we simply go back and change this to say 11, which makes this a valid statement now. So it'll change the output So firstly, we will get the 28, which is 11 plus 17. We get the 28. We get the output from the else statement, which says no exception has occurred, no exception was encountered. And then finally, we get the finally statement anyway. So I am going to print regardless, right? So this essentially explains how exception handling works in Python. Now, additionally, we have the option of raising exceptions as well, right? So we have the option of specifically specifying conditions in which we would raise exceptions instead of relying on the predefined exceptions that Python already gives us. So say if we want to throw a type error or an exception in general. So let us type in something like x equals to 14, right? So this is a value, and now x is equal to 14. Now what we can do is simply type in if x is equal to 14, in which case we will write if x equals to 14, and then given the condition of that particular statement, and then what we would do is raise an exception. This is an exception is the message that we're going to use. So when we do that and click on play, it throws that particular exception, which is this is an exception, right? So we can even configure Python in a way, or we can configure our code in a way to throw exceptions on our custom predefined conditions, right? So the raise statement is used for that. We can also do other exceptions with this particular statement. Now, if I simply start a code block again over here, right, I can raise another exception. Say, for instance, I type in a variable. Now I give the variable a string data type. So let us call this string data. Right now, what we will do is we will check the type of this particular variable. Now, to do that, we'll simply type in if not type a. Now we're checking the data type is int, which is the data type that we're actually checking whether the a variable is of integer data type or not. Raise type error and say that integers are allowed. When we do that and we click on play, we get an exception which says the exact message that we typed in, which is a type error and integers are allowed. So that was the example of how exception handling works. I hope you understand the workflow of it and the exact pattern of how these exceptions occur and how you can handle them very easily. You can also see how you can create your own exceptions by using the raise keyword.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
What is an IDE? An IDE stands for Integrated Development Environment. So it is a software application that contains several tools for helping programmers to write, edit, and evaluate their code. So think of it this way. Whenever you're writing code, you need several applications to work together. Things like code editors to write code and save files, compilers to compile the files, to run the files. If you are writing tests, then you need test runners. If you are trying to take a look at the memory consumption of your application, you might be using a profiler. There are many other tools that you can use. For instance, checking the memory leaks, and all of these things can be done using several tools, but they are all interspersed in the coding world. So to bring them all together, what you can do is you can use an application like integrated development environment. So integrated development environment, or IDE, is just a term used to describe such an application, and these kinds of applications are available for a lot of programming languages including Python. So what are the benefits of using an IDE? So let's take a look at them. So there are several benefits of using an IDE or an integrated development environment. Let's take a look at them one by one. So firstly, it allows for rapid development. IDEs provide some really great tools for you to write and edit code in quite a speedy way. They allow you to define code snippets so that you can write just a few keystrokes and expand the code and then fill out the important details. It reduces boilerplate coding. They allow you to generate files. They also allow you to do syntax completion. So if you're typing a long name for a variable or a function or a class, you can just write the first few letters of the entire name, and the suggestion will appear, or whether or not you want to use it is up to you. Then comes enforced standards. So many development environments allow you to use something called a linter. What a linter does is it takes a look at your code and it takes a look at a standard that has been set by a company or maybe by you, and it checks whether the code is following those standards. So these standards could be not more than 80 characters on a line, small method names or large method names, methods that are not more than 6 lines in definition. There could be many other standards that you could use. Many companies use these standards to make sure that the code is clean, it's readable, and many companies also enforce standards such as writing documentation, without which your compiler might not even compile your code. So these standards can be set up depending on what your requirements are. If it's just for taking a look at clean code, or whether it's more than clean code, it's more about tooling and all. So these standards can be enforced using an IDE. Then comes easy configuration. You can mold an IDE, especially there are many IDEs that are really, really easy to configure to your needs. You can change almost anything about many IDEs that you use, going from font to the user interface, configuration about the compilers and interpreters. You can take a look at a lot of things, and you can change all of these things depending on your needs. They do come with a sensible default, but these defaults might not work for you, so you can change them at your own pace. And then comes project management. If you're dealing with multiple projects, then dealing with them without an IDE could be a little difficult. Let's say that your project contains several sub-projects as well. So these kinds of problems can be really difficult to keep track of, and IDEs can help you with that as well. They allow you to export configurations for projects so that you can share that with everyone around your team, and they can use the same thing again.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, another thing that project management that comes under project management is version control systems. So things like Git, GitHub, Subversion, Mercurial, all of these things, they also come under project management. And many IDEs, including PyCharm, have a really good support for using Git and Subversion and Mercurial and other kinds of version control systems. Let's take a look at some of the most popular IDEs. So here are some of the most popular IDEs. As you can see, that's PyCharm, it's IntelliJ, which is also from the same company of JetBrains. Then comes Eclipse. Eclipse is more popular for Java development, but it's not really necessary that it can only be used for Java development. For instance, if you want to use Eclipse with Python, there's an extension called PyDev, PYDEV, that could be really, really helpful. If you are proficient with Eclipse, you know the shortcuts, and you want to use Eclipse for Python development. So for that, you can use PyDev extension. It's a little difficult to install, but if you've already worked with Eclipse before, then you already know how to install it. And once you do, you can use Python with Eclipse. Visual Studio comes with a built-in support for Python. So if you want to use, and if you want to install some additional templates and other things like that, they are also available via the use of plugins. Then comes Komodo IDE. It's also very popular, especially in the Python community. So you can use that as well. Then there's RStudio. It's not for Python, but it's used with R. So it's very useful in that regard. And then as you can see comes PHP Storm. So PHP Storm is something that many web developers use, and since many of these IDEs are free and many of these are not free, and when they are not free, then you need to either download a community version, which is a version of the IDE that comes with limited set of features, which are helpful for you when you get started, or you can buy the pro version or the premium version. Many IDEs have different terms for these, or at the end of the day, you can also apply for a student's license, which if you are a student, they can give it to you either for free or for a much reduced cost. So you can take a look at that as well. Then comes introduction to PyCharm. So let's take a look at what PyCharm is. So PyCharm is an IDE for Python language. It has been developed and maintained by JetBrains. It's currently under active development. New versions are being released every now and then, and new patches are being released every now and then as well. It is one of the most popular IDEs, especially for Python. If you're a Python developer and you are writing code for Python and you're working in large corporations, chances are you have already come across PyCharm. And PyCharm is really, really good for writing code in such a manner. PyCharm has got some really great features. It's got some really good plugins as well that you can use for your Python code. You can enforce standards. You can do a lot of things. Let's have a demo and we'll see how to use PyCharm. So if you want to use PyCharm, the first thing you have to do is you have to download PyCharm. Now it's very easy. Go to Google, and first thing you have to do is you have to download Python. So you can go to python.org, click on downloads, and download the latest version. Mine is 64-bit Windows, so it already gives me that version to download. And if you don't find the version you want to download, you can scroll around and get the version that you want to. Downloading the latest stable version would be the best way to go. After you have installed Python, you can install PyCharm by downloading it. So you can just search for PyCharm, click on the download link that is given to you in your Google search. When the link opens, it will show you multiple options to download. One of them is the professional version and the other one is the community version. So the professional version is quite useful, especially for those who need the premium features that come with PyCharm. And for those of you who don't really need the premium features, just want to try it out, just want to make sure that you get the basics of PyCharm correctly, then you can download it using the community version. The community version is extremely easy to install and really easy to use, and it's free. And the professional version, although it's not free, gives you a free 30 days trial. So you can use that. It's available for both Windows, Mac, and Linux. I'm using Windows, so I have downloaded Community Edition and I have installed it. Installing it is really easy. So let me just open it for you. I've already installed it, so I'm not going to go with the installation again. But if you want to install it, just open the installer and it will work just fine. After you install it, it gives you the option of opening the PyCharm IDE right there. As you open it, it gives you the opportunity to create a project. If you already have a project, and bear in mind that this has to be a PyCharm project. A PyCharm project basically is a folder with a .idea folder in it that contains all the configuration that PyCharm will use. So you don't need to worry about that. You don't have to use these. You don't have to edit those files yourself. But if you don't already have a PyCharm project, then I would suggest you create one using create new project, which is what I will do. Now, this is just the basic setting. If you want to take a look at some advanced settings, you can take a look at here. Now, you can take a look at the environment that you can use. If you are working with scientific computation, you can take a look at Conda. Pip-N is for creating a virtual environment using virtual-N or Pip-N. I like using Pip-N. It allows you to isolate your dependencies. So if you're trying to use some library such as Django or Flask, but you already have it installed, and now for this project you want to use some new version, you can use a virtual environment in which all the libraries you install will stay in that library, and that for that project only. No other project would be able to access those libraries. So you can use that. And you can take a look at the interpreter. I have Python 3.7. I have Python 3.7, and you can also take a look at Anaconda's distribution of Python if you have and you want to use that. So with that selected, if you have an existing interpreter and you don't want to use the current interpreter, you can just click here and browse for it and then use it. But as of now, I'll be using the base interpreter that PyCharm has already detected for me. I need to change the name of the project. I'll call it Intellipaat demo. I have used pipenv because I find it really easy to use, but it's your choice. If you want to use virtualenv, you can use that. If you want to use Conda as your development environment, you can use that as well. It's totally up to you. Click on create, and the first time you use it, it will take a little bit of a time because it's setting up a virtual environment for you, and virtual environment takes some time. So as I had already created say demos like this, it will create a virtual environment for me, and if it already finds a virtual environment, it will just use that virtual environment. As you can see, it's creating the virtual environment, so let's just wait for a few seconds, and when it gets done, we'll get started with the next steps. Now, if it's just a new installation, then it could take a little bit of time for you. And if you have already installed it and if you have already used it, then it might not take that much of a time. So don't worry about it. It will just take a few moments. And when it does, it will open everything up and it will start creating something called indexes. So let me just tell you what indexes are. They are basically things that your PyCharm IDE will create so that it's easy for it to scan the entire project and find files. So that, as you can see, it's launching the skeleton generator. Everything can be seen here. It's discovering the module, reloading the generated skeleton. Skeleton is basically the project structure that it has generated for us. Now it's telling us that it's indexing, which is basically it's taking a look at scanned projects and it's taking a look at all the files that we have, so that when we try and scan something or search something for it, will be able to much more speed and accuracy. So now that that is done, we can use Python for whatever we want to use. So as you can see, this is the folder that I have. I can click on this arrow to expand it. As of now, since I used pip, I only have pip file. If I open it, this is what it looks like, and it's giving me an option to install a plugin that will help me create to get syntax highlighting and better support for pip files. I don't need to do that right now. I'll show you how to install packages in a moment. But first, let me just create a file and show you how to run it. To create a file, right click on the project that you want to create a file in, go to new, and I want to create a Python file, and since it's giving me that option, I'll just create on Python. This has to be a Python file, not a Python unit test file, not a Python stub. So I'll just create a Python file. I'll name it main, and I'll press enter after giving it the name. If I don't give it the name, then I won't be able to create any files. It'll create one for me. Now, as you can see, this is fine, but the code editor looks fine. It's working fine. If I type something, as you can see, it's working fine. The problem that I have as of now is that the text is really, really small. So let me show you how to customize Python to your own taste. So go to settings by clicking on file. Once this appears, you can take a look at a lot of things. It opens with the editor setting, but you can take a look at a lot of things. If you want to search for some setting, like let's say font, click here and it'll show you all the things that you care about. I need to change the editor font, so I have that here. Now it is by default using the JetBrains mono font, but I want to use Fira code, and I want to increase the font size, let's say to 18. Let's say to 16, and for line spacing I can take a look at this as well, and as you can see, I get this nice preview right underneath it. So after doing that, I can also enable ligatures. So enabling ligatures basically means that it will allow the code to dictate how it wants certain symbols to look. So if I disable the ligatures, as you can see that not equal to will look like an exclamation point and then an equal to symbol, but if I enable the ligatures, then it looks something like this. So the font will now dictate how certain combinations of symbols should look like. I click on apply and then I click on OK, and now as you can see, the font has been changed. Now you can play around with it a bit, but it works fine. Now let me just write some Python code and then execute it so you can see that it works. So the first thing I'll do, and as you can see, I have syntax highlighting. So if I type in name and I get the suggestion that I want, and I want it to be equal to main. Now if you don't understand this, don't worry, this is just some simple Python code, and I'll even show you some resources through which you can learn Python if you want to get started with Python, and you can already see how we can use PyCharm. So I'll just create a function named main, and here I'll just move the code. For those of you who are wondering, I'm using the shift key and then moving things around. So if I use shift and then press down key, the PyCharm will automatically insert the pass keyword, but I don't want that, so I'll just do it here. So now what will happen is my script will get executed. It'll take a look at the file name, and it'll take a look at an internal variable called name, which automatically gets set. So if I use this file to execute every other file, then I'll get main, and then it'll execute this function, and it will print hello. So to do that, there are many ways I can do it. I can just click here and run it, or I can go to run, click on run, which is here. I click here, I want to run main, and it will run it for me. And as you can see, it's printed hello, and the process exited with the code of 0, which means everything went successful. Now let me show you what else you can do. Let's say that this is not just one file and you use multiple files. So I create another file in which I'll create a configuration class. Let's say configuration helper. Okay, this will be the name of a Python file. I click insert. I'll type in some code, configuration helper. Firstly, I'll define a constructor, and in a moment I'll tell you how I'm doing this. So just type in, as you can see, let me just show you again. I type 2 underscores. It shows me all the things that I can do. I press the tab key. It automatically does everything for me. And now I'll just print construct. Okay. So now if I want to go back to this file, let's say I have multiple files and I've closed this file, first thing you can do is press the shift key twice. So shift 1, shift 2, and you need to do it really fast. And then as you can see, recently opened files are showing here, but if I want to open a file, just type main. It will show me the main method as well as the main file. So let's say that I want to go to the method wherever it's declared. It's showing me the file name right beside the function name as well. I press enter and it automatically takes me to that function. Now that that is done, let me just import it. So I need from configuration helper, import configuration helper. I'm using the control and space key together. So hold down control and press space to get automatic completion. And after doing that, all I have to do is create, let's say, an object out of it. This gets done. So now what will happen is if I run this, I can run it from here, and you can take a look at some of the shortcuts as well, which is Control Shift F10 if you want to run it. So the constructor gets run first and hello gets put second. Now, as you can see, I have made a spelling mistake, which is deliberate because I want to show you some of the other features of PyCharm. But first, if I want to go to that file again, hold down Control key and then hover over that class name. I click on that class and I am immediately taken to this file in which I have declared this. Now, as you can see, I have mistyped the name. So as you can see, it's already giving me an option to do something about it. But another thing I can do, and I want to show you this, is select the class name, right click. There's something called refactor. So if you can see, it's here. And then it also gives a shortcut key, which is Shift F10. Click on rename. And I want to rename it wherever I can, and in the project files you can click on all places as well, so that it can take a look at all the places available to PyCharm and rename anything that's named like this to configuration helper. So as you can see, configuration helper. Now I can click on preview and it will show me all the changes that it will make. So these are the files in which the changes will be made. Click on do refactor. Now it has changed it here, but it has also found out that I'm referencing configuration helper in the main.py file, and it has changed it here, here, and here as well. So these are the kind of facilities that you don't get when you're trying to code it out in a simple notepad or simple text editors. And these are the really powerful benefits that you get when you're using an IDE. Now that that is done, let me just show you another thing, which is the debugging capabilities. So I'll just create another function, print with hello, and all I'll have to do here is I have to print, and I'll do some Python code here. I'll format the string, and inside the format all I have to do is pass in name. So what it will do, it will take a look at the string, print hello, comma, and then takes a look at a variable. I can remove this as well, and takes a look at the variable named name and prints that for us. Replaces this empty brackets into name. This is what's known as Python string interpolation also. So you can do that as well. And now, just to make it a little more complicated, I'll just create another function, def get config name. And as you can see, as soon as I type this character, which is an opening parenthesis, PyCharm automatically types self, closes the parenthesis, and types a colon for me. And all I have to do is return default config. Save this, go here, and now if I run this, it works fine. We get constructor, we get hello, and instead of doing this, now what I will do is I will print with hello, but I will use the config get default name. And now if I run this, you will see that the execution will be changed a little. We get constructor hello and this. Now if I want to debug this, debugging basically means stepping through the code line by line to see what has changed. Now this is really easy to do, especially in Python. I want to debug from this line, right? So I can, instead of running it, click on debug main, or I can click on debug as well and choose main. As you can see here, if we do that, and that happens, starts debugging, and we get here. As you can see right now, no variables have been declared in memory, so we get nothing. And we get options to step over some code, step into the code, step into to see your code. If it's a library code and you don't want to step into it, then you use this function, which I will do in a moment. And you get to step out. So I want to step into my code and see what happens when this configuration helper gets instantiated. Click here, it opens the file, it gives us the name of the value of the self variable. If I open it, it's giving me the memory location as well. And as you can see, nothing's been initialized as of now. I step in, it prints constructor. If you want to take a look at this, you can take a look at console simultaneously, and you can see constructor has been printed. Now you go ahead, print hello world, take a look at the console, it gets done. Only the config variable has been created. As you can see, there are no variables associated with the config object. And I then step into the function, it returns default config. After that, it steps into the function that we have declared with the print with hello function, prints everything, and then exits because that was the last line. Everything has been printed and we have come to the end of our code. So that's how you can debug things. Now that that is done, let me show you something interesting. Let's say that you want to, after going to that, click on settings. There are many settings available for you. You can install some plugins to make changes to the way things work. If you are using Vim as the code editor, then you can install the Idea Vim plugin. You can change the look at the material themes as well. There are a lot of things that you can install, and these things either upgrade the functionality of some existing feature, or they introduce new features as well. For version control, you can take a look at many other version control systems like Git. If you want to add a GitHub repository, you can do here as well. Mercurial, Subversion. And finally, for our project, we can take a look at Project Interpreter. Right now, we have not installed any package, so we don't have to do anything. If you want to install a package, click on the Add button. And as you can see, it's getting the list of available packages. Let's say that I want to install Flask. This is what the current version is. If I want to install Flask, I can just click on Install Flask. If I want to specify a version, here are the list of available versions. So you can see it's very graphical, very useful. I'm not going to install Flask right now because I'm not going to be using it in this demo, but you can do it if you want. So with that in mind, this is what it looks like. This is what a breakpoint is. So when we were debugging, I put a breakpoint here so that I can just debug my code and the execution will stop here. And from that point on, I can just step into the code. So it's very easy to do if you want to do it. So there are a lot of features that I can go into. This could be a really long demo, but to help you get started, I hope this was quite enough and has whetted your appetite. And if the Python code was not something that you understood, don't worry, I'll guide you to the resources that can help you out. But the intention of this demo was to help you get started with PyCharm, to help you understand how you can use the basic features, how you can customize it to your liking. You can change the theme, you can do a lot of things that you want to do, how you can navigate around the code, how you can debug the code. There are a lot of things that you can do.
So NLP is a subfield of artificial intelligence where we teach computers how to understand and interpret human spoken languages, or in other words, natural language. So what in the world is text mining? Well, simply put, extracting information from unstructured textual data is known as text mining. Now, let's say there's a 500-page thesis on some financial topic, and you come across a sentence which ends with the number 30. Now, you have absolutely no idea what that number means. It could be the number of days in a month, the amount of dollars a stock increased over the past week, or the number of items sold in a day. So, this number 30 could mean anything. And without proper context, you wouldn't get the right information. And this is where text mining comes in. So with the help of text mining, we can give proper context to the words before and after the number 30. And this would help us to find out more information. Now let's look at the need of text mining. So today, with the advent of social media, companies now have access to massive behavioral data of their customers. And most of this data is present in the form of unstructured textual data. But beneath this textual data lies an enriching source of information which can help companies to boost their business. And this is the reason why text mining is being used across various industries. Now, text mining can be divided into 4 practice areas. So we've got information extraction, which basically deals with identification and extraction of relevant facts and relationships from unstructured data. Then we have document classification and clustering, which aims at grouping and categorizing terms, paragraphs, or documents using classification and clustering methods. After that, we have information retrieval, which aims at storage and retrieval of text documents. And then we have NLP, which forms the major part of text mining. So here we use different computational tasks to analyze and understand the underlying structure of the text data. Right, now we'll dive into NLP. So when you hear the term natural language processing, the first question to pop into your head would be, what is a natural language? So any language that is used for communication by humans is known as natural language. So English, French, Chinese, all of these are natural languages. Now, since we are humans, we're able to understand these languages. But what about a machine? How is a machine able to comprehend all these human spoken languages? Well, this is where NLP comes in. So natural language processing is a subdomain of artificial intelligence where we understand and interpret human languages using a computer. Now let's see how is NLP used in text mining. So just think about how much text you see each day. Email, SMS, web pages, the list is just endless. So with the help of NLP, we can go through all of this text data and use it for different purposes such as character recognition, sentiment analysis, and spell checking. Right. Now we'll go ahead and install Anaconda into our systems.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So Anaconda is basically a free and open source distribution for Python and R programming languages. And it is specifically designed to perform data science and machine learning applications. Right, so these are the 4 steps to work with Anaconda. So first we'd have to download the Anaconda installer and then we'll install Anaconda. Then we'd have to open Anaconda prompt and update Anaconda. Right, now let me just guide you how we can do this. So first we'd have to go to this website, anaconda.com distribution download section, and you'd have to download the version for whichever operating system you're using. So if you're using a Windows system, then you'll download Anaconda for Windows. If you're using Mac, then you'll download it for Mac. And if you're using Linux, then you'll download it for Linux. Now, you've got 2 versions of Python. So Python 3.7 and Python 2.7. And we'll be downloading the latest version of Python, which is Python 3.7. So once we download this, we have this setup wizard over here. So we just have to click on next and it'll take care. Now, once the installation is done, we'd have to open up the command prompt. So this is what we get when we open the Anaconda prompt. Now inside this, we'd have to type in conda update Anaconda and we'll have the latest version of Anaconda in our system. Alright, now let me just go ahead and show how to do it. So I'll just type in download Anaconda. I'll click on this link over here, Anaconda Python R distribution. And over here, I'll click on this download. So I've got different versions over here for Windows, Mac and Linux. And since I'm using a Windows system, I'll download Anaconda for the Windows system. So this is the latest version of Anaconda, Python 3.7. I just have to click on download. Right, so once the download is done, I'll get a setup wizard and I'd have to set it up. And I'll go and click on Anaconda prompt. So this is my Anaconda prompt over here. So now that we've successfully installed Anaconda into our systems, we'll go ahead and work with the OS module. Right. So the OS module, it provides functionalities to perform operating system dependent operations. So these operations include creating directories, creating, renaming and removing files and many other tasks. And these are the different methods we've got. So we've got os.rename, os.open, os.list directory, os.make directory, os.get current working directory and os.fdopen. Now to work with the OS library, we'd have to launch the Jupyter Notebook. So we can either launch the Jupyter Notebook through Anaconda Navigator or we can launch it through the Anaconda prompt. So Anaconda Navigator basically provides you a GUI. So you can either use this or the Anaconda prompt. Now when you open the Anaconda Navigator, you have Jupyter Notebook inside this and all you have to do is click on launch. Now once you do that, you have your Jupyter Notebook right in front of you. So over here, you'd have to click on new and open up a new Python notebook. Now once you do that, you have a new page and over there you'll be performing different operations. So your first task would be to import the OS library. So you'll just type in import OS. Now if you want to have a glance at the current working directory, all you have to do is type in os.get current working directory and it will give you the current working directory. And if you want to create a new folder, then you'll type in os.make dirs and then you will give in the path. After that, you will give in the name of the directory which you want to create. So let's perform this. So again, I'll just type in Anaconda prompt over here. Now inside this, I'll type in Jupyter Notebook. Right. So now we see that we've launched the Jupyter Notebook over here. Now I'll click on new and I'll open up a new Python 3 notebook. So our first task was to import the OS module. So I'll type import OS and I've successfully imported this module. So as I stated in the PPT, the OS module is basically used to work with different operating system applications. So you can create different directories, you can open up new files, you can rename files and so on. So our first task over here is to have a glance at our current working directory. So I'll type in os.getcwd and I'll put in the parenthesis over here. Right, so this is my current working directory, C users Intellipaat. Now I want to make a new directory in my C drive. So this would be the command for that. So I'll type in os.make dirs and over here I'd have to give in the path. So I'll type in C:/ and I'll name the folder as, let's say, new folder. Let me click on run. Right, so now I've successfully created this folder. Now let me actually go to the C drive and see if this folder exists or not. So this is my C drive over here and I see that we have this folder with the name new folder. Now we'll go ahead and perform some more operations. So let's say I want to open a file which is present in my system. So to do that, I've got this command os.open and inside this I will give in the path of the file and then I'll give the name of the file. After that, I also have to give the extension of file, right? So this is a text file, so I'll type in file.txt. And over here, this is basically the flag. So over here, I'd basically be setting what sort of operation I want to do. So O_RDWR, it stands for read and write. So I've got different operations. So I can open this file in only either read format or write format or read write format. Now, after that, we set in another parameter over here, which is os.o_create. So this means that if a file with the name file.txt doesn't exist, then it'll automatically create this new file and then it'll open it up. And then we've got another operation. So if I want to have a glance at all of the contents which are present in a folder, then for that the command would be os.list_dir and I will give in the path. So over here I want to have a glance at all of the contents which are present in the D drive. So I'll just give in D over here. So these are all of the contents which are present in the D drive. Right, so now I'd want to open this sparta.txt file using the OS module. So let me do that. So the command was os.open and inside this, as we saw, first we'd have to give in the path. So let me copy the path over here. I'll click on properties. I'll copy all of this and I'll paste it over here. You'd have to keep in mind that you'd have to give in / over here. So the path over here. So to separate all of these, you'd have to give in a /. Again, you'll give in a double slash over here, and then you will give in the name of the file. So the name of the file is sparta.txt. After this, I'll give in the flag over here, which would be os.o_lb read and write. And then I'll give in the pipe operator. So over here, I'll just state if the file doesn't exist, then I'll tell the operating system to create it. So os.create, I'll click on run. Right, so we have successfully opened this file. Now I'd want to have a glance at all of the contents which are present in the C drive. So I'll type in os.list directory, and inside this I'd have to give in the path. So I'd want to have a glance at all of the contents which are present in the C drive. Right, so these are all of the folders or all of the contents which are present inside the C drive. Then I have a couple more commands over here. So this is the command to change the working directory. So over here, I am changing my working directory from D drive to my folder. So I just have to give in the path for this, and this is how I can change the current working directory. And then we can also change the name of a file. So let's say if the name of the file was oldfile.txt, then to rename it, I'll just give in newfile.txt over here. So let's perform both of these operations. So let me perform both of these operations over here. So I'll type in os.chdr, and inside this I'll set the working directory to just C drive, C:// right. I've changed the working directory. Now let me also check the current working directory now. Right, so now I've changed the working directory to C drive. Now let me go ahead and rename a file over here. So I'll type in rename. So over here this takes in two parameters. First is the path where the file is located and the name of the file. So I'd just rename this file over here Sparta. Right, so as we saw earlier, the name of the file was sparta.txt. Let me also remove this over here. Let me just put in a single quotation mark. Now after this, I'd have to rename this. So I'll copy this all again and I'll paste it over here. Now I'll change this to Sparta new. I'll click on run. Right, so now we see that we've got a new file over here. So initially it was sparta.txt. Now we've changed it to Sparta new. Right, so that was the OS module. So the OS module, we saw how can we create new directories and how can we change the names of some files. Now we'll go ahead and do some proper file handling in Python. So the IO module is the default module in Python that is used to perform file handling operations. And it contains functions that return a file object called handle. And this handle is then used to read from a file or write to a file. So this is the command to create a file object. So we'll be using this function from the IO module. So open, and this has two parameters. So this is the first parameter file, and over here we'll give in the path of the file or just the name of the file. After that, we've got the mode. So over here, this mode basically specifies the way we want to open a file. So we've got these different modes over here, R, R+, W, and W+. So R basically stands for read only mode, right? So if we open a file in read only mode, then we can't edit it. So it's only read only mode and it starts from the beginning of the file. After that, we've got R+, which stands for read and write mode. So over here, the file pointer again starts at the beginning of the file. And with this, we can read the file as well as write something in the file. Then we've got W, which stands for write only mode. And even this, the pointer starts at the beginning of the file and it starts to overwrite the existing file. Then we've got W+, which allows us to write and as well as read. Now this doesn't start from the beginning, but it actually starts at the end of the file, right? So we can start writing from the end of the file over here. So these are the different modes which we can open a file. Now these are the different methods from the IO module with which we can read from a file. So now let's say we've opened up a file. So open, and then I'll give in the path, and I'm opening this in read only mode. Now I'll store the file in this F1 instance over here. Now if I want to read the entire file, I'll just type in f1.read over here. So this would give me the entire file over here. Now instead of reading the entire file, let's say if I want to read only the first line over there, then what I'll do is I'll type in read line. So I'm storing this file object in this F1 instance over here. After that, I'll type in f1.readline, and this would just give me the first line over here. So let me perform these two operations. Right. So I'll type in import IO over here. Let me load this up. Now I'd have to open the file. So open, I'll take the path. So I want to open up the same file, which is sparta.txt. Right, now I want to open this in read only mode. So I'll type in R over here. Right, so I've also given the board. Now let me click on run. Right, so I've created an instance of this file. Now let me go ahead and read the contents of this file. So I'll type in f1.read. So these are the 3 lines which are present in this file. This is Sparta, this is 300, and this is Intellipaat. So let me just verify this. I'll open up this file, right? So these are 3 lines. This is Sparta, this is 300, and this is Intellipaat. Now, as you see, all of these 3 lines are separated by /n. So over here, /n denotes a new line over here. Now, instead of reading all of these 3 lines, I want to read only the first line from this file. So the command for this would be os.readLine. Right, so now let me click on run. Right, so I've just read 1 line from this entire file. Now we'll see how to read a file line by line using for loop. So again, first we'd have to open up the file and save this file in an instance. So over here I'm saving this in F1. After that I'll start the for loop. So over here I'll create a new variable. So for line in F1, and this line stores every line which is present in this file over here. So it'll store the first line, and then we are printing the first line. Now once that is done, it'll go back and then print the second line, and it'll go back and then print the third line, right? So this is what happens. Now after we print all of the lines, I'm just typing f1.close. So when I type f1.close, it'll just clear all of the buffers and close the file. So I'll just type in for line in f1, and over here I want to print f1, right? So let me start off by using the for loop. So I'll type in for line in f1, and I'd have to print each of the line. So I'll type print line, and I'd have to close the buffer. So f1 dot close. Let me close this. Now let me click on run. Right, so let me start off by using the for loop over here. So I'll type in for line in f1. So this is f1 and not s1. I'd have to print each of the lines. So I'll type in print line, and then I'd have to close the file. So I'll type in f1 dot close. Right, so let me run this. Right, so I've extracted each of these lines with the help of the for loop. So we've got this is Sparta, this is 300, and this is Intellipaat. Now let's see how can we write something to a file. So to write something to a file, we can use the write method. So again, we'll have to start off by opening the file, but this time we'll be opening this in write mode. So over here, I'll set mode is equal to W, and while writing, I also have to set the encoding type. So the encoding of this file is UTF-8, and what I'll do is I'll add 3 new lines over here. So I'll type in, this is the first line, this is the second line, and this is the third line, and these 3 would be added to this current file. Now instead of adding one single line, let's say if I wanted to add multiple lines over here. So for this, what I'd have to do is I'll create a list, and inside this list I'll separate these 3 items with the help of /n. So as we already know, this /n, it denotes a new line. Right, now after that we'll open the file, and over here we'll open this in the mode A+. So A+ stands for the append mode, and we'll write this entire list into the file over here. Now let's perform these operations. Right, so what I'll do is I'll copy the same command over here and paste it over here. So the file would be the same, and over here I'll set the mode to be equal to W. So W stands for write, and after this I'd have to set the encoding. So encoding would be equal to UTF-8. So I'll type in UTF-8 over here, and I'll click on run. Right, so I've successfully opened this file in write mode. Now I'd have to go ahead and write something into this. So I'll type in f1 dot write over here, and let me write something inside this. So let me add the first line over here. So the first line would be this is 1. I'll click on run. Then I'll type, let's say, f1 dot write, and I'll type this is 2. I'll click on run again. Then I'll type f1 dot write, and I'll add the line this is 3. Now let me go ahead and open the file. So this time I'll open the file in read only mode. So I'll set this mode to be equal to R, and I'll remove the encoding from over here. I'll click on run. Right, now I'd have to type in f1 dot read. Right, so this is what I have. This is 1, this is 2, and this is 3, right? So I've successfully added these 3 elements into my file. Now, as you see over here, my file initially had these 3 lines over here. This is Sparta, this is 300, and this is Intellipaat. Now, when we use the write mode and we entered these 3 lines, this is 1, this is 2, and this is 3, what it did was, it replaced these 3 lines with this. And this happened because the pointer starts at the beginning of the file. And when the pointer starts at the beginning of the file, all that which was there initially, that would be replaced. So let me go to the file now and see how it looks like, right? So I have a single line now. This is 1, this is 2, and this is 3, because the earlier thing was replaced. Now I'll go ahead and actually create a list over here. So I'll name this as L1 and I'll add some values over here. So let's say the first value is A. I'll add a new line after this. Then the second value is B. Again, I'll add a new line after this. And then I'll add a new value, which is C. After that, I'll add a new line. Now I'll open this file in append mode. So this would be the same. The mode would be A plus. And I'd have to give the encoding again. So encoding would be UTF-8. Right. So this time I've opened the file in append mode. Now what I'll do is I will go ahead and add this. So f1 dot write lines, and inside this I'll just put in L1. Now I'll go ahead and open the file. Let's see what do we get. So I'm opening the file in read mode now. Now let me read what we have in this file. So now I have successfully added these 3 characters over here, A, B, and C. So now let me open the file, right? So this was the first line. After that I added A, B, and C. Alright guys, now let's see how can we work with Word document files. So we have this library with the name Python docx, and we can use this for creating and updating Microsoft Word documents. So to install this library, we'll again have to go to Anaconda prompt, and inside Anaconda prompt we'll given this command conda install -c conda forge python docx. Right, so with the help of this command we'll be installing Python docx library. So once the installation is done, we'll go to either Anaconda prompt or Anaconda navigator and then launch the Jupyter notebook. So we'll open a new notebook over here, new Python notebook, and we'll type in import docx. So here you have to keep in mind that when importing the library, you'd have to type docx and not Python docx. So you'll type in import docx. So once you import the library, now let's see how can we create and update a Word document. So starting off, we'd have to create an instance of our Word document. So to create an instance, we'll invoke the document method. So we'll type in docx.document and we'll create an instance of the Word document. So I'm naming this instance as document. Now once we have this instance, we can add all of the content into our Word document. So I'll type in document.add heading, and with the help of this I can add a heading to my document. Right, so over here I'm adding the heading. This is a 0 level heading. So here 0 indicates the level of the heading, right?
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So once we add the heading, now we are going ahead and adding a new paragraph. So here I'm typing document.add paragraph and I'm just writing this is a paragraph. And after that, if I want to add a page break, so we can use this method document.add page break. So we created an instance, and with the help of that instance, we added a heading and we also added a paragraph. Now it's time to save the document. So to save the document, we'll type in document.save, and inside this we'll give in the name by which we want to save the document. So I'm saying the document as document.docx, right? So this is how we can create a document. Now let's see how can we read a Word document. So to read a document, we'd have to start off by importing this document method from docx, and then we'll use this document method, and inside this we'll pass in the name of the document. So we'll pass in document.docx, and this is the file which we had just created earlier, and we'll save this in a new instance and name that to be doc. So once we have this instance over here, we'll use the for loop, and with the help of this for loop, we'll print all of the content inside this document. So I'm typing in for para and doc.paragraphs, print para.text, right? So it'll take in each paragraph over here and it will print each paragraph with the help of this for loop. Right, now let's go to Jupyter Notebook and actually perform this. So I'll start off by importing the library, which is docx. So I'll type in import docx. Now I'll go ahead and create an instance of this. So docx.document, and I'll name the instance as doc. So now that I have the instance, I can add the content into this. So I'll type in doc.add heading. Now let me add the heading. So I'll just say heading 1 over here, and then I'll add a couple of paragraphs. So this time doc.add paragraph, and inside this I'll type in p1, and then I'll add another paragraph. So I'll type in doc.add paragraph again, and I'll add p2 inside this. After this I'll add a page break. So I'll type in doc.docx. Right, so now I have successfully saved this file. Now it's time to read this document which I've just created. So I'd have to import document. So I'll type in from docx. I'd have to import document. Right, so now that I've imported this, so I'll just give in the name of the doc which I've just created. So my doc.docx, and I will store this in a new document again, and I will name this as d1. Right, so now I have created a new instance of the document which I had created earlier. Now I'll use the for loop. So for para in d1 dot paragraphs, and I'll just print this out. So print a para dot text. So now we have the content which is present in the document over here. Heading 1, para 2, and then we added a page break. After that we have the heading 2. Right, so this is how we can work with the docx module. Now,
so at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
REST APIs are quite useful, and Python is quite easy to use when we're trying to build REST APIs. So in this session, we'll take a look at how to combine your knowledge of Python and web applications and how to deliver the data that you want to deliver via a web service or a REST API. And in this session, we'll take a look at what REST APIs are, what are APIs, how do you use REST APIs, and then we'll bring a quick demo in which we'll be using the Flask web servers to build a web API using Python. So without further ado, let's start. But before we begin, if you have any questions, then please do ask in the question section. And for those of you who are joining via YouTube, there's a link in the chat box that you can click to join this as a webinar, and then you can ask me questions in real time so that I can answer them. So let's take a look at the agenda for this session. So in this session, we'll take a look at what are data types. Then we'll take, okay, so this is, so we'll take a look at APIs first. We'll take a look at what are APIs. Let's take a look at what APIs are. So an API stands for an application programming interface. So in case you've ever wondered how two applications interact with each other, or how two applications can connect to each other and then can pass messages, then APIs are the way that we do it. So in case you've ever logged into a website and they give you the option to log in via your Google account or Facebook account, you might be wondering how they do that. Do they get the access to the Facebook's database servers and use those credentials to then log into the Facebook's databases and then authenticate you? That's not really a secure way to do it, but a more secure way to do it is via APIs. So that's why we use APIs to expose certain endpoints or certain procedures that other programs or applications can use to talk to us, to describe to our application what data they want, what applications or what processes they want to perform. This API transaction or API communication also allows for a lot of other kinds of applications like cloud computing applications, in which you are basically offloading a lot of your computations to cloud computing. And this is also something that is done via an API. So APIs are quite prevalent, but a particular type of API is called a REST API. So what are REST APIs? Well, when you take a look at an API, you could be many kinds of APIs, but if you're looking at a web API, then it's most probably a REST API. So REST API is basically a standard. It's an architectural style. It's how you define your URLs so that the person who's trying to get something from your API can describe the best way that he or she can the data that they want. And then our APIs respond to those requests. So these requests work on URL parameters and methods. So to give you a quick introduction, if you've ever worked with HTTP, which is the protocol that the internet uses, there are several methods that you can use. A method is basically just the intention of your request. So for instance, if you wish to get some data, if you wish to get data from a web API, then you use the GET request or the GET method as is shown in the image below. You use the POST request to submit some data to the web API so that you can save it. The GET request with a ID or a unique identifier gets you a particular record of that. So for instance, if I have a web API that is serving up user information, then I can just tell it to get me all the users or save a user to my database. Or if I give it a particular ID, then my API will check in my database to see if that ID belongs to a particular user. If it does, then I will send back that user. Otherwise, I'll send an empty response. Similarly, if you want to update the information that the person has given, you can use a put or patch request. Now, a put request is basically a request in which you tell it to update the entire row. So all the columns are rewritten. And in a patch request, you just update a particular data field. Nowadays, these are used in conjunction. So both of them are used with each other, but there could be other reasons as well. And then finally, if you want to delete a particular user or a particular record from a database using our REST APIs, then you can basically send a delete request to a user URL by providing a particular ID. Now, one thing you will notice is that I've written /users. So the URL is not going to be like that. It's going to be the localhost URL. You can type http:// and your entire web address to the API, and then /, and then from there, the API's URL will be like the one that you're seeing. So for instance, api.mywebsite.com/API/ and then I send the request to the user's URL. This will get me all the users. Now, APIs can be really, really more complex, and APIs are built around the idea of resources. So resources are basically things in our databases. So it could be users, blog posts, comments, anything like that. And instead of us then using the user's URL, we use the blog post URL. So instead of going api.mywebsite.com/users, I'll go api.mywebsite.com/ and then blogs or comments. And then I can use the same request pattern that I'm using here by providing an ID, get a particular ID, so on and so forth. So that's how that works. Now let's take a look at REST APIs in Python. So Python is quite easy to use when it comes to building REST APIs. In Python, you can use many of the available frameworks or libraries or any other kind of software package that you can to build a REST API. Now, Python is quite versatile, so you have a lot of options when it comes to building a web API in Python. You have Django as a framework. Now, it's a full-blown framework. It's not a micro framework like Flask and Web2Py, mainly because in Django you get a lot of functionalities out of the box. You don't need to configure a lot of things. You get a web server, you get database interactions, you get validations, you get template rendering. There's a lot of things that you get out of the box for free. Or on the other hand, frameworks like Flask and Web2Py, they provide the basic functionalities that they think is required for a web API. And the other tasks, such as interacting with the database, caching the data, other things, you can build on your own, or if you want, you can probably use a plugin that has been built to integrate with the framework. So there are a lot of things that you can mix and match when it comes to Flask. So when it comes to using micro frameworks over full-blown frameworks, it really comes down to your choice. You could use a full-blown framework if you choose to. The problem there is that then you lose a lot of flexibility. You would have to, if you want to use your own caching mechanism, you need to figure out a way to integrate it with the framework. On the other hand, if you use micro frameworks like Flask, you get to choose your own ways of doing things. You get to decide how you want to cache data. You get to decide how you want to validate your data and how you want to parse the requests and responses. So you can do it that way as well. Depends on the application, depends on the team size, depends on a lot of factors when building a REST API. Now let's take a look at a demo. So before we take a look at the demo, you should have an application called Postman. It looks like this. You need to have this installed on your system because we'll be firstly taking a look at how to send requests and get response back. So this is a client that allows us to send HTTP requests and analyze the response that we get back. Now, I have already created the code for API and we'll walk through it. And mainly what I've done is I have created ID will never get updated. So we just update email and password and using the ID that we have. And then if we take a look at whether or not it's working, we go to update user and go to body. As you can see, I've written the ID as 1 and the method is put. So instead of Jane, let's say johnny@example.com and password is this. Now if I send this request, I've updated the ID. It's now Johnny. And if I now try to get the users, let's try and get all the users first. And we get Johnny and James. So Jane has been updated. And if I get by an ID, I think I've updated it to be the first ID. And as you can see, the changes have been persisted to our database. And finally, if you want to delete a user, basically send a delete request to one of the users. Now, deleting is a special case, mainly because if I open the api.py file, as you can see, I use the delete method. It's the same thing that I've done before, delete user by ID. I send the request to services. In my user service, I use the delete method, and inside it, I just pass it to the model. And inside the model, all I'm doing is I'm deleting it. But the thing is, I'm taking a look at how many rows were affected by the last query. So if it was affected and 1 row was affected, then the status is 200. Now, let's understand HTTP status codes. 200 basically means in HTTP protocol, 200 means that everything went okay and as expected. 404 means that the thing that you were trying to access was not found on the server. So we send the status as well as the affected rows back to the user. The service returns the same thing back to the API, and the API converts it into JSON and then send it back to us. So I go to the web API, and in the delete users part, if I send in an ID that does not exist, I get the response of status code 404 and 0 rows were affected. But if I send in an ID that does exist, I get row count of 1 and status of 200. But if I do it again, then again, since row of ID 1 was deleted, then we don't get that. Now, this is how you use it to check whether or not it's working or not. Now, the main benefit of creating a REST API is that you can now create web applications, you can create Android applications, you can create any kind of application that can access this API. So I've created a really small function here. Here, all I've done is I've gotten data back from the API and then displayed in the table. It's a very simple use case. If you want to take a look at the code, let me just show you. This is what it looks like. Now, again, if you don't know HTML, don't know CSS, just stick with me till the end of the slide and I'll show you. Basically, what I'm doing is I'm creating a table, adding this header here, and then basically getting data from the users and then converting that data into HTML elements and then adding it to our HTML web page. This is what it looks like. Let me try and add another data and then this will be fetched dynamically. So if I add another user and instead of James, I type in John. Save it. Now you get the ID to be 3, name, email, and password. So if I refresh this, as you can see, I get both the usernames and passwords that are available in our database. So that way you can build a REST API quite easily. Now, again, this was a very rudimentary example, mainly because REST APIs are quite deep topic and they take a lot of time to cover. But this should give you a basic understanding how you can use Flask and how you can do it. Now, another question that you might be wondering about is why are we separating things into other files like user model and user services? We could have just created it in the same folder and then called the queries and all. But when you're trying to build a good application, main things that you need to consider is separating things into smaller pieces and then separating those responsibilities into other classes, functions, modules, etc. So, for instance, the reason why we are using another layer of service instead of just using the model is because if in future, let's say that you get a assignment that says that this API is working, but we want to convert it into JSON, but not in JSON, but we want to convert it into XML and we want to cache it as well. So for caching it, you can just go to the user service, add your caching code here, and it will work just fine. And for sending it back to the user as XML, instead of JSONify, you can use another function. So instead of you having to then dive deep into the code and then figure out which line or which file of the particular project do I need to change, you already know how to do it. And it's easy to understand as well. We can just take a look at the application and understand the flow of request and response. And finally, we are just running this application in debug. Debug allows us to take a look at errors if we run into any. And we also take a look at port. So the port is 8001. You can change it here. This is exactly why I'm getting my API running on the 8001 port. If I change it there, it will be changed here as well.
So let me start off by giving you a use case. Suppose you decided to build your own game, but you don't know how. Well, there are three aspects which comes into picture over here. The first aspect is what kind of language you want to develop your game in, what kind of platform you want to deploy your game in, and what kind of game type you're trying to develop. Well, the answer to this is Python. Now, I'm going to tell you why we are using Python for gaming. First and foremost point is Python is independent of all the other. Python itself being a very good programming language. It has a lot of independent libraries and packages which makes your work really, really easy. Next point is it has a very large community support. So suppose you have already developed a certain game. What exactly happens is if you're getting any doubt or queries related to the game, then you can always reach out to the community where people from different parts of the world are always there to help you out. And then it has a very rapid game prototyping. Now I'll move on and talk about the next topic, which says how to create games in Python. Now, how do we actually get started with it? Since now I know that why we are using Python for gaming. So now I want to know how do we create games in Python? Well, Python in general supports a lot of libraries, or I can say packages for game dev, especially, or I can say game development, which includes Pygame, Albo, Pygonym, etc. Now, out of all these libraries or packages, Pygame is one of the most popular one since it allows a user. Now, let's say you are somebody who has just started out in this whole game dev ball game. Then it basically gives you the power to create basic and small games and also create, bigger games like Mario or Flappy Bird or Snake Game, etc. Now, I'll move on and talk about the introduction to Pygame. Now, this user over here has a problem. He doesn't know what is Pygame. So let me give you a formal or a general definition of Pygame. Well, Pygame is a cross-platform set of Python modules which is designed specially for writing video games. It includes your computer graphics and sound libraries designed for usage with Python. Now I'll move on and show you what Pygame can support. Well, Pygame can handle time, it can handle video, which includes your still images and GIFs. It can handle music. So if you want to add, music, or if you want to create a game which has a background music, well, welcome my friend. Pygame allows you that. It can add different fonts. So let's say you are developing a small, a virtual prototype of a game which includes you to display a font or different fonts in the output. You can do that using Pygame. It has different image format. So let's say you're developing a game where you want a background image or a different background image. You can do the same using Pygame. It allows you to, move your cursor or change the position of your cursor. It allows you make use of your arrows which are given on your keyboard, and has so many more functionalities. Intriguing and simple, isn't it? Now I'll move on and get started. So how do we get started by Pygame? So my first and foremost process is we will install Pygame, or we will install the package Pygame in our IDLE. So the IDLE what I'm using here is PyCharm. So I'll move on and show you how do we actually do that. Alright. So as you can see, I have named my file here as experiment.py. I will be giving you guys a step-by-step explanation of how I am proceeding further. So my first step is I have to import Pygame. So you just click on file, go to settings, alright, click on project interpreter and click on the plus sign over here. Now in this you type Pygame and click on install package. Since this package is already installed, so it will probably show okay, so my package Pygame has been installed successfully. So this is how you import your Pygame. Now let me just go back to my PPT. Alright, so this was regarding the installation of Pygame. Now let me tell you the prerequisites for learning Pygame. Since I am teaching you Pygame, guys, so I am in the assumption that you guys are already aware of the basic Python functionalities. That is, how do you work with Python, how you can write small codes, or the basic requirements what are there to learn Python. So you need to know the two basic things, that is the basic workflow, how the Python code runs, and also the syntax. So you need to be thorough with both of these things. Now I'll move on and show you the coding concepts. So let's say we have a simple code. So when I write this code, okay, this is the output of this code. Now I know you guys wouldn't be understanding by this PPT what is this and what is that part. So let me just type this code out for you so that you get a better picture. Now whenever we are getting into this whole ball game of using Pygame and developing a game, so my first and foremost concern is I need a play area, right? I need a screen where we can show the game or where we can actually project an object. So my first concern is to get the screen. Now how do I get that screen? Well, it's pretty simple. So my first line is, so import Pygame. Now let me move on to the next point which says pygame.init. Now what this init will do is it will initialize our Pygame. So if you forget writing this line, and if you have written the whole code and if you have not written pygame.init, that is initializing, then your code will definitely show you an error that your Pygame has not been initialized and it won't run. Now my next line will be, let me just create a variable with the name as Windows. So I have written win. So win is equals to pygame dot display dot set mode. So the set mode is basically the size of your screen, so I'm going to give my size of my screen as 400 by 400, which is the width and the height of my screen. Now I'll move on and just write pygame dot display dot set caption. So this caption is nothing, guys. It's just that whenever your screen gets displayed, this caption is shown. So let me write, this is my first Pygame. Alright. Let me move on and just run this code and show you what happens. So as you can see, our window is loading, but then it goes. Alright. It is just loading for like a second or two, and then it just goes. If I execute this code once again, you can see my first Pygame is being shown over here. So what I'm going to do is I'll just move forward and I will probably write a code. So now since our window is loading, but I want the windows to load permanently and not just go back in a jiffy or just exit in a jiffy. So how do I do that? Well, it's pretty simple, guys. Alright, so how do I do this? So firstly, my first and foremost concern is that window is loading, but that window has to be there permanent. Now that is my play area. So once I'll run this code once again and show you. So this is my play area. Now this is always exiting. So how do I keep this window intact? So in this play area, I'll be firstly creating an object. Now in order to create an object, I'll have to give the coordinates. So my coordinates will be x is equal to, let me give a value for x, let's say I'm giving 50. Okay, then I'm giving y is equals to 50. Moving on, I'll give the width of the object, which is 40, and then I'll give the height of the object, which is, again, let's say I keep it as 60. Alright, then I'll move on and keep the velocity of the object. So I'm keeping the velocity of the objects as 10. Okay, now what I'm going to do is I'm going to create a while loop. So the loop, what it's going to do is, by Pygame programmers have a main loop where it basically checks for the boundary collision. It checks when the game is going to exit, if the object touches the boundary, or how the collision is taking place, etc. So for that, let me just create a variable called run. So run will be equals to true. Okay, now I'll enter a while loop. So while run, alright, I'll be making use of a time delay. So what this time delay is going to do is, time delay is basically the clock in the game. So alright, and I'm keeping this as 100. Alright guys, so let me just quickly open my PyCharm, and as you can see, I have already created a file with the name of experiment, because in this experiment file I'm going to load the screen. I'm going to firstly write the code for you to load the screen, which will also be called as the play area or the screen area. So in order to do that, let me first import my Pygame and show you how to import the Pygame. So it is a package. You click on file settings, go to project interpreter, click on plus sign over here, alright, and simply type Pygame and then click on install package. Alright, so as you can see, the message over here shows that your package Pygame has been installed successfully. Now I'll move on and I'm going to write the code for loading the screen, alright, which you just saw in the PPT. So what I'm going to do is, my next line of code will be, I've already written import Pygame, so my next line of code is pygame.init. Alright guys, so if you don't write pygame.init, basically pygame.init is initializing a Pygame. So if you don't write this in the beginning of your code, so when you are done writing the code for your whole Python gaming or the game which you are trying to develop, it will show you an error that your Pygame has not been initialized.
So a fraud by definition is an act of deception that is used illegally to deprive a person or an organization or entity of money, property, or legal rights. So if we talk about financial frauds, which are the most common type of frauds, so a typical organization loses around 5% of their yearly revenues to fraudulent cases. And according to an RTI report, there were around 2,480 cases of frauds in 18 public sector banks, which involved around 32,000 crores. And according to an RBI report, in 2017 and 18, a total of 911 credit card fraud cases were there, which amounts to around 65 crore rupees, which were illegally transferred from different bank accounts. So now let's discuss some of the types of frauds that we can encounter in our daily lives. So the most common types of frauds nowadays are online frauds, where a person's account may be hacked and all his money can be transferred to different accounts illegally. And the most common types of frauds nowadays are the credit card frauds, where stolen credit cards and credit card numbers are used to make illegal transactions. And then we have threats and theft of inventory when someone breaks into a bank or an ATM. And then we have other types of frauds where someone can steal your idea or your professional work. So now that we know what are frauds and what are the different types of frauds and how they can affect different organizations and how important it is to detect the frauds and save ourselves from heavy losses. So now we'll discuss some of the rule-based approaches or traditional approaches that are used for detecting frauds. So in the rule-based approaches, the algorithms are actually written by fraud analysts, and these are based on strict rules. So if there are any changes that have to be made for detecting a new type of fraud, so they are all done manually. So either by making those changes in the already existing algorithms or by creating new algorithms. So in this approach, whenever there's an increase in the number of customers and the data, the human effort also increases. So in conclusion, we can say that the rule-based approaches are time consuming and they are costly. So now let's discuss some of the drawbacks of the rule-based approaches. So one drawback of the rule-based approach is that it is more likely to have false positives. So this is a type of error condition where the output of a transaction, it depends upon the rules and the guidelines that we have made for the training algorithm. So if you have a fixed rule and a fixed threshold, and if a transaction is rejected where it should not be rejected, so it will generate a condition of high rates of false positives. So these false positive conditions actually result in losing a lot of genuine customers. So our rule-based approaches cannot recognize hidden patterns since all of the rules are mentioned by the fraud analyst, and it cannot also predict new types of frauds because it always abides the rules that are mentioned by the fraud analysts, and that leads us to a situation where it cannot respond to new situations which is not trained on or it is not explicitly programmed on. So now that brings us to our next topic, that is how we can use data science to solve these problems and use data science for fraud detection. So the modern alternative is to leverage the vast amounts of big data that is collected from different online transactions and model it in such a way that allows us to flag or predict fraud in the future transactions. So for these, different data science techniques such as machine learning and deep neural networks are the obvious solutions. So here I'm going to show you an example of how machine learning techniques can be used to identify fraud in financial transactions. So machine learning is a broad field. It has a large collection of algorithms and techniques that are used in classification, regression, clustering, or anomaly detection. So two main classes are supervised and unsupervised learning. So in supervised learning, it is used to predict either the values of a response variable, which is also called regression, or the labels of a set of predefined categories, which is also called classification tasks. So in supervised learning, the algorithms learn how to predict unknown samples based on the data of samples with known response variables and labels. So in fraud detection, we are technically dealing with the classification task. So for each sample, that is a transaction, the predefined labels tells us whether it is a fraud transaction or not. So however, there are two main problems while using supervised learning for fraud detection. So the first problem is data labeling. So in many cases, fraud is actually difficult to identify, and some cases will be obvious. Some cases will be easy to recognize with rule-based techniques, and they usually won't require complex models. So where it becomes interesting are the subtle cases. So they're hard to recognize as we don't usually know what to look for. So here we use the power of machine learning, but because fraud is something that is hard to detect, so our training data sets that is collected from the past transactions are probably not classified correctly in many of these cases. So this means that the predefined labels will be wrong and some of the transactions will be wrongly labeled. So in this case, our supervised machine learning algorithms won't be able to learn how to find these type of transactions or these type of frauds in the future transactions. And the next problem that we face is the unbalanced data. So an important characteristics of fraud data is that it is highly unbalanced. So this means that one class is much frequent than the other. So in a fraud detection example, less than 1% of the transaction will be fraudulent. So in most of the cases, you will find that less than 1% of all the transactions are fraud transactions, and most of the supervised machine learning algorithms, they are actually very sensitive to unbalanced data. So we have to use different techniques to balance the data before we actually use the supervised machine learning algorithms to predict the fraud cases in the future. So the next class of problems that we can solve using the unsupervised learning. So it does not require or predefined labels or response variables. So it is used to identify clusters or outliers or anomalies in the datasets. So in our fraud dataset, we don't trust the predicted labels to be 100% correct. So since there will be a lot of incorrect labels as well, but we can assume that the fraudulent transactions will be sufficiently different from the vast majority of regular transactions, so that our supervised learning algorithms will flag them as anomalies or outliers. So in supervised learning, we can use the dimensionality reduction, which is also called a type of dimensionality reduction is called principal component analysis. So in preparation for our machine learning analysis, dimensionality reduction techniques are very powerful tools, and they are used to identify hidden patterns in the data. And whenever we have high dimensions in the data, so it is better to use PCA so that we can reduce the number of features for machine learning while preserving the most important patterns of the data. And similar approaches can be used, such as clustering algorithms, and like K-means clustering can also be used to find the patterns in the data using number of clusters. So in this video, we are going to use the supervised machine learning model on our data set so that we can predict future fraud transactions.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So now let's discuss some of the challenges that we'll face while building a machine learning model on our credit card dataset. So various challenges arise when building models for fraud detection. So the first challenge is the unbalanced data. So there are plenty of legitimate cases, but only a very few fraudulent cases. So for example, in a credit card transaction, typically less than 0.5% of the transactions are fraudulent. So it might cause an analytical technique to experience difficulties in creating an accurate model. And depending on the exact application, operational efficiency may be a key requirement. So the fraud detection system might only have a limited amount of time available to reach a decision. So in a credit card fraud detection setting, the decision time to let a transaction pass or not is typically less than 8 seconds. And also incorrect flagging. So when flagging a particular transaction, if the transaction is flagged as fraudulent for a good customer, so you risk losing this customer due to the harassment caused by flagging the transaction as fraudulent. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is unbalanced data. So here you will find that most of the cases in a data set, most of the transactions will be legitimate transactions and very less transactions will be fraudulent transactions. So if you train your classifier model on this, so your classifier will tend to favor the majority class, that is your legitimate transactions, so which results in large classification error over the fraud cases since it has not learned much because of the less data available to it. So the classifiers actually learn better when it is trained on a balanced distribution rather than an unbalanced data. So now we'll discuss sampling methods to solve this unbalanced data problem. So we always perform the sampling methods on the training set, not on the test set. So we'll always divide our data set into two sets, that is our training and test sets. So we'll build our model on the training set, and before building the model we'll balance the training set so that our model learns on the training set, and then we'll use the original test set, which is the unbalanced test set, to predict whether a transaction is fraudulent or legitimate. So the first technique is called the random oversampling technique. So in this technique we oversample the minority class, which is our fraud cases. So we copy the cases that are already present in our fraudulent cases. So we'll just copy the same cases multiple times till we reach a particular threshold or the value of the cases that we want in our dataset. And the other technique that we can use is the random undersampling. So in this technique we undersample the majority class, which is our legitimate cases. So we remove some of the cases that are present in our dataset which are from the legitimate transactions. So we'll remove some of those cases, and then we'll downgrade some of those cases till we have a dataset that has an equal distribution or an almost equal distribution of both the fraudulent and the legitimate cases. Or we can do both, so either we can up sample or we can down sample. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that most of the data sets have most of the transactions as legitimate and very few transactions as fraudulent. So if you train your classifier model on this particular data set, so our classifier will tend to favor the majority class, that is the legitimate cases, so which results in the large classification error over the fraud cases since it has not learned much from the fraudulent data because the data that was available to it was very few. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets or legitimate cases they are outnumbered. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are legitimate transactions and there are very few transactions which are fraud transactions. So if you perform a classification model on top of this data set, your classifier will tend to favor the majority class, that is all legitimate cases, so which means that it will show a huge classification error over the fraud cases. So classifiers actually learn better from a balanced distribution. So if you train or model on a balanced distribution, it is more likely that we have a less classification error for our fraud cases and it will be easily available to us. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are actually legitimate transactions and very less transactions are fraud transactions. So if you create your machine learning model on this type of data set, your classifier will tend to favor the majority class, which is your legitimate transactions, and which will result in large classification error over the fraud cases. So our classifiers or our machine learning models, they learn better from a balanced distribution where the balance of the two classes, that is legitimate and fraud, can be equal. So now let's discuss some of the methods that we can use to solve the first type of challenge, that is our unbalanced dataset. So you'll find that most of the datasets, they have large number of legitimate cases and very few fraudulent cases, since in credit card transactions less than 0.5% of the transactions are fraudulent. So our classifier or our machine learning model will tend to favor the majority class, that is our legitimate cases. So which means that it will show a large classification error over the fraud cases, will not be able to identify which case is fraud or not. So our classifiers actually learn better from a balanced distribution instead of an unbalanced data. So now let us discuss different sampling methods used to balance an unbalanced dataset. So the first technique is called the random oversampling. So in random oversampling, we increase the number of fraud transactions in the dataset by creating duplicates of the already present fraud cases. And the next technique is called the random undersampling. So in random undersampling, we decrease the number of legitimate cases to get a balanced distribution. And also we can perform both random oversampling and random undersampling by increasing the number of fraud cases and decreasing the number of legitimate cases. So now this is how our dataset will look like after performing both the oversampling and the undersampling. But the problem with oversampling is that it is done by creating duplicates of the fraud cases that are already present in our dataset. So that means that we will be training our model using a lot of duplicate values which won't explain the variance in the data. And the problem with undersampling is that we end up throwing away a lot of useful data and information which is not preferred in general. So that brings us to our next sampling technique, which is called the synthetic minority oversampling technique, aka SMOT. So in this technique, we oversample the fraud cases by creating synthetic fraud cases. So if you look at this scatter plot at the right hand side, the green dots here represent the legitimate cases and the red dots here represent the fraud cases. So in SMOT, we find the k nearest neighbor of a fraud case, let's say x here, and let's take the value of k as 3, so we'll find the 3 nearest neighbors of x. And after choosing the nearest neighbors, we'll randomly choose one of the x's nearest neighbors, let's say y here, and then we add a synthetic sample using the following method. So we'll take the x and the y coordinate of both the points and find the x and the y coordinate of a synthetic point, which is given as follows. So the synthetic point will lie on the line that joins both x and y, and here the number 0.3, it is a random number between 0 and 1. So we can use different numbers between 0 and 1 so that we get different synthetic samples that are present on the line that joins x and y. And we can also repeat this step multiple times for each neighbor of x, which is a fraudulent case, to get a desired value of the fraud cases in our dataset, and hence we'll get a balanced dataset after all.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So now let's go to RStudio to implement credit card fraud detection model using SMOT. So now let's build a fraud detection model in R. So first of all, we will import the dataset that we are going to work on. So I've stored my dataset in this particular folder. So once I load this dataset using the read.csv function, and I'll store the dataset in credit underscore card data frame. So if I run this line, your dataset will be imported, and after importing the dataset, we'll look at how our dataset looks like. So after your dataset is imported, you can click on the dataset name in the variable explorer, and once you click on the name, you will find that our dataset contains 284807 entries, that is rows, and around 31 columns. This dataset is about different transactions made by different credit card users, and the first column here you can see is the time. So this is the time stamp, and then we have columns from V1 to V28. So these columns are actually the reduced versions using the dimensionality reduction. So the actual dataset contains the actual columns which the dataset does not contain. So these are actually the reduced versions using the PCA. so that the confidentiality of the users is maintained. So these are different features that are extracted from the actual features using the dimensionality reduction. So after the 28th column or the 29th column, we have the amount column that represents the amount of transaction that was done using this particular credit card. And then the last column here you can see is the class column, which contains two values, that is 0 or 1. So 0 here represents that the transaction was a legitimate transaction, and 1 represents that the transaction was a fraud transaction. So after that, let's look at the structure of the dataset and see what are the different types of variables that we have in our dataset. So if you use the structure function and write the name of your dataset, that is credit card, so you'll see we have around 31 variables, that is columns, and most of the variables are numerical columns. And the last column here you can see is class, which is also an integer column, but in actual it is not an integer column, it is a categorical column. It has two categories, that is 0 and 1, and 0 here represents the legitimate transactions and 1 represents the fraud transactions. So first of all, we will convert our class column to a factor column, two levels, that is 0 and 1, so that we can work with our dataset later on. So we'll convert this to a factor column using the factor function, and I'll pass the name of the variable, that is credit card $class, and then we have two levels, that is 0 and 1, 0 for legitimate cases and 1 for fraud cases. So we'll again store it in the same variable, that is credit card $class. So once you run this function, if you now look at the structure of the dataset, so you'll see now our class column is a factor column with two factors, that is 0 and 1. 0 here represents the legitimate transactions and 1 represents the fraud transactions. So now let's look at the summary of the dataset to display the summary statistics of different columns. So here you can see the last column is a class column. So here around 284315 entries are legitimate cases, that is 0, and only 492 entries are your fraud cases, that is 1. And then we have most of the columns are integer columns with mean of 0, and the first column is our timestamp. So now before moving ahead, now let's check whether there are any missing values in our dataset or not. So we'll use the is.na function to check whether there are any missing values in our dataset or not, and then the sum function will count the number of missing values if there are any. So once we run this function, we will see that we don't have any missing values in the dataset, so it is okay for us to continue and work with our dataset. So now we have to use the class column. So first of all, let's see how many fraudulent and legitimate transactions are actually there in our dataset. So we'll get the distribution of fraud and legitimate cases or legitimate transaction in the dataset. We'll use the table function, and inside the table function we'll write the variable that we want the distribution for. So our variables or the transactions are stored in class variable in our credit card dataset. So we'll use the table function to get the distribution of different transactions. So here, after running this command, here you can clearly see that 0 represents the legitimate transactions, and most of the transactions in this dataset are legitimate transactions. So there are around 284315 legitimate transactions and only 492 fraud transactions. And if you want to get the percentage of the transactions, you can use the prop table function, and then inside the prop table function you can write the table function, which will get you the distributions, and the prop table function will get you the percentages of the distribution. So here you can see that 99% of the more than 99.82% of the transactions in this dataset are legitimate transactions, and only 0.001% transactions are fraud transactions. So clearly we can see this is an imbalanced dataset. So now let's also plot a pie chart to get the distributions of our legitimate and fraud cases in our dataset. So we'll firstly set the labels of our pie chart. So the labels are legit and fraud. So we'll create a vector that contains two strings, that is legit and fraud, and we'll store that in labels. And after that we'll paste or we'll concatenate the percentages of your fraudulent cases and legitimate cases with the respective labels. So if you pass two vectors in the paste function, so first we'll use the paste function to concatenate two strings. So first vector that we have passed is the labels, which contains two values, legit and fraud, and then we'll pass the round function. So this function will actually calculate the percentages of the distributions. So we'll calculate the percentages of the prop table that we have just seen above, which will display this particular result, and we'll multiply it by 100 to get the percentage, and then we'll round this percentage to 2 digits. So we'll only get 2 digits after the point. So we'll use the round function, which will contain our percentages up to 2 digits of decimal, and then we'll have the labels which contains your two strings, that is legit and fraud, and we'll paste it together and we'll store the result in labels. So if you run this command and look at the labels right now, so now your labels actually look like this. We have a 99.83%. So here we have rounded the values up to 2 decimals using the round function here, and the fraud cases are 0.1% and legit cases are 99.83%. So clearly we can see there is an imbalance in our data set. So let's plot a pie chart first of all to get the distribution or display the distributions of our legitimate and fraud cases. So we use the default pie function from the default R package, and we want a pie chart for the different distributions or the different categories of the class variable in our credit card dataset, and we'll use the table function to get the different distributions of the categories, and our labels will be equal to these labels, and then the color of the labels will be according to the orange and the red. So the orange will represent the number of legitimate cases and the red represents the number of fraud cases. And then this is the title of our pie plot. So our title will be pie chart of credit card transactions. So let's run this command to get a pie plot. So this is our pie chart for our credit card transactions, and here you can see most of the color is orange. It means we have around 99.83% of the legitimate transactions and only 0.17% are fraud transactions. So now if you make a model on this particular data, so you will get most of the accuracy. So we'll first of all make a model that is no model. So even if you don't have any particular machine learning model, and if you predict that every single transaction in this data set is a legitimate transaction, so you can see what kind of accuracy we'll get. So first of all, we'll predict that all the transactions in this data set are legitimate transactions. So we'll store all predictions in predictions variable, and we'll repeat integer 0 equal to the number of rows that are present in our credit card dataset. So in our credit card dataset we have around 284807 rows. So we'll create a vector that will contain zeros 284807 times. So after creating a vector, we'll convert this vector to a factor variable with two levels, that is 0 and 1. Here 0 represents the legitimate transactions and 1 represents the fraud transactions. So we are predicting without using any model that all the transactions are legitimate transactions. So once you run this command, we'll factor out or we'll convert this particular vector to a factor with two levels, that is legitimate transactions and fraud transactions 0 and 1. So after that, we'll use the confusion matrix to get the accuracy for these particular predictions or that we have done without using any particular model. So we'll use the caret package. So if you have not installed this package, you can use the install.packages command and write the name of your package to install it. And then after installing the package, you can load the package using the library function. And once you run this command, your package will be loaded, and then you can use the confusion matrix function from the caret package to get the confusion matrix and the accuracy. And if you want to know more about this particular function, you can press F1 here, so it will take you to the documentation on the right hand side, and then you can know more about this particular function. So in this function, we'll firstly pass your predictions that we have stored in predictions variable as data, and then we have our reference variable which will contains the actual classes that we have predicted. So we have predicted the classes of the credit card dataset. We will pass our reference variable or the actual classes that we have predicted. So once we run this command, we'll get the confusion matrix for this particular model that we have built without using any machine learning model. So here you can clearly see that we have correctly classified all the samples that were all the transactions that were legitimate transactions, but we have not classified any of the transactions that was a fraudulent transaction. So still we get an accuracy of 99.83% because we have flagged every transaction as a legitimate transaction and we have not flagged all the fraud transactions as fraud transactions. So this will be your true positives and this will be your true negatives, which are the correctly classified values. So our true positives are total and our true negatives are 0. It means we have wrongly classified all the samples that were fraudulent transactions. Here your 0 represents legitimate transactions and 1 represents your fraud transactions. So out of all the fraud transactions, we have flagged all the transactions as legitimate transactions, which are false positives. So here you can clearly see that if you only check the accuracy of the model that we build, so we'll be wrong most of the times because here accuracy does not represent anything. Here our goal is to maximize the number of cases or maximize the true negative so that we can classify most of the fraud transactions as fraud transactions. So now let's move ahead and build a model. So before moving ahead, we will take a small subset of our dataset so that it is computationally more faster. And later on, once you have built a model on the smaller subset that you can make, then you can make the model on the whole dataset, which will take some time. So we'll take a smaller version of the dataset so that we can compute it faster. So we'll use the dplyr package to get a small fraction of our whole dataset, that is credit card. So I'll load the dplyr package first of all. So after loading the dplyr package, I'll use the sample fraction function, sample frac function, to get the fraction of our dataset, which will be random fraction. So it will contain both zeros and ones, and I'll pass my credit card dataset using the forward pipe operator, which will pass my credit card dataset to the sample frac function, which will extract 0.1%, that is 10% of the samples or 10% of the rows that are present in our dataset. So right now our dataset contains 284807. So after extracting 10% of the rows, it will be 28,480 rows, and we'll store the result in our credit card data frame again. And we have used the set seed function. So if we run this particular code again, so we'll get the same sample again. And if you don't use the set seed function and you run this code again and again, so your sample will be different every time. So we'll run these two lines together and we'll get a sample that will be 10% of all the rows that are present in our actual data set. So now let's look at the data set. That is a fraction, that is a subset of our original dataset. So we have around 28,481 rows and all the columns. So this is a 10% of dataset, and then we'll make a model on this particular data, and after building a model later on, we can build the model on whole dataset. So now let's see what is the distribution of classes that we have in this particular data. So right now we have around 28,437 transactions as legitimate transactions and only 44 transactions as illegitimate or fraud transactions. And now let's plot a scatter plot between the two columns, that is v1 and v2. So we'll plot a scatter plot between the columns v1 and v2, and we'll see what is the distribution of classes between these two variables. So we'll use the ggplot2 function to plot a scatter plot. So firstly I'll load the ggplot2 library, and after loading the ggplot2 library, I'll use the ggplot function to plot a scatter plot. So ggplot function is based on grammar of graphics, so it has different layers that we stack upon each other to build a final plot. So our first layer is our data layer, where we pass our data frame. So our data frame is our credit card data frame that we have just extracted from the whole data frame. And then we have our second layer as the statics layer. So in the statics layer, we have our variables that we want to plot on our scatter plot. So on the x-axis we have our variable v1, and on the y-axis we have our variable v2, and we want the color of the points of the scatter plot according to the different categories of the classes. So we'll have two categories in the classes, that is 0 and 1. So we'll have two different colors for each particular category. And then to plot a scatter plot, we'll add the third layer using the plus sign here. So our third layer is our geom layer. So in the geometry layer, we'll pass our function that we want to plot scatter plot for. So here if we want to plot a scatter plot, we'll pass geom underscore point. So it will plot a scatter plot for us. And then if you want to change the background of your plot, so we can use the theme function. So theme bw, that is black and white. So it will make the background of your plot as black and white. And then you can also change the color of the points. So to here, this will get you the basic plot that we want. So if you zoom in on this plot, you can see that this particular color represents our legitimate cases, and our blue color here represents our fraud cases. So if you want to change the background of this particular plot, so you can use the theme function, which will change the background to black and white. And if you want to change the color of these points to different colors, so we can use the scale color manual function, and inside of that function we can declare our values. So our values of the colors are dodger, blue 2 and red. So now this color represents the 0, that is legitimate cases, and red represents the fraud cases. So now let's run the whole command and we'll get the final plot, black and white background, and these colors as the color of the points. So if you zoom in on this particular plot, you will find that now this particular color, dodger blue 2, represents our legitimate cases, and our red color represents our fraud cases. So here also clearly you can see that we have a comparatively huge number of legitimate cases and only a few fraud cases. So if you train your model on this particular data, our model will not be able to learn a lot because the number of fraud cases are very less. So we have to use different techniques to balance the dataset before we actually make or build a model on this particular data. So before balancing the dataset, we'll first of all create training and test sets. So we only use balancing on the training set to train the model, and we don't use balancing on the test set because that will be the original test set that will predict values for. So first of all, we'll create training and test sets, and then we'll balance the training set and train our model, and then evaluate the performance of the model using the test set. So now let's build our training and test sets for the fraud detection model. So we'll be using the CA2's library. So if you have not installed this library, you can use the install.packages and the name of the library to install it. And after installing this library, you can use the library function to load the library, and after loading the library, we can use the sample.split function to split our dataset into two sets, that is training and test sets. So in the sample.split function, if you want to know more about this function, you can press F1 here. So it will take you to the documentation on the right hand side. So now if you want to split your dataset into training and test sets, so here we'll pass our column that we want to split according to. So since we are going to predict whether a transaction is a fake transaction or a legitimate transaction, so that column is a class column that represents zeros and ones. So we'll use the class column to split our dataset into training and test sets. So I'll pass the column, my class column, from the credit card dataset, and now I'll mention the split ratio, which will represent how many rows I want in the training set and how many rows I want in the test set. So if you write split a ratio equals 0.8, so 80% of the rows that are present in your dataset will be in the train set, and 20% of the rows that are present in your dataset will be in the test set. So if you run this particular line, and we'll store the result in data sample. So once you run this line, and if you look at the data sample now, so it will contain true and false values. So here the true values will be 0.8. So 80% of the values here will be true, and 20% of the values here will be false, and these number of values will be equal to the number of rows that we have in our dataset. So now we'll use this particular object to split our dataset into two sets using the subset function. So we'll use a subset function on our credit card dataset, and we'll check wherever the sample value is true. We'll store all those rows in train data. So after running this line, our 80% of the rows from the credit card dataset will be in the train data, and wherever the data sample value is false, we'll store all those rows in the test data. So 20% of the rows in the credit card dataset will be in the test data. So now let's run all these lines together. So now we have successfully created our train data and test data. So now let's click on the train data in the variable explorer to see how many rows are there. So we have around 22,785 rows in our training data. That is 80% of the rows of the whole data set. And then if you look at the test data, so we have around 5,696 rows in the test data and all the columns. So we'll train our model on the train data after balancing this data, and then we'll test the performance of the model using confusion matrix on the test data. So now if you want to check the dimensions of your training and test data, you can use the dim function. So it will display the dimensions. So our training data contains 22,785 rows, and our test data contains 5,696 rows, and all the columns, that is 31 columns. So now before making a model, we have to balance our data set first. So we'll use different techniques. So the first technique that we're going to use is called the random oversampling, which means that we will increase the number of fraud cases in our data set. So we'll oversample the minority class. So right now, if you look at the distribution of the class variable, you can see around 22,750 transactions are legitimate transactions, and only 35 transactions are fraud transactions. So now if you want to increase the number of fraud transactions, so we'll use this particular method. So first of all, we'll write how many we'll store, or number of rows in our dataset, or number of legitimate transactions in our dataset in n legit variable, and then we'll store the number of fraction, or the amount of fraction that we want for our fraud cases. So if we want our fraud cases to be 50% of the whole dataset using the random oversampling, so we'll write 0.50, and we'll store the result in new fraction legit. So now this fraction will be 50%. So in our final data set, after performing the random oversampling, the 50% of the rows will be your legitimate transactions, and 50% of the rows will be fraud transactions. Now if you want to calculate how many rows should be there in our data set to accumulate both of the legitimate and fraud transactions as 50%, so we'll divide the number of legitimate cases by the fraction, and it will tell us how many rows we want in our data set to balance our legitimate and fraud transactions as 50-50%. So after dividing the number of legitimate cases by the fraction, we'll get the number of rows that we want in our data set. So if you run this function, we have stored the number of rows in new and total. So if you click on new and total, so you'll find that we need around 45,500 rows in our dataset, and out of these rows, 50% of the rows, or 50% of the cases will be fraud cases, and 50% of the cases will be legitimate cases. So now to perform random oversampling, we'll use a package called rows. So if you have not installed this package, you can install the package using install.packages function, and then write the name of the package that we want to install. And after you have installed the package, you can use the library function to load the package so that you can use the functions that are included in this package. So in this package, we're going to use the o1.sample function, which will help us to perform random oversampling. So if you want to know more about this function, you can press F1 here. So it will take you to the documentation of this function. So in this documentation, you can see the first argument that we want is our formula argument. So in the formula argument, we have to mention our variables that we want to oversample. So here our class variable is the variable that we want to oversample, and then we have used the dot, which means the rest of the variables are independent variables, and this tilde sign is used to separate our independent and dependent variables. So our class is our variable that we want to oversample, or that we will predict later on, and we'll use all of the variables in our dataset except the class variable, which we can mention using the dot symbol here. And after the second argument is our data argument, so it will require the data that we want to oversample. So our data comes from trained data that we have just created above our training set. And the third argument here you can see is our method argument. So if you go to the documentation, you can see that we have three methods, that is over, under, and both. So firstly, we'll perform the oversampling of the minority samples. So we'll use method equals over, and then we have our n argument, which will be the number of rows in the new dataset after the oversampling is performed. So that is equal to the number of new and total, which is 45,500 rows. And then we'll also use the seed function, so that if we run this code again, so we will be getting the same sample again, or the same number of oversampled rows again and again. So let's run this function now to get our oversampling result. So after running this function, if you just click at the variable that has been created, so here you can see we have different attributes of this variable, that is oversampling result. So our data is actually stored in the data attribute. So if you want to reach the data attribute, you can use the oversampling data and then the data attribute, and we'll store the data set in oversample credit. So if you store the result in oversample credit, and now if you look at the distribution of the classes that we have after random oversampling, so you will find that we have 22,750 legitimate cases and 22,750 fraud cases. So now the distribution of our fraudulent and legitimate cases are equal using the random oversampling. So before moving ahead, let's plot this distribution using the same V1 and V2 columns of our oversampling result. So now if you click at the oversampling credit, so this is our oversampling credit, we have 45,500 rows. So let's plot a scatter plot between V1 and V2 and see what is the distribution of classes between these two variables. So we'll use the ggplot function to plot a scatter plot again. So here now our data comes from oversample credit here, and then we have the variables v1 on the x-axis and v2 on the y-axis, and the color of the points will be according to the categories of the class column, that is 0 and 1. And then we'll use the geom function. So if you want to plot a geom, so if you want to plot a scatter plot, we'll use the geom point function, and then the theme of our plot will be black and white using the theme function, and the color of the points will be dodger blue and red. So
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
if you want to change the color, you can use this scale color manual function. So once you run this command, you will get a scatter plot between v1 and v2 that represents your oversampled data set that we have just created using the rows package. So now if you zoom in here, you will find that we have the blue color or the dodger blue color as class 0, which is the legitimate cases, and the red will be our fraud cases. So here you can see still our points do not represent a lot of points compared to the blue points. So the reason is that in our random oversampling we create duplicate points, so most of these points are overlapping on each other, because we in random oversampling will just create duplicate points that are already present in our dataset. So if you want to know whether there are points overlapping on each other or not, so we'll add some jitter to these points. So once we add some jitter to these points, so you'll see that there will be a lot of points in this on top of each other, because we have just created duplicate points using the random oversampling. So to add jitter to the points, we'll use the position argument of the geom point function. So if you set your position argument to position jitter, and inside the position jitter function we can mention our width of the jitter that we want. So if you write 0.1 here, so now if you run this function, you'll find that there will be a lot of points that are overplotted or stacked upon each other, because we have just created duplicate points using the random oversampling. So now here you can see the points, when you add some jitter, you will find there are a lot of points that are stacked up on top of each other because we have just performed the duplicate values. We have just increased the number of duplicate values using the random oversampling. So now let's perform our random undersampling. So in random oversampling, we just train our model on duplicate values, which is not a good condition. So we'll see what is random undersampling. So in random undersampling, we'll reduce the number of legitimate cases. We'll keep the legitimate cases equal to the number of fraud cases. So let's first of all see the distribution of our credit card dataset. So we have this distribution. We have around 22,750 legitimate cases and only 35 fraud cases in our training set. So now if you want to set the number of legitimate cases equal to the number of fraud cases, so we'll use this method. So first of all, we'll store the number of fraud cases in n fraud, and then we'll calculate we'll store the fraction that we want for our fraud cases or our legitimate cases. So we want the number of fraud cases equal to 50% of the whole data. So we'll store that in n frac fraud, and then we want to calculate the number of rows that will be in your data set so that our fraud cases and legitimate cases are equal in number. So we'll divide the number of fraud cases by the fraction that we want our fraud cases to be in, that is 0.5. So once we divide it, we'll get the total number of rows that we need in our data set to satisfy this fraction. And once you run this particular command, so if you look at your new total, so now our data set will contain 70 rows, and out of the 70 rows, 35 rows will be number of legitimate cases and 35 rows will be number of fraud cases. So now let's use the o1.sample to create that particular data. So we'll use the same o1.sample, and now instead of mentioning the method as over, we'll write method as under, and then all of the arguments are same. So you just have to change the method, and once you run this particular function or particular command, so now your undersampling result will be calculated. And now if you want to get to the data set that is stored in undersampling result, so we'll get the dataset attribute or the data attribute of the undersampling result, and we'll store that in undersampled credit. So once you run this line, you will have your dataset that is undersampled credit. And if you look at your dataset right now, so we have around 70 rows, and out of these 70 rows, 35 rows will have legitimate cases and 35 rows are fraud cases. So now let's plot scatter plot between same v1 and v2 to see how our distribution of the points look like and the distribution of the classes look like between these two variables v1 and v2. So if you plot it now, so you'll see that now we have equal number of legitimate cases and fraud cases. So in random oversampling, we decrease the number of legitimate cases to a certain ratio so that we have more, or we have an equal distribution of legitimate and fraud cases. But the problem here is that we end up losing a lot of data which is not preferred in a general case. So now we'll perform both the random oversampling and undersampling to see how our data actually looks like. So now we'll perform both random oversampling and undersampling. So now the number of rows that we want in our dataset will be equal to the number of rows that are present in our training set. So our new dataset will also contain the same number of rows, that is 22785. And now we want our fractions of the legitimate and fraud cases equally in our dataset. So out of the 22,785 rows, 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases. So we're not going to increase or decrease anything. We're just going to resample our dataset in such a way that 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases, using both random oversampling for increasing the number of fraud cases and random undersampling to decreasing the number of legitimate cases. So after storing our fraction in the fraction of fraud new variable, we'll use the same o1.sample. So now we have used the method as both. So here if you want to perform both random oversampling and undersampling, you can use the method as both. And then the n argument here is the number of rows that we want in our new dataset, and then the p is your probability of fraction. So if the method is both here, so the probability will be default by 0.5. So 50% of the rows will be your legitimate cases and 50% of the rows will be fraud cases. And then we have used the seed function so that we get the same sample again and again if you run this code again. So now if you run this code and if you get to the dataset using the data attribute of the sampling result, you will store that dataset in sampled credit. Now let's look at the dataset. So we have around 2785 rows, and out of the 22,785 rows, you can see around 11,430 rows are legitimate cases and 11,355 rows are fraud cases. So if you want to get the percentages of these rows, so you'll get around 50% of the data are legitimate cases or legitimate transactions, and 49.8% are fraud transactions. So now let's plot a scatter plot between V and V1 and V2 to see how our class distribution looks like. So I've already added some jitter so that we can see the overlapping of the points, because we have performed random oversampling and undersampling both. So we have reduced some number of legitimate cases and we have increased some number of fraud cases. So now they are in equal ratio, but the number of fraud cases are overlapping on each other because they are duplicates of each other, and the number of legitimate cases are scattered on whole of the plot. So now let's move ahead and use the third method that we use, which is called the SMOT, which is the synthetic minority oversampling technique, which will add the synthetic samples in our dataset without actually creating duplicates of the fraud cases. So to implement SMOT, we use this library called SMOT family. So if you have not installed this library, you can use the install.packages and the name of the library to install it first, and then after installing you can use the library function to load the library to use the functions that are contained in this library. So after loading the library, if you look at the class distribution, we have the same class distribution, that is 22,750 are legitimate cases in our trained data and 35 are the fraud cases in our trained data. So now we want to increase the number of legitimate cases, or we want to add synthetic samples of the fraud cases so that we have a balanced data set that we can use to train our model. So we'll start by first of all setting the number of fraud and legitimate cases and the desired percentage of the legitimate cases that we want in our dataset. So our legitimate cases are represented by N0 here. So we have around 22,750 legitimate cases, and N1 are the fraud cases. So we have around 35 fraud transactions. And then R0 represents the ratio that we want in our dataset after the SMOT. So we want 60% of our rows should be legitimate cases and 40% of the rows will be fraud cases. So we'll add synthetic samples in such a way that after adding the synthetic samples, our data set has 60% of the legitimate cases and 40% of the fraud cases. So now to get the number of times that we have to perform SMOT to get the desired number of ratio of the legitimate and fraud cases, so we'll use this SMOT function first of all from this SMOT family. And if you want to know more about this function, you can press F1 here, and you can see we have different arguments, that is x, which is our data that we want to apply SMOT on. Then we have our target value, so the vector of the target class attribute corresponding to our dataset x. So our x will be our independent variables and our target will be our dependent variable that we are going to predict later on, and k is the number of nearest neighbors we want during the sampling. And then we have our dupe size, so it will be the number of times we run our SMOT, or number of times we want to run our SMOT to add different synthetic samples. So if you want to get the number of the dupe size, which will actually tell us how many times we have to run SMOT in order to get the desired percentage of all legitimate and fraud cases, so we'll use this formula. So this formula will help us to get the number of times we have to run SMOT in order to get a percentage of synthetic cases such that our final data frame contains 60% of the legitimate cases and 40% of the fraud cases. So using this formula, which contains both R0, N0 and N1, once you run this here, and before running this we have to run these three together, and after that if you run this, so if you now look at the number of times, we will get we have to run 432 times. So after running 432 times on the SMOT, we'll get to a value of your variables in such a way, or value of the points in such a way that 60% of the points will be flagged as legitimate transaction and 40% will be fraud transaction. So we'll use the SMOT function first of all, and our x will be our training data. So if you look at your trained data right now, so our trained data, first column is our time column. So we are not going to use this particular column because we are only going to use these features v1 and v2 up to v28. So we'll be removing this particular feature from our data, and then we'll also remove the last column, which is our target column, which is our class column, which is 31st column. So we'll remove these two columns, and our training data will be from amount till v1. So after declaring our training data, that is our x, now we'll declare the target. So our target is our class variable that we are going to predict either 0 or 1, and the number of neighbors that we want is 5, and then the dupe size is equal to the number of times here. So once we run this particular code, so we'll get our output as SMOT output, and if you look at the SMOT output, so it will have different attributes, and our data is stored in our data attribute here. So we'll get the data set, which is data frame from this particular attribute. So we'll use this attribute data and we'll store the data set which we have created using the SMOT method. So once we run this particular line, and if you now click at the credits mode, so we'll get the data set that has around 37,905 entries and around 30 columns. So we have removed the first column, and our last column is our class column. So in the class column, around 60% of the class values will be 0, that is legitimate cases, and 40% of the class values will be 1, which is fraud cases. So now let's change the name of this variable to class with an uppercase C, so that we are according to all of the data types that we have in our, or all of the data frames that we have used till now. So we'll change the first of all the name of our last column, that is our 30th column, to class with an uppercase C using the call names function. So after changing the name of the class, so if you want to now get the percentage of the number of legitimate and fraud cases in our dataset, so we can use the prop table function, and then we'll pass a table function which will get the distribution of the categories present in the class variable. So now you can clearly see that we have around 60% of the legitimate cases and 40% of the fraud cases represented by 1. So now let's plot a scatter plot between V1 and V2 and compare the original dataset with the dataset that we have created using this mode. So this will be our original dataset where our data comes from the training data, that is without smot, and the rest of the code is same as above. So this will be our original scatter plot between V1 and V2 for the training data. So now let's plot a scatter plot for the V1 and V2 in the credits mode data after we have used the credit, or after we have used this mode method on our training data. So you just have to change your credits mode, the data that you are passing to ggplot function. So once you run this function, you will see that we have added a lot of synthetic points, around 40% of the synthetic points using this mode method. So now if you look at this particular data, you can see the blue points represent class 0, which is the number of fraud legitimate cases, and the red points represent number of fraud cases. And you can see we have not only added points, but we have added synthetic points and not the duplicate points. So these are all the synthetic points that our smart algorithm has added using this mode method. And now after creating this particular data, we'll train our model on this data, and then we'll evaluate the performance of the model on the original test data. So now after making the data set 60 and 40 ratio, so the 60% of the cases now are legitimate cases and 40% of the cases are fraud cases. So now let's build a decision tree on top of this data so that we can predict whether a transaction is fraudulent or legitimate. So we'll be using the rpart package to build classification and regression trees. And we'll use the rpart.plot package to plot the regression trees or the classification trees. So if you have not installed these two packages, you can install using the install.packages command and install the packages for rpart.plot. So once you have installed these packages, you can load it using the library function. And once you load these packages, now we'll use the rpart function to make our classification and regression tree. So if you press F1 here, you will get to the description of this particular, or the documentation of this particular function. So the first argument here is a formula argument where we have to mention the independent and dependent variables. So now we are predicting the class variable. So our class is our independent or the dependent variable which we are going to predict, and we'll use all of the variables except the class variable as independent variables. So these, if you want to write all the variables, you can use a dot instead of writing every single name, and then we use tilde sign to separate our independent and dependent variables. And then we'll pass our data that we want to train our model on. So now our data that we will train our model on is a credits mode data, which is our balance data. So once we run this, we'll create a tree which will predict the class of any particular sample based on all other variables. So we'll store the tree in cart model variable. So after building a decision tree on this particular data, so now let's plot the decision tree using the rpart.plot function. So we just have to pass our model that we have built, that is our card model, and then we have used extra equals 0. So once we plot this model, we'll get a decision tree. So if you don't want any extra information on the leaves, we write extra equals 0, and type equals 5 will change the display of this plots, the shapes that we have used in this plot. And tweak equals 1.2, it enlarges the text to 120%. So the text will be enlarged by 120%. So this is our decision tree that our model has built. So it will use only one column in our data set, that is V14, and it will use this column to classify different samples. So if the particular column's v14th value is greater than minus 2.6, so that sample will be classified, or that transaction will be classified as a legitimate transaction, and if it is less than minus 2.6, so that transaction will be classified as a fraud transaction. So now after building the decision tree, let's now predict values on top of the test set to see how many samples are correctly and incorrectly classified. So we'll use the predict function to predict the values on top of the test set. So we'll use the first method, that the first argument that our predict function takes is our model that we have built, that is our card model. And if you want to know more about this function, you can press F1 here, so it will take you to this particular documentation. So we'll use the card model, that is our machine learning ML model that we have declared above, and then the data that it wants to predict on is our test data, and then we want to predict classes, so it will predict whether a class is 0, that is legitimate case, or class 1, that is fraud transaction. So it will predict on top of the test data, and then we'll compare the predictions with the actual values of the test data that we already have with us, so that we can see what is the distribution of the correctly and incorrectly classified values. So we'll store all the predictions in predicted val variable. So once we have predicted val variable, if you look at how our predicted value variable looks like, so here you can see the first value is 4. If you go to your test data, so here you can also see the first row of the test data is the fourth row of our whole data set. And if you want to see what our model has predicted, so for this particular row, the class value is 0, and our model has also predicted 0. And for this the second row, the class value is 0, and our model has also predicted 0. So if you want to know how many predictions are correct and incorrect according to our model and the actual values, so we'll build a confusion matrix to see how many predictions are correct and incorrect. So let's build a confusion matrix using the caret package. So I'll load the caret package, and then I'll use the confusion matrix function where I'll pass the predicted values first, and then our actual values that are present in our class variable in our test data. So once you run this, you will get the confusion matrix for this particular model. So you can see here our true positives are 5625 and our true negatives are 7. So out of 9 samples that we have in our test data, 7 samples, or the 7 fraudulent cases were correctly classified by our model that we have built using the credits mode data. That is, after using this mode method, the data that we have built, if we build our model on top of that, so we'll get out of 9 cases that are present in our test data, out of 9 cases, 7 cases which are fraud cases are actually classified. So we'll be able to detect 7 cases out of 9 cases that are present in our test data. And here accuracy is insignificant, but still if you want to see the accuracy, our accuracy is around 98.98%. So now if you use the model, if you build the same model without using more data or on the original trained data, and let's see what is the classification rate or how many samples are incorrectly and correctly classified. So this is our decision tree without using the more data. So now our data is actually the trained data, and I've excluded the first column of my data, that is our time column. So we were only using the variables v1 to v28 and then the amount column, not the time column, and the rest of the code is same. So this is our formula which can dependent variable, that is class, and independent variables, the rest of the variables that are present in our data set. So we'll use this particular function rpart to create a classification and regression tree, and we'll store the modeling card model, and after that we'll plot the card model. So this is our model looks like. This is a decision tree that our model will use to classify different samples based on the legitimate cases and the fraud cases. So now let's predict on top of the test set and see what is the classification or the misclassification rate. So we'll use the same predict method, and then we'll call the card. In the predict function, we'll mention the first argument as our model, that is our card model, and then we're predicting on the test data. So here also I have excluded the first column. So if you want to exclude the first column of the test data, you can write this. So here it will include all the rows and it will not include the first column, that is our time column of the test data. This is our test data, how it looks like. So if you want to exclude this particular column, because we are not going to predict using this column, so you can write -1 here, and after that we have to write type equals class. So it will predict classes for each sample, so either it will be 0 or 1. So now we have predicted the classes of the test data using our model that was built on the original trained data without using smooth. Now let's look at the confusion matrix. So now if you now look at the confusion matrix, you can see that our true negatives is 6. So out of the 9 samples, we are only able to classify 6 samples if we use the data set that we have, that is our trained data, without using the smooth. So now let's compare these two models using the whole data. So now instead of predicting on the test data, we'll predict on whole of the data set, and that will show us how many samples will be correctly classified by a model that was built on smooth and by a model that was built on the original data, that is unbalanced data. So first let's build our model that was built on the credits mode. So this will be our model that we built on the credits mode. Now let's predict on the whole credit card dataset that will contain all the values. So we'll exclude the first column, and then we'll predict the classes, and we'll store the predictions in predict val. And after storing the predictions, let's see the confusion matrix. So in this confusion matrix, out of the 44 samples that we had in our dataset, 40 fraud cases were correctly classified by using the smooth data, or the model that was built on this smooth data, because our true negatives is 1. So these are the samples that was the transactions that were actually fake transactions, 1, and our model has also predicted that these transactions are fake. So out of 44, 40 transactions were actually correctly classified. And now let's build the same model using the model that was built on the trained data, or the original data, without the balancing factor or this mode. After creating this data that is built on the original data set that is unbalanced, and now let's predict on the top of the whole data set. And now if you build the confusion matrix, so you will see that we have only 35 right now. So we have using this mode, we can easily detect 5 more samples than we can detect using the unbalanced data set. So that is why using smooth is preferable, because it balances the data set first, and then it predicts. So you can easily see we are able to classify more fraud cases using the smooth, which is 40, instead of using the original data set that we have, which is unbalanced.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer, so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry, and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees, so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course, where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'll have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary. And we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run. And we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2 and house number 3 are our real world entities which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name. And after this, I will get the name. and this self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object, right? And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard, right? So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be get age. Again, I'll pass in self inside this, right? This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again, right? So we have created two get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly I'll create another method which would be put age and I'll pass in self inside this. So for this it would be print of your age is, let me again put in double quotes over here, right? So your age is, it would be self.age. So we have created our class where we have two variables, name and age, and I've created 4 methods, and out of those, from those 2 methods I'll be getting the name and age of the person, and the rest of the 2 methods would help me to print the name and age of the person, right? I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the get name and get age methods. So person1 dot get name. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam, right? So now it's time to get the age of the person. So I'll type in person1 dot get age. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name, right? So your age is 28 and your name is Sam, right? So we have successfully created our class which would print out the name of the person and the age of the person, right? So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method, right? So we have created our init method, which is basically a constructor, and going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this we have age, so let me change this to be age over here, and this would be self.age. After this we'll have to print in the branch, so let me just put in branch over here, and this would be self.branch. Right, so we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use the super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3. And the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array, which comprises of 1, 2, 3, 4, 5, and 6. So this time we'd have to initialize a 5 cross 5 NumPy array comprising of all the zeros. So it's a 5 cross 5 NumPy array, that is, there need to be 5 rows, 5 columns, and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the NumPy library. Let me just type in import NumPy as np, and inside a, I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out a. So we have successfully created our 5 cross 5 NumPy array where all of the values are just zeros. Now let's say we have two NumPy arrays like this. So this is our first NumPy array, this is our second NumPy array. First NumPy array comprised of 1, 2, and 3. Second NumPy array comprised of 4, 5, and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7, and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the NumPy library, import NumPy as np. I will go ahead and create my first NumPy array, a equals np.array. And the values are 1, 2, and 3. Similarly, I'll create my second NumPy array, which is b. I'll change this variable to be equal to b, and the values are 4, 5, and 6. Now, to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the NumPy arrays, which I'd have to add. So I want to add a and b, and I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2, and 6 plus 3. Right? And this is what we have. 4 plus 1 is 5, 5 plus 2 is 7, and 6 plus 3 is 9. Now let me actually change the axis value to be 1, and let's see what do we get. Right? So when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a NumPy array. So this is our NumPy array over here. And this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5, and 68. And I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again, we'll start off by importing the NumPy array, import NumPy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our NumPy array. Let me just print in X over here. So this is our NumPy array. Now what I'll do is I'll just copy this np.argsort of X, and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68, and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this, and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this NumPy array. So 100 and 68 are the two highest values from this NumPy array. So now we'd have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as PD. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4, and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24, and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprised of apple, mango, and orange, and the count of the fruits is 12, 24, and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width, and species. Now out of this we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as PD, and after this, to load a CSV file, I'd have to use the pd.readcsv function, and I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this dataset. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal dot width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we give in the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with nen values. So I'll start off by loading the required packages, which would be pandas and numpy. So import pandas as pd and import numpy as np. After this, I'll load the iris dataset. So iris equal to pd dot read csv, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce nan values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column and the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the nan values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame, and with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readcsv function. And I'll give in the name of the file, which is enhance.csv, and I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right? So we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here, right? So this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in 2 parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda and then you'll give in all of your arguments. After that, you'll put in a colon and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda and I'll give the name of the variable to be a. I'll give a colon and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is how we can create a simple lambda function. Now, I'll call the function and pass in a number. So let's say I'll pass in 8. Now, this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the Matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the NumPy package. So I'll type in import NumPy as np, and I would also need the Matplotlib package. So I'll type in from Matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt.plot, and I'll pass in x, comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt.x label. So the label would be x-axis. Similarly, plt.y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt.title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the Matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange. And we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From Matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that we have banana, and the cost of banana is 20. After that we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data dot keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data dot values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list. Right. So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop, and it will iterate through all of the characters in this string, and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0, and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string, it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this NumPy array to -1. Right, so this is our NumPy array which comprises of the numbers from 0 to 9. and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the NumPy library, import NumPy as NP. After this, what I have to do is create my NumPy array. So ARR equals np.arange, and it will go from 0 to 10. Let me just print out this NumPy array over here. This is my NumPy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So ARR percentage 2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly, over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right? So the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'd have to perform an operation so that we get the common items between two NumPy arrays. This is our first NumPy array. This is our second NumPy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first NumPy array and I'm storing it in A. This is my second NumPy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two NumPy arrays inside this as the parameters. So A, comma B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb, so we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as pd. Now I'll create the series pd.series, and I'll pass in the values, which are basically Mary had little lamb. Right, so this is done, and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now. Right, so this is my pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L, and L needs to be capital. Right. And as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here. Right, so all of these elements have been converted into title case. So now we have the same pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3, and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this pandas series. import pandas as PD. Let me again create the series ser equals pd dot series, and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this panda series, I'll have to use the map method. So ser dot map, and inside this I'll again create a new lambda function lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In hat there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s underscore length. Let me load the package, import pandas as pd, and I'll also load the file. So pd dot read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here, I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s underscore length. So it'll be s underscore length. So this is how it goes. So iris dot rename, and the original column name is sepal dot length, and I'd have to change it to s underscore length, and I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1 dot head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the pandas library, import pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection, So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features, and then I'd have to pass in the target. So x comma y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in xtrain, xtest, ytrain and ytest. So xtrain would comprise of all of the training values or all of the training records for the features, and xtest is basically the test set for the features. Ytrain is the train set for the target, and ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor, and I will fit this model on top of xtrain and ytrain, or in other words, I'm fitting the model on top of the train set. Alright, so now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x underscore test, and I'll store this in y underscore pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics dot mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the NumPy library over here. I'll type in import NumPy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start off by loading the requisite packages, which are NumPy and pandas. So import NumPy as np and import pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv, and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal length, petal width, and the species column. Now out of this, the species column is our dependent variable, and these four columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first four columns. So I'll just extract sepal length, sepal width, petal length and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame, and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'd have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set, and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics and we'll also get the accuracy score. Right. So this is my confusion metrics and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same and it comes out to be 91.11.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So guys, we have come to the end of the session. Hope you all enjoy the session very much. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.